Chicago. Yeah, I love the enthusiasm.
Yes!
For those who don't know me, I'm Andy Randall, and with me?
I'm Benazir Khan.
Yeah. So together we've been part of the organizing team for this event. Just wanted to go through a few details with you today. In fact, this is our 8th ever Cloud Native Rejekts. Hard to believe. If this is working?
Yes, I think so.
This was working? Okay. I will just do this then. I apologize. Let's get this. So we started back in Barcelona, went through the pandemic and all of the trials and tribulations of the pandemic with a virtual rejects. Most recently Amsterdam, and here we are in Chicago. So what are we seeing? What are we seeing here today? So Rejekts started on the premise that there were all these talks that got submitted to KubeCon that were great, but got rejected. So we needed to provide a forum for them. Well, I'm afraid things have moved on a bit, and there's a whole load of talks that get submitted to Rejekts that are also great and don't all get in.
Yeah.
So
it's true.
one of you has to go found the rejects of rejects, but we're not doing that. We've got 48 talks from 62 speakers here, out of well over 100 proposals. This is really exciting. We've got nearly 200 attendees registered, which makes it the largest rejects we've ever held in North America. I think Amsterdam was slightly larger. This is just a chart to visualize that. It says 100,000, it's meant to be 10,000. But basically, we are, so one way of looking at this is only the craziest people come to rejects. Another way of looking at it is we are the top 2%. And I really do think, those of us who are here, if you think you've got a whole week of KubeCon ahead of you, and you choose to come and spend the weekend in advance, doing more conference sessions, meeting more people, you have to be pretty damn passionate. This is an amazing crowd, and I just love being here with everyone. So Benazir, why don't you talk us through what we've got coming up?
I think we have an amazing schedule ahead for you. There are quite a few talks on security, observability, developer stories, and communities. We've made sure there's an equitable balance between all of these topics this time. And yes, as you can see, we begin at 9:40 today. 9:30 is the opening now with talks. There's a short break. There's a barista service right outside, which we hope you enjoy. It's up till 12:30. There is lunch, and Andy very kindly has written on your own, but it could be with all of you. Yeah, as in how you want to organize yourselves for lunch. And yes, we come back for more talks at 2. The lunch is I think it's plenty time. It's 1.5 hours, but we could stretch it to 2 sometimes, but this time it's 1.5. Yes, come back for more talks at 2, and we end at 6:10 today. And probably around 6:10 tomorrow with the lightning segment, but since it's very popular, as we hope this time it will be too, it should take us not more than 6:30, and that's how we end day 2. For the lightning talks, there's a whiteboard outside. Please feel free to sign up. We still have a few slots left. What else? I think that's about it. Yes.
Clocks.
Yes, clocks, yes. So time turns back tomorrow by an hour, and this is something that we just realized yesterday. We're used to the daylight savings even in Europe, but yeah, good to inform everyone that you have 1 extra hour of sleep and rest before you come back for Rejekts Day 2. Yeah.
It's good on a Sunday morning.
Yeah. The COVID situation, we're in an endemic situation right now. It's not a pandemic anymore. Even so, if there's anyone who's a little uncomfortable with distance or just wants to inform everyone else, we have wristbands out at the registration. Feel free to choose your color. There's masks too, optional, but if you want to and feel safer that way, go for a mask. Yeah. Be kind, be respectful. I know it's a given, and we're all that way. But if you do feel like there's a situation that you want to talk about, approach one of the organizers, either Andy or me, Lexi here. Yeah. thank you to our sponsors. Big, big thank you. Goes without saying. Yeah. Azure, SUSE, Solo, Illotl, Isovalent, Tailscale, KubeSimplifier, Cast, and the new stack. Thank you all. Thank you to all of our sponsors. They've been very, very supportive, and we couldn't have possibly pulled this off without them. Trust me. So big, big thank you to them.
And if you work at a company with a marketing budget,
yes, yes,
there'll be another Rejekts opportunity in the future.
Absolutely. Yeah. That's a cool segue, thank you. Big, big thank you, and very, very welcome to Rejekts, the 8th Rejekts that's happening here. And yeah, we look forward to networking, chatting, and making new friends, and meeting old ones.
Yeah, talking of old friends, it's my pleasure to introduce our first speaker. I've known Justin for quite a while now, and a lot of you will know him for a lot of the really kind of groundbreaking foundational work he's done in various areas of Linux security, and he's now a CTO at Docker and has been focusing a lot on supply chain security. It's a very hot topic, and I know he's got some super interesting thoughts to share. And so with that, I will hand over to Justin Cormack of Docker. Please go ahead.
Weirdly, I've not actually been to Rejekts before, despite there being 8 of them, and despite every time I come to KubeCon, I kind of run into Andy and people saying how nice Rejekts is, and like, oh yeah, why didn't I come 2 days earlier, like all of you lot? So really nice to be here. Also kind of nice to be up first, given I'm slightly jet lagged, having just arrived from Europe. So it's nice to. I think originally I was on Sunday, and I was like, oh, actually, yeah. Speaking first thing. It's nice. As Andy said, I'm the CTO at Docker. I've been at Docker for a long time now, 8 years or so, maybe. I'm also on the CNCF Technical Oversight Committee, so involved, a lot in what's going on in CNCF and the projects there, and I'm going to talk about a bunch of those things today. So I've been involved in supply chain security for quite a few years now. I wasn't originally a security person, but I always had an interest in security, and I kind of moved into security full-time for a bit at Docker some years ago, and Docker's always been involved in supply chain security. We donated the Notary project originally many years ago to CNCF, and really spent quite a long time discovering what the problems with that were, talking to customers about what's important to them in supply chain security, and obviously, over the last few years, it's gone from what's that to, oh yes, it is important to us, and we need help, and so it's become a really interesting, kind of important area, and there's been a lot of innovation going on in this space, but I think it's also kind of exciting because there's still lots of work to do. It's still a really new space. There's lots more people involved, so it's great. There's lots of ideas, collaboration, and working together. So it's really really nice space. I'll talk about some of the things that are going on today in this talk, but it's quite a narrow focus on attestations. There's lots of things I won't talk about, but I'm happy to talk about them, in questions and things as well. But this talk is really trying to kind of explain my thinking about supply chain and why, and the kind of way I think about it now from really from having a lot of conversation with customers, a lot of thinking about what we're trying to do here. So I'm going to talk about attestations, and an attestation, like the sort of definition, is an official verification of something that is true or authentic. I put these pictures in. Usually, there's a lot of supply chain talks. We talk about things like, tamper-proof things and medical things. I decided to go for some more kind of weird things. So there's a Dutch woman who makes artificial flowers for bees, and she and I came across these. They're kind of quite cute. You have to actually persuade bees quite carefully that they look like flowers, because bees have weird eyesight that can only see certain. They can see ultraviolet, I think. Anyway, and so they have these patterns that make them think it's a flower, and then you basically put sugar in them, and they can actually treat them like normal flowers. But they're not kind of authentically flowers, so I decided to use those as a kind of model of things today. And so supply chain attestations are something we started having a while ago, and they're basically, just information about the thing that you're using. So in this case, like, what kind of flower is it that the bee is sitting on? Who made it? If it's an artificial one, what kind of flower is it? If it's a real flower, and of course, the kind of question the bee might ask is, if it gives me honey, why do I care? But obviously, we know that supply chain security is important because there are hostile actors out there. There are people who might make flowers that are, not pleasant to eat. And also, we kind of need to, we've kind of learned about, from the kind of supply chain security issues there've been, that we need to understand about, repeatability, traceability, reproducibility, understandability. We've had big security incidents like SolarWinds, where there have been direct supply chain attacks where someone has gone and modified something that you're consuming to be hostile, either to you or to downstream people from you, and so on. And so we really have discovered that we need to know more about the objects that we're building, and so we can and using and consuming every day to build our software and to use and to deploy. So we actually need to understand more about about these flowers or whatever objects that we're using. Need to understand what they're made from. We need to understand if much more detail about the internals of them and so on. And I think one of the things that I think has become clear to me, particularly just talking to people about what they need from supply chain security, is that actually this piece about understanding more about the software and understanding about its composition and how it was made and how trustable it is the kind of the most important piece for them. And a lot of the focus, kind of has been on other kind of aspects, like whether things have been, the focus on delivery. So, for example, the original Notary project was basically an implementation of TUF, and TUF is a way of actually getting secure software updates sort of on an end-to-end process, but it doesn't tell you anything about the software that's actually, it gives you an update process, but doesn't tell you about what the thing is that's being updated. And I think that one of the things we learned is the most important concern people have is actually what's the thing that I'm getting. And the update process is potentially important, but the what is it piece is really, 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 really important. It's like, well, I've got this bit of software, it's a nice secure update, but is it hostile? And so I think that's why I've really kind of started thinking, a lot more about the attestation piece. And in particular, the Intoto project, which is a CNCF project, came out of originally the same team as the TUF project, originally NYU, Justin Kapos' team, and Santiago, who's at Purdue, is the project leader, but it came out of his work with Justin Kapos, and it's basically, it's answering this kind of second question about, well, so what's in the stuff? How can I understand more about it? How can I understand how it was built and everything about where it came from? And so essentially, Intoto is really an extensible metadata standard about, and we'll go into more detail about it. And again, it's like, this quote here is really what I was saying about, like, TUF is a last mile security about software updates, and they provide integrity and authentication, but it's, as I said, it's possible that by the time, you're updating it, it's already been compromised. And so you really need to go further back. And you need to go kind of, back to like, what was this built from? How was it built? Was the build process secure or not? And all those kinds of questions. And so those are the kind of questions that attestations are there to try and answer. To give a more kind of concrete example, I'm going to talk about Witness from TestifySec. So, hello, TestifySec. TestifySec has a couple of projects which are all, they're planning to join the Intoto project as official sub-projects at some point soon. And so Witness is, was, I think, probably the first, the first kind of open source project about collecting attestations, and it's a good project to look at to understand, like, what you can do easily. It's a great, it's a great starting point. It's pluggable, and it's got all sorts of things. So, and it gives you an idea of, what you can do with attestations, and as well as concrete code for actually doing that with attestations. So, it's got a whole set of attesters, which kind of in a sort of sequence. They start with you have a series of steps in the Intoto model of like what happened to the things in the supply chain, and you can go, if you're thinking about like how you build a piece of software. There's a lot of stages of building software. At the moment, Witness is mainly about collecting information around the build process. There's actually work in Intoto about going even further back into like, and I think these things are also kind of interesting about like what happened even before that. So the process of building software starts with a blank text editor, and you start to write some code, and you can potentially even make attestations about that process. And there is some work on that as well, and like what's happening on the developer workstation, and like what's happening when you actually write code, which is kind of interesting too. We're not going to talk about that so much today, but Witness is mainly at the moment has attesters around the build process. And so if you think about something like, you're going through something like GitHub Actions or Circle CI, and you want to, or any of the, GitLab or anything like that, and you have a set of steps that your software goes through, and you want to collect information to demonstrate that it went through those steps. We'll talk about exactly how that gives you kind of reassurance later. But so, first of all, there's these pre-material attesters, like where did the step run? So it ran in AWS or GitLab. Like this is, if you want to understand, like, is this the official version of the software that was built in the official process? Well, the official process is we build our software in GitLab, and so you want to make sure it was run in GitLab. So there's attesters for that. there's material, so what files did this use? What was the source code that this was built from? So basically file hashes of the source files. There's execution attesters, like what happened when the build process ran. So Windows has a ptrace framework that will tell you like what the system calls that happened while the build was happening. So you can see like what exactly went on, where the network was, what happened on the network, and what happened to the file system. And then you can see from the file system ptrace, you can see what files were created during the build, and then you can look at the hashes of those. So those are your output files. And then what final artifacts were created. So say you're building a container, you take a bunch of the files and you package them up into this container, so you can attest for the hash of the container. So you can see that there's these are the kind of groups of attesters that come with Witness now, but you can add kind of more, and you can kind of see that kind of model of thinking about like what happened, how do I record this, and using that to get reassurance. So the data model for in toto is this set of what they call links, which form a chain, a supply chain, and each one basically is a you take a hash, you say what the action was, and then there's an output, an output hash. So what came in, what did I do, what came out, and then the stuff that came out is the input to the next step in the supply chain. So there's a kind of sequence of hash chain, and we'll talk about what you expect from the the layout piece later on. So that's the kind of model of that. So kind of more abstractly, there's a predicate relation between subject and an object. Again, input hash, output hash. So it's a Merkle tree. You can also, you also think of, we end up using Merkle trees in an awful lot of security stuff. It's actually a really powerful abstraction. Git is a Merkle tree, and you can think of these things as really looking a bit like a commit. There's a previous input state, there's a new state, and there's a commit that joins them together. So it's again the same structure from hashes to hashes. OCI registries are also basically Merkle trees. They have the same structure of hashes and documents that join them together, and they tend to be used less like a relation at the moment. But that's kind of just we'll talk about that more later. But this structure is really very sort of simple structure in a way. Once you think of it as like input, what I'm did, output, hash, tree, or DAG. There was great, this picture I put here because I was reading on the plane. There was this great article about a stolen painting and the weird history it went through. It's in the FT, I highly recommend it. But so this painting was stolen and resold, and a large number of times since it disappeared in Poland in the First World War, I think? Oh, Second World War, I think. No, Second World, yeah. And it kept reappearing in various places and being sold and having this very murky provenance and weird sort of legal status, where in some countries if you own something long enough it becomes yours, even if it was stolen, but in other countries that's not true, and people kind of didn't say where it came from and ignored the fact it had a museum stamp on the back of it from a museum who had very complicated kind of, this kind of set of steps that things go through in their lifetime. There's, as we said, like, there's an expectations. You have an expectation that your source code starts, we keep our source code for this project in GitHub, we build it with GitHub Actions, and then we push it into this registry, and that's where you consume it from. It's these expectations, expected steps that you want to trace in order to understand if this is really the thing you think it should be. So, concretely, like the Docker official images, we keep the source code for them in github.com/Docker library, the GitHub org. We build them in our AWS account. We use the Docker files in the base repo as the instructions to build them, and then we push them to Docker Hub, or you can consume them from other places. And that's a kind of documented process, and that's what we want to attest to. And then the question is, how can you trust this attestation? Because obviously, if someone was trying to fake this, they might just say, this is exactly what happened. It went through this process. And it's like, how do you know? Often, like, signatures are discussed as a way of helping this. But I think one of the things about signatures are often, like, the way in which signatures are used is usually like a person signs something saying, yeah, this is good. Justin says, I can sign a container and say, I built, this is good. This is the Docker official image for Alpine, or probably the team would sign it. But how do you, as a person, how do I know what went on in the computer? Like, I can kind of assume that it went through the right process, but even I don't really know. And computers are kind of very opaque to us. And so part of the thing is really to get away from, like, person thinks the process was good, because, like, in SolarWinds, person thought the process was probably okay. And to really get inside with these attestations and see what really went on inside the computer. And that's kind of hard in some ways, but easy in other ways. We'll kind of talk about how this works. It's really about evidence. When you're, how do you trust evidence? Can you check it? If you imagine a court case or a kind of retro where you're trying to understand, like, is this piece of software good? You want to collect a lot of evidence that all points in the same direction, gives you reassurance, and you want to look at the things that are anomalous, see if they're explainable or an indication of compromise, and look for a pattern of evidence reinforcing that things were doing what was expected. So if you think about, like, a build process or the kind of things that we do when we're building software, sometimes you can check things ex post. You can, like, I put this picture in because I like that. These are computers. This is the Women's Army Corps doing their computations for the Manhattan Project. You can check your calculations. Like, if it's something, a piece of math, you can check it, and it might take you a long time to check it, but you've got that ability, and you can do that with some bits of code, and that's actually kind of useful sometimes. So reproducible builds are a great example. There's like, so if you have a reproducible build process, then you can go and try it yourself and see if it gets the same output. And there's like, then you can be fairly confident that that was the set of inputs that were used, and you got those outputs, and you'd be fairly happy. It might take a long time, and you might really want to build a process of multiple independent builders and people checking. The Persia project that JFrog and us are doing is that's one of its outputs. One of its aims is to have a set of multiple trusted builders to check things. I think reproducible builds have been hard, and people have kind of gradually been building up to doing that. But I think it's a really valuable piece of tech that can help you understand and verify and do the go back and check it thing. You can often, like, if it's not necessarily a build, but it's some other part of a process that you want to check, sometimes those things are reproducible. Sometimes you can, if you want to check, someone's given you an SBOM, you want to, and it came out of, out of a particular SBOM generation program, you can rerun that if you have the same data set, the same version of the code. And you can, so sometimes there's additional metadata that's reproducible. Sometimes you need to make sure you have the state of the input of the code at the right time as well. So keeping all the data that you use to actually do the things you want to check, keeping them in a data store so you can reproduce it is kind of helpful as well. But some things are kind of hard to check. We spent a bit of time, actually, Ilya, who's here, did this work a while ago, and we kind of didn't quite finish it, and we should release the bits we did, actually. But talk to Ilya about this. But we spent a bunch of time checking, like, for Docker official images, many of the packages in them come from upstream Linux distros, and we're like, well, if you say I installed these packages, how can I go back and check it from the package manager? And it's kind of doable. It's kind of bits of it are easy, bits of it, well, not easy, but difficult. Things like post-install scripts in package managers are really annoying because they just run arbitrary code and you don't really know what they output. But actually, in practice, they do a more limited range of things, and you can run them once and see what kind of thing they do. But you can actually spend a bunch of time working out, like, yes, that SBOM does correspond to the packages that were installed. I've been talking too much. It's got 5 minutes. So that's one thing. I talked to you about that. OIDC is really valuable. So many endpoints give you an OIDC output that tells you a lot of things about the code. So GitHub Actions is a good one. You can get a signed state JWT from GitHub that tells you repo, branch, hash. Gives you a lot of confidence about that something happened in GitHub Actions. How do we record this? So this is something that we've been working on with OpenPubkey, which is a new open source project from Docker and Bastion Zero that we launched a few weeks ago. OpenPubkey is there's a bunch of stuff on it in the repo, but it turns JWTs from bearer tokens into certificates by binding a public key into them. And you can then sign with this public key to demonstrate that you had possession of the JWT. And so you can capture that information in JWT in a way that you can sign it and it can't just be copied by someone else who had access to it. Some people being nervous about sharing a full JWT, so we added a zero-knowledge proof framework around this, so you could prove that you had possession of bits of the JWT that had the interesting metadata from that JWT. This is the architecture, really. I'm not going to go through that. There's more information about OpenPubkey there, but so we're basically using it to record the validated JWT, so you can validate that something went through any kind of process that gives you an OIDC, basically what's now a certificate from there. So that's kind of cool. TPMs also give you this kind of structure of signed attestations of what code was running, which are pretty cool. People are not using them much, and it's kind of messy. But there's a lot of opportunity, I think, to use these as well to demonstrate, like, this is the code that I ran in order to do this build, and again, get a signed attestation from, for example, AWS Nitro will give you signed attestations, including the whole kernel. Then we have an area that, how do we know what the process should have been? I told you what the Docker official image process is, but actually, like, how do I tell you that officially? So Tato has a concept of the layout for this. This is like what should happen, and it's signed, and you can distribute those again through TUF, which is our plan for the Docker official image work. When you have attestations, you have lots of data. How do you query it? You can query the documents and use a kind of document-focused approach. Both Docker internally with Docker Scout and Testify.sec with Archivista have actually built a kind of graph database model that's you can sit and run queries on. So Docker Scout we use Datalog, and for example, whenever anything changes, you can basically get a notification of any policy violation or that's changed when you change your data. Both of them have GraphQL APIs. I think there's a lot of interesting standardization work in that. Overall, this is a really zero trust approach. You don't trust an object because of what it is. You trust it because of the attestations and the information in that. And so it really fits with the whole kind of zero trust model we've been getting elsewhere. And so overall, I think like evidence of what supply chain processes are is really important. Attestations are a way of basically collecting this evidence and building out this infrastructure, and I think this is really kind of core structural way that we can help understand like the questions that really the customers have been asking about is, you know, what actually is in this code that I've got from somewhere else? You know, what are the ways I can verify it? And you can, as well as telling people what's in it, I think this process of how much can you verify the information you've got is the really key thing, because otherwise the attestations could be faked as much as the code you're getting. So you need to be able to have ways to add this extra trust into and verification layer into it. And so I think this is really the way I've been sort of thinking about how this stuff should work. This is all kind of really, you know, I think we're very early in this journey. I think we're still exploring it. I think that, you know, but I think this is really where, you know, a lot of the direction that really helps answer the questions that people are really asking goes. Thanks very much.
Hi, we have some minutes if anyone has questions for Justin.
You mentioned this project in Toto, right?
Yeah.
Maybe I missed it. Are you involved in it, like a maintainer? Or?
No, I'm not a maintainer.
Okay, you just mentioned it.
But I mean, I've been, you know, kind of working with them for a long time. I did the CNCF review for incubation for it, and I've known that because I've worked with the Tough team, who have a lot of overlap. I've been working with them for many years on this because we started working with the Tough team like 8 years ago or something like that. So I've kind of been involved in it growing up and coming through CNCF and
Right. Actually, I wanted to ask also, maybe you know where the name comes from for in Toto?
That's a good question. I'm actually not sure. I think the wholeness of it, but it's also weirdly, randomly, the name of a kitchen supply store in the UK, which I don't think it's come from that. I was going down the street once in Cambridge and I was like, there's a shop called Toto here.
Okay, thanks. Probably need to ask the creators of the project. Thank you.
You talked about a lot of attestation, like what it will look like and things like that. But when you're doing attestation, like who attests the software that's doing attestation?
Yeah.
And where does it stop?
That's the kind of, there's this whole kind of concept of the software factory that's come from the US Department of Defense model. Like, you have to do this for everything. And yes, there's a kind of circularity problem that you've got to start with something that you trust, but there's actually a bunch of techniques you can use to kind of potentially bootstrap. But I think but you want to try, in theory, in an ideal world, you want to try and do this kind of almost recursively for everything, but you obviously have to start with something. But it is a difficult problem, the bootstrap problem with this, and but being able to reproduce the whole of your entire factory is actually really important in the end, because you've got to build it up from, like, do I have a trusted pipeline? Do I trust the software that deploys the pipeline? You know, there's a lot, you know, I think we have to kind of add trust throughout this whole thing. But it is definitely a, you know, kind of bootstrapping problem as well. And so there's definitely, you know, there's definitely work to do to try and do that. But I mean, I think a lot of it's not about, is it right? It's about what degree of trust do I have? And, you know, we have external things, you know, we mostly trust like Debian and Red Hat to produce good base software that we then can bootstrap the next piece off and so on. So it's not, like, you don't have to have all the evidence for everything. And I think there isn't even a fixed, I don't think there's a fixed set of attestations evidence that you need. It's like the more things you have that you can verify, the happier you are, and the more likely you are to catch any issues. And so, you know, you don't have to like have a perfect system to get started.
To follow up on that, like you mentioned about TPMs, right? So if we assume for any computing, like distributed system, if we assume like machine, like a computer being a single unit of compute, and then you attest that using TPM, and then you extend it to VMs, and then VMs do the same thing inside, and then, you know, we can have some system like that, maybe, I don't know.
Yeah, I mean, I think, you know, I think that, I mean, I think there's, you know, that there are also, I mean, I think that part of the thing about the OIDC thing and why it's so interesting is, like, there are people we trust. Like, you generally trust your cloud provider. You generally trust, you know, GitHub Action, for example. If these things were, you know that these people have strong security teams who are working on stuff, and if they're compromised, you could potentially, you know, you probably hear about it, and you can kind of work backwards if there was an issue. But in general, you've got a lot of trust in certain things behaving the way they say they're going to, and I think that's why I think the OIDC kind of JWT attestation stuff is really useful, because you can say there are these parts of the process I trust, and I can use that trust to bootstrap more trust, and I can be happy that my thing's going through that. Because if you don't trust your cloud provider, then why are you using them in the first place? It's like, if you think they're going to kind of they're going to be the source of compromise. So I think there's I think part of it is like taking the bits where we have got trust and using that to bootstrap kind of more of a chain across everywhere else. And I think that we're seeing more and more of kind of, you know, OIDC and things being used as a way to do things like cross-cloud authentication, like get your GitHub Actions to run some code in AWS, because you trust that process. And so I think we're tying more of these things together like that anyway.
Okay, sorry, we have more time for questions. If anyone wants to meet Justin outside, sorry, we have to move on to. Thank you so much, Justin.
Thanks a lot. All right, today I'm going to talk about building your own APM. For the last 12 months, constantly I've been hearing about people talking about the pain of running Datadog and sort of the costs associated with it. So at Last9, we built tools for solving software reliability, and this is a common concern that a lot of customers come and talk to us about. And in that context, I thought it would be fun to talk about what would it look like to leverage some of the existing tools that we already have in our systems and be able to leverage that to build something like an APM. We all deal with Kubernetes, so change is a constant in that context. Number of microservices or subsystems is constantly growing across the company, and the number of times we deploy them is at least more than 5 times a week. And the dependencies, like earlier, I think Justin was also talking in terms of the supply chain and just everything, and internal and external dependencies is only exploding with at least 3 internal or probably more. It's almost like a web within our production system itself. It's almost similar to the internet where there are so many dependencies. And when thinking about monitoring or observability in this context, it's always interesting how we sort of dissect it. We talk a lot about, let's say, MELT, right? Metrics, events, logs, and traces. But to take a step back from that, I think about them slightly as these 2 systems that we need to think about. One, a radar system, essentially something that's low latency, real time. You want to be able to observe it in a way that talks about the system as it is right now, more than how it behaved in the past, to be able to respond to it extremely quickly. All incident management and response essentially has to deal with being able to recover quickly rather than go and solve the problem critically in that context, which is very similar to a radar system, which lends itself really well to being able to use metrics because their low latency can be stored efficiently and queried quickly, along with the alerting nature of it. A lot of logs and traces essentially then lend themselves amazingly well to being able to debug what's happening with the system. Classically like a black box, right? And how we treat those systems as. It's not that it's not important in that point in time, even if the latent availability of that data or out of order is absolutely okay, but not so much with real-time systems as a radar would. And I realized while looking for images for a black box, turns out black boxes actually are not black boxes, but they are actually quite fluorescent in color to make sure that they're actually found when something goes wrong and are recoverable. So that's something was very interesting to know about. Anyways, a typical journey, what I've seen consistently talking to so many people, and I'm sure you guys resonate with this, is the fact that we all start with something like a CloudWatch. Basic, gets the job done. But soon with applications being deployed or serverless architecture, you go and sort of look at some application monitoring, because our stack typically looks like a burger, is what I talk about. There are 2 patties where essentially off-the-shelf components like a load balancer or database is something that we are using off the shelf. But application is where the patty is for each business, where we're essentially writing our own code to make sure it gets written in a way that is special to us or to the processes we're automating or the services that we're offering. And in that context, we go on from, let's say, using CloudWatch to then developers also using something like a Datadog or a New Relic. Costs grow up, other challenges start rising, and then the platform teams decide, you know what, we could very well run this on a Prometheus. And then you have Prometheus as well, where you start moving infrastructure metrics, and then suddenly you have 3 systems, but all being visualized through a Grafana, because that's a unifying visualization layer that brings it all together. And more often than not, this disparate nature of it leads to a lot of challenges, right? There's telemetry upkeep, there's lack of control in terms of instrumentation, standardization across dashboards or alert fatigue, because alerts now are being thrown through across 3 different systems rather than just one, which means there's constant pain in terms of being able to make sure that the toil reduces rather than being able to act on it. And yes, cost definitely keeps coming back to being able to maintain these disparate systems and then justify the cost that we're spending against it. So what would a typical system to be able to solve for this in-house look like, right? Yes, there is the melt stack and other things, but what if we could sort of leverage Prometheus in a way to be able to use our application data in fact, to be able to look at that application metrics and do some level of APM, which would mean we could use our existing deployments of Prometheus or Victoria metrics or similar high cardinality stores to be able to leverage some of this data. It would help solve a lot of challenges, right? With Prometheus compatibility, the only thing missing consistently I see across this landscape is the agent libraries that allow you to instrument this off the shelf in a way that would allow you to leverage this and then make sure you can standardize the alerting, standardize dashboards on Grafana. Because the whole power of a closed system like a Datadog or a Neuralink in that context would be the fact that across these frameworks, dashboard alerting and the user experience is amazingly well done. And being able to replicate that becomes quite a big challenge. But what would it look like essentially from a dissection of being able to actually leverage something like this? I think from an anatomy of a monitoring system, there are several stages. Yes, begins with instrumentation, but there's also ingestion controls, whether handling cardinality or shaping and sort of load balancing and other aspects around it, or pre-aggregations, or even streaming aggregations for that matter. Or something like storage with different data formats, being able to optimize on that, and then deciding on a query language. So whether you're taking any stack for these signals, there are these components involved. If you look at trace, then you would have something like a tempo, a trace QL for query language, an alerting mechanism on top of it, and then ingestion controls as well. So across stack, you would end up having these 5 different components to leverage to make and use them. In an existing system like ours, for now being able to do this APM, we could leverage these existing stuff that we have in our infrastructure across storage, query language, again, alerting and visualization. Visualization could come through Grafana because we already have that running. Alerting could be an alert manager or Grafana alerting. Query language like PromQL and storage, again, a Prometheus. What would this look like? We'll go into this. But before specifically in this context, if you go and sort of check this project out, it's called OpenAPM Node.js. It is being done, one for Node.js. There are several other variations of this also available, where it is a drop-in replacement where you could just go and say, require express and then use the red middleware. Red essentially being rate, errors, and durations. And being able to use that middleware means it's actually intercepting all requests that are coming to the Node.js application and is able to emit those metrics in a way that are leveraged. That allows you to sort of standardize that experience. And if I go and sort of show you that quickly, this is leveraging the standard open instrumentation, open telemetry data to be able to leverage and build this out. And in a way, also capture database queries to a MySQL to intercept that and emit it as metrics across a database. So at the end, you could not just have standard error metrics being available along with throughput, error rates, and the AppDex score, but you would also have the latency and other metrics come through and be visible in this context. In addition, the database queries that I was talking about, where intercepting MySQL queries or other Postgres queries through that middleware, you'd be able to track and make sure that even Prometheus is able to load those queries through a PromQL interface. This is a working demo of that. Absolutely, I would request to go to this, just install it through NPM, and you should be able to try this out. In addition to doing all of this, it's key to be able to add certain other elements of this from an events to metrics correlation perspective, tracking application deployments, application lifecycle events. This is a work in progress for that open library, which will instrument it to be able to showcase that data and then emit it, and should be available soon. It is available across these frameworks today, across Node.js and Ruby, and we continue to build it for all other use cases in the context of frameworks that can emit it to existing Prometheus instances. That's pretty much. I'm happy to take questions and sort of answer anything in that regard that would help clarify this. Thank you.
Any question? Yeah.
So I think I'm still a little confused on what OpenAPM does. Like, is it like a wrapper around like the OpenTelemetry, like Node.js SDK? And like, does it auto instrument the metrics, or like, do you still have to like initialize it like you do for Prometheus?
No, you don't have to. So it's a layer on top of OpenTelemetry, you're right, which is specific for Node.js to make sure that the application data and the metrics are emitted with default Grafana templates as dashboards to make sure that they can just work off the box in a standardized way like your typical APM experience would.
Okay, cool. Done.
Any more question? Okay, then thank you so much,
All right,
Sean.
thank you.
And we'll start in 5 minutes next session. Thank you.
that number. I know it's small, but it's 2,000.
All right, how's everyone doing this morning?
24 vulnerabilities.
All right,
Exactly
lots of
the problem.
excitement.
Too many of them. What do you do?
It's really hard to get excited without coffee, so hopefully everybody's got a
that's what
chance
I'm gonna talk
to get some coffee, get warmed up. I see a lot of people with coffee. That's a good sign.
Too many of them.
So what I'm going to cover today is I'm going to talk about
you can
open source security, and I'm going to cover a range of different topics.
Based on
so just for my
that are
background,
publicly
I'm
available. Some
the
teams
VP
do
of
better
Developer
than
Relations
others,
at
but
JFrog.
that's about it.
Also, I sit on the open source security governance
Every
board.
year,
So I'm involved in a lot of the
more and more
OpenSSF
vulnerabilities.
initiatives, the new
More and more new
ONCDR5,
vulnerabilities.
which
So
we're putting in for the
in terms of the
recent government
percentage, that
issue.
number is going down.
And I think
so
that
it's a mission
the
impossible.
reason why we're all
Can't-
here is because
can't fix
now
them all.
security has become the job of everybody.
You need to have a
The
way to
job of
prioritize
developers,
what to
cloud
fix
native
and
developers,
what to
of
mitigate.
DevOps teams,
And
of folks who, of course,
You
are in
can't
security
simply
roles
fix
and
all
security offices.
highs and critical.
Who here is a
but it's
software
actually
developer,
something
cloud native
that
developer?
a lot of compliance
Okay.
frameworks
Quite a number of
tell
folks.
You
Who
know,
here is in
you
a
scan
security
your
research role or
containers,
security?
you find
okay, so
all
a few
highs
folks
and
who are
criticals.
security
You fix them.
researchers.
What's the
and
problem?
anybody from a DevOps team
If you look
doing
at
infrastructure?
all
Okay,
vulnerabilities,
so we have the full.
about 60%
Did I miss
of
anybody?
them are high and critical.
So I think we have the
That's
full
the
gamut
problem
of
with the
different
15%
folks
that you
covered.
can
And
actually
when
So it's
we're
just too
thinking about
many of
open
them
source
and-
security, I think
and you-
a good
that's
way
not a
or a
good
good
strategy.
analogy of thinking about security
So you need to
is
have another
comparing
way
it to food and the food supply chain.
Prioritize
So
and decide
you know,
what to fix.
when you're cooking, you want to start
And this
with
is
fresh
where
ingredients. You want to make
looking
sure
at
that you're getting
exploitability,
the very
usability,
best,
and
freshest
most
stuff
importantly,
for
the
your
environmental
restaurant.
information.
But what happens when you start with some spoiled ingredients or you don't have
But
good
before we
ingredients?
get
So
there,
this is
we
a
kinda
photo
need to
from
cover
Kitchen
few
Disasters.
fundamentals. in terms
Anybody a
of,
fan of watching Chef Ramsay
severity,
rip
for
apart
example.
restaurants?
Highs and critical.
So we
What
love
is it?
we love
What does it
watching the
represent?
disasters,
What does it mean?
which
What
unfold
does it-
before us, because that
where does it come
helps
from?
us forget how horrible our
Is
own
it any
lives and
good?
jobs are at times. And these are probably not the free-range chickens that you're looking for.
Now,
No.
with
So that
each-
we want to
if we
avoid
go back.
disasters like this in our software supply chain, where we're creating
vulnerability, when
software
you look
which
at
is
the
as
reports,
free from vulnerabilities,
they have
addressing the
a
vulnerabilities
severity.
quickly. And
low,
I
medium,
think what
high,
you need is
critical.
you need a healthy
That
supply chain or a healthy security supply
severity
chain to accomplish this. So
is a mapping
you know, this is the
from a
ideal
score.
picture from the U.S. Whatever.
And
US,
that score is calculated
FDA, I think?
using a formula. And
USDA,
there's
yeah. So that,
a lot
this
of
is their
problems with
ideal
it.
supply chain where
And,
everything
but the biggest
happens
problem with that
magically.
score is
You
that
get good fresh
it's
produce from the farm, and then it goes
usually
through distribution and
misunderstood and
processing
misused
plants, which are clean,
because
and it goes
it's
to
used as a
restaurants,
risk
which are
score
nothing like
to
the Chef
determine
Ramsay
whether or
restaurants.
not you
And
need to fix
you end up
vulnerabilities.
with a very
And you
clean
shouldn't
supply
use it
chain.
that
And
way. And
in
even the
open
people
source world, the
behind
equivalent of
CVSS
this would be
state that you need
if we
to
were
take
following good
that
practices like
score
SALSA, which is supply
that they
chain levels
provide
for
in the
software
results,
artifacts.
and that's actually
This
just
is one of the
one part of it.
OpenSSF
And
projects.
you need to augment
it's a
it
great
with the
way to
temporal
make sure
information,
that
and I'll
you're
go into
looking
more
at all the
later,
different possible
and the
entry points
environmental
for
information. And only
vulnerabilities,
then,
for malicious
you'll
packages,
get a
for
more appropriate score. And
different
their
things to enter
calculator
your supply
actually
chain
covers that, but
inadvertently.
nobody
And it
uses
goes
the
through a whole
calculator.
bunch of the different
Everybody just
steps
looks
where you
at the
may
base
have
score and they
vulnerabilities
say,
in your
it's critical,
application.
so it's the end of the world.
I
need
think
to fix
most
it
of us
tomorrow.
by now know that you have to be
Right,
careful
not the
about
case.
source code and source code reviews and making sure that you're doing all the things right with your own source code.
So
hopefully you know that
the
there's a lot
score
of
you
different
get and the
vectors for getting malicious
severity
packages into your supply chain.
represents
So it could be coming
only
from
this part,
from
the
NPM or
base
from
metrics,
PyPy
and
or
it
other
has
central
different
repositories.
types of submetrics.
But even then, you could get
represents
compromises
different
in your
properties
CI/CD
of the
system.
vulnerability.
You could have something which
And then
gets
you're supposed
injected
to
right before you sign
take
your build.
that
So there's a whole bunch
score,
of different
and then you augment
dependencies
it
and
with
threats
the
and
temporal
places where it
data.
can
And
enter the
the
supply
temporal
chain.
data
And when you're not
represents
following
the
these
information
best
about the
practices,
exploitability,
what you end up is with
exploit
disasters
availability,
like
proof of concepts,
this is an old
active
one, but a good
exploitation,
one. So
etc., and the
Equifax
remediation
data breach,
information as well.
it was a result of
but
one of the
That's not enough. You need to
Java
take
security
that and then
exploits,
augment it
that affected,
with the information from
Apache,
your environment.
and it
only
cost
then
1.4 billion in
and
cleanup
only then
costs
you
and
get the real
1.38 billion in
CVSS
consumer
score.
claims.
But
This
again,
is a huge
you
risk
can,
for
the
companies.
scanners can't
It ended up affecting
calculate that. It's
143
your
million
job.
US consumers.
Usually,
So like a huge
you know,
wide breach.
It gets neglected.
They patched their main system, so they knew about the vulnerability and they patched their main systems,
And
but it got
actually,
in through
the
another
score is
system
not the most
that was inside their
part of
firewall that was used
what
for
CVSS gives you.
different purposes.
The vector,
Then they got entry and they
is
got
actually the most
escalated
important part,
privileges. They moved
because
around the
it
network. They
encodes,
started exfiltrating the data.
valuable
And it
properties,
wasn't until a few months later
that
where they
represent
realized there was a data
vulnerability.
breach.
For example,
they closed down the
probably
hall,
the
but they'd already
number
lost a
one
bunch of data.
property that you
And this
care about
was
is the
eventually
attack vector.
attributed to,
that tells you
I
so
believe,
if it's
Russian
if it's
nation-state
an L,
hackers.
it
Years
means
later.
local. If it's
so
an A, it means it's
Theoretically, they've
adjacent,
actually done nothing with the data, but it does cause
network
a
adjacent,
lot of
and
collateral
then
damage.
network means somebody
Log4Shell,
over the network can
how many folks
exploit
had to patch
the
the
vulnerability.
system?
And
Okay, so this was
it has other
this was
useful
a
properties
huge
and
widespread
all of
exploit.
that.
Everybody
Unfortunately,
uses,
the formula
logging
itself
if you're using any
is
job
not very
applications.
good,
This affects
and
you.
it's also,
It was
also
interesting
depends
in that
on the person
if you were just
who
using Log4j core,
builds
you actually
the
weren't
score,
affected.
and then
was
you
only
end
if
up
you're
with
using the full
different
Log4j
values.
stack,
So
and
this is
you
pretty.
can
This is
even
the same
disable it with,
vulnerability from the
configuration
demo
by
app,
turning off the
and it's
JPI
scored by
feature,
different
which
people
flagged this.
from
But,
NVD
everybody,
and GitHub.
just to be safe,
And if you
upgraded
look
their version of Log4j in
at
pretty much all
one of the
production
properties,
systems.
privileges
70,000
required
open source
to
projects use
exploit
Log4j as a
vulnerability.
dependency,
The one from
170,000
GitHub
uses a
says
transitive
no
dependency. So
privileges are
pretty
necessary.
much the
The
entire
one from
supply chain
NVD
was
says
affected by this
you need
one
to have
exploit,
low
and
privilege.
it causes a lot of
sometimes it's like,
damage. And
I'm just
this one,
this,
again, an
so,
old one, but a good one. So
that's one of the reasons
in the case of
the scores
SolarWinds,
are
this kicked off a
inconsistent.
lot of the legislation, a lot of
times.
around
And another reason is
open
when
source security.
people
This was a
score
case
the
where they actually got
vulnerabilities,
into
the-
the network of SolarWinds.
not the requirement, but
got into
the
their
scoring,
CI/CD servers,
guideline
modified the
tells you
code right
you
before
should,
signing. So it had gone through
use the worst
source
case
code was
scenario for
successful. They
anything
went through the
that
build
happens.
phases, and
For
then they
example,
injected
there's a
stuff
specific
right before it was signed. So the
configuration that
end
needs to be there for the
deliverable
exploit
looked like it
be
was signed
successful.
by
I've seen
SolarWinds,
that
but actually it was a malicious package,
it's,
and
the
18,000
worst,
customers were affected. A lot of
imaginable
government
case. And
customers.
that's one of,
it opened
one
up
of
a
the
big
other reasons
backdoor
why you
entry
end
point
up
for
with
everyone who got
high
affected
scores
by
that
this
don't
breach,
mean
which
much
could be
because they just,
could cause further damage to
use
all their
that,
customers. So it's
strategy
quite a bad exploit.
to score.
So,
But
on average, the
it
cost
does
of
have
breach in
useful bits
2023 was
and pieces of
4.45
information that you'll
million.
be able to leverage in your decision-making process.
Quick show of hands. So today, how many folks
So
are
going back
aware
to
of a
highs and criticals, you have
security
60%.
incident response
That's a lot. But if
plan
you look
in your
at
company
what's
when a breach
actually
happens?
exploited, it's about 6%.
Okay, so that was a lot of hands. Now,
60%
5 years ago,
versus
did that
6%.
exist?
That kind of tells you
Okay, so you had
that
one 5
it's
years
a good
ago.
idea to use
But I think that
exploitability
like
and the
this
exploit-related
amount of
information
damage, like this
as
amount
one
of
the inputs
cost,
in your
which is being introduced in our
decision-making
industry, is
Because
fairly
you cut
new.
down
And
the,
for all the developers in the audience,
the
now
number
it's
of
become
vulnerabilities
our
you need to
job
deal with.
and our responsibility to write code that's secure.
And one of the up-and-coming
All right, so put your
ways to
hand
do
on your
it is
chest as a
EPSS.
developer. It's my responsibility.
It's a predictive
of
model
course,
that tells
even when you write
whether
secure
or not
code, there are
something, your
other
vulnerability
incidents
will
and
be
vulnerabilities
exploited
and things
in
which
the
get
next
to the pipeline.
30 days.
But I think we're
It's
all
a number
trying as
from
hard as
0 to
possible
1,
to write code.
and this is an example
so my
from
daughter's also
from
in
the
the
demo
audience,
app.
and so I get to watch.
I have the
This is
probability
her
there and
friend.
also percentile. The probability
I
there
get to watch
says
some of her computer science classes. She's a student at Colorado
96.86%.
State University.
That's a pretty
and
high
unlike
probability.
when I was a developer,
that it's going to be exploited.
where they taught
the
us
next 30
programming,
days.
they taught us like function
And then
languages, all
the
this cool
percentile
stuff
tells
first.
you the
She's
relative
taking a
importance
basic,
to other vulnerabilities,
level
meaning
like 101
that
computer science
most
class,
of the
and they're teaching
vulnerabilities
them
in the data set
memory safety,
are not as
avoiding
important.
buffer overruns,
so
like
that
using the later
gives you
C++
relative priority.
standards, so you're not
and
exposing
it's
your
super useful.
code. So that's exciting.
But it's
that
not perfect,
universities
and
are
it's
actually
also
identifying that this
not
is
a
a real
risk
job skill. This is something
because
which
just
they need to
because
start teaching in schools.
something
So,
is exploitable and
Which of
there's
these
a
is
high
your
probability
package?
of being exploited, doesn't mean that it's exploitable
So, like,
in your environment.
Oh, you found
For
it?
example, with the sample app.
Oh, nice.
using a
Okay, yeah,
package,
so you can pick that
vulnerable
one up.
package. If I have a CLI app,
So I
a
think
system
that, you know,
utility that
it's
uses
very, there are a lot of
not
innovative
gonna be
attacks.
exploited remotely.
This is a clever
So
one as
that's
well,
an
if you haven't heard of it, the dependency
environmental-specific
confusion attack.
property
And
that matters.
hackers
So
are very, very
also
good
not a
at
risk
finding different
for-
ways of entering the
for.
supply chain. So this
It
one
has flaws.
is
For
a
example,
dependency confusion attack.
it's not
Basically,
complete.
you're getting the wrong package.
It has a
You're
number
getting
of
not the
requirements.
package that you expected
First,
to get.
there needs to be a
this
CVE
is an
number.
example of a
Second,
intercepted
which means
request
that
to
the
NPM,
vulnerabilities
which
and
shows
exploits
you that
0 days that have
all
no
of the requests
CVEs,
actually
they're not
have
covered.
the full namespacing of the packages you're
you
requesting.
also need to have an IDS signature.
I think
because
they
they
fixed
use
this, but originally this was also clear
IDS
text, so you
sensors
could
from
actually do man-in-the-middle
Fortinet,
text easily
Alien
and pull
Vault,
this
and
out.
a number of other
And
commercial vendors to collect
once you get the
telemetry.
package name, let's say
So if
somebody's
there's no
asking for a
IDS
package
signature,
that doesn't exist.
there's
So,
no
you know,
way
I work
to
at Yelp,
detect the
I'm
attacks and
doing
all of
code
that.
and I'm asking
And
for a
about
bunch of internal packages.
10% or so
What they could do next is they can
all vulnerabilities
publish a
have
package with that name
signatures. In some
into
cases,
NPM. NPM's pretty liberal on
there's
whatever
no
you
need
want to
for a
publish.
signature
PyPy's
because
the same.
they're not remotely
And then
exploitable.
if
So
you
there are
have
good
a
reasons, but
vulnerable
still, there's a
package
gap in
manager,
terms of
when you
coverage.
request
But
this,
it is useful.
instead of getting
in case
version
of the
1.2,
demo,
which is what you
yeah,
want
it
if you
ended
say
up,
latest,
being
it's
there.
going to pull the magical 666
They ended up
version
having a
down
signature
from the central
and
repository,
more.
and then bad things happen.
The model doesn't
When you let kitties
use
push red
the
buttons,
information
and
about
then
what's
you're going to be
actively
pulling the
being exploited and what's being
artifact,
exploited.
which you don't want.
Because
now,
it would
most package
screw up the
managers,
model,
Artifactory
the
does
predictive
this,
nature of
Nexus
the
does
model,
this as well.
and they
So
wanted to
most
stay,
modern package managers will actually
they wanted
insulate
to
you from
provide
this
a
sort of
leading
attack,
indicator,
where
as
they'll make
opposed
sure
to,
that if it exists in internal
tie
repositories,
the
it
results
won't go out
to
and
the
fetch it from
current
external
state.
repositories. This is
That's
one
why,
way you can
and they
protect
say,
your developers from doing this. But
you
our
use
buddy
it
Alex
as a
Mersan
pre-threat
made a lot of money
source
on
of
this.
data, meaning if you
So
have a
he was very
commercial
clever in how he
vendor
did the
that
bug
gives you
bounties.
threat
So
intelligence
he
about
found the
what's
exploit.
currently being
This was kind of a
exploited,
theoretical exploit
use
for a while,
that
but
first.
nobody had actually
And then,
proven it,
what's not
done the
covered,
exfiltration,
use
and actually
ESS
showed how you
as
could
the-
actually
the-
attack
the next
corporate
thing to
systems
use.
using this.
So if you don't
so
have a
he
commercial,
did the full attack,
threat
did
intel
it
source,
against
what can you
Apple,
use?
Google,
And in this case,
Meta, a
there is
whole
an
bunch of
option.
companies all at once. He went
there's
for
an,
all of the
there's
bug
something
bounty
called
programs,
a known
and then he collected
exploited
about
vulnerability
20,000 from
catalog
each of the
maintained by
corporations, and
CISA,
together got 130,000. So,
a government organization.
if you're
that's
tired of
involved in a
your
lot
day
of
job
stuff,
and you're like, I want a
in
good
the
side gig
industry
where I
when it
can
comes to supply
do
chain
fun
security,
stuff, then maybe you
etc.
can become a hacker and
You
do bug
can
bounties
look
for a
up
living.
vulnerabilities online, and you can
Okay,
download the
and
data set.
here's another fun one.
It's
so,
pretty useful, but because it's not a
if they're calling for
commercial,
rice in a recipe, what
threat
type of
intel
rice do you
source,
want?
and they have
There's a lot of types of rice. So if you're cooking, let's say
goals.
what's a good rice?
It's also
like
not complete for a number of
the
reasons.
Spanish one with a
It actually misses
paella. So if you're doing a good paella,
possibly
and use,
80%
let's say, use like a
all
black
exploited
rice. Would that work?
vulnerabilities for
No.
one reason or another.
It's going to come out horrible.
But
It's going to
still
be
a good
the
source
wrong
of information, and
result.
conceptually
And
you'll
this
want to
is
have something
similar
like
to another sort of attack. This
and
is
again, you need to
common
have a
attack.
CVE ID.
This one,
They
we
do
caught
try
our
to
security
cover
research team
exploit
malicious
attempts. It's not
hackers
just about
putting in packages
successful attacks.
for Azure libraries, but they left
Now,
off the
with,
prefix.
If you look at
So
the
they publish
vulnerability
exactly the same
scan,
package with the prefix. It's also
scan
common
results
to do
Trivy,
typo
Bright,
squatting, where you put in
Snake,
typo errors, you
Docker,
just make
or any
random
other
typo
vendor.
errors,
They're
publish a bunch of packages.
pretty basic. They just try to discover.
They were also clever that
all
they did
possible
it by
packages in the
forging a
environment
bunch of
that they're
accounts.
scanning,
So each of the
container,
packages they published
VM,
wasn't from
whatever.
the same account.
And they
all showed as
just
different
look up
accounts.
the
So it was kind of a
vulnerabilities
very
in those
clever way of
packages.
doing it.
Very
And they did this
primitive,
for
very
218
basic.
packages
They
in
don't
Azure,
know if
Azure Test,
and
Azure
how
Tools, Catalang.
those
And
components
basically the
are
goal
used,
here was
and
if you're a
and
lazy
how,
developer and you don't actually put in the package and you get one of these by
environment is
accident,
vulnerable. This is
when
why
it installs
you
it
need
into
to
NPM,
augment,
it runs a package install script, and that's
what
going
you
to
do with
immediately
some
trigger
kind
the
of
malicious
vulnerability
code.
information.
Now
there
this
are different types
attack
of
was
visibility.
later attributed to a
Historically,
group that said they were doing
network
research.
reachability reachability, but a lot of
security
network
research,
scanners
kind of
have
like
been
a white hat
big
hacker group.
thing. Then
We reported it
static code analysis,
NPM. They pulled down all the artifacts before we published the results.
Runtime,
but again, something else to watch
dynamic,
out for. So what we want to do is we want to start with fresh ingredients, not rotten ingredients like this in our software supply chain.
Dynamic
And
reachability analysis.
when you're looking at this and managing your open source supply chain,
to simplify the demo,
bananas,
so
so I've changed
I don't
that
have
to
to deal with a lot of
banana there.
vulnerabilities. So many different
Melissa's
options
one of my
there.
coworkers, and she's speaking later today.
They all have different
Come see her
cons and
talk with
pros, strengths and weaknesses.
So you have all this
Coverage
modern
is one of
infrastructure,
them.
and you have this poor little
Not
package
much
which has
time
been
to
maintained
go
like
into
years
details.
ago.
I'm happy to talk more about it.
This is a good example of the left pad incidents.
Now, with
So
all that
developer and
information
Keek organization
about
couldn't come up with an
the
agreement
basic
on the NPM package.
vulnerability property,
NPM sided with Keek organization, so they
exploitability,
gave them the namespace.
and
the developer unpublished his
reachability,
package.
you
And
have all of those
72 other
components,
packages,
and you
one
need
of
to
which
put
was
them
left
together
pad,
somehow
and,
to decide what to
somebody
do.
else stepped in and published a functionally identical package.
A
later
natural
to fix this.
fit there is
But this was a
some
case
kind
where
of
the whole
decision
supply
tree.
chain fell
and
apart.
there is a formal
because
model
there was
that
a
uses
maintainer,
decision trees,
poor,
called
unpaid. I did this in my spare time. And
stakeholder-specific
what is left pad?
vulnerability
This is the whole
categorization.
function which blew
If
everything
you look
up.
at the
So it's a
acronyms,
very, very small amount of
it's
code. We're lazy as
CVSS
developers.
backwards.
We don't want to write this. We'll include it as a dependency. And that
people
collapsed the whole
Carnegie
software
Mellon
supply chain.
University,
So that's an example of what can
they
happen.
actually published
And this is
a
my
critique
favorite quote from Dan Lorang, who is
of the
creator
way
of
CVSS
Six-Store.
works.
I think he works at
and
ChainGuard
its
now.
problems, and
Every
then
time you pip
they
install
came up
GoGet
with
or
this
fetch
idea
something, you're
as
doing
an
the equivalent
alternative
plug-in
where they
thumb
have
drive
different
you found on the
stakeholders and
sidewalk into your
different
production server. So let's
decision trees
let's not do this.
That incorporate different types of data, including importing data from the
who do you trust?
CVSS
Who
vectors,
uses one of these registries? PyPy,
Coral
NPM,
and exploit
so
information.
pretty much everybody
in the,
in the audience raised their hands.
And
do you trust
decision
these
trees,
registries?
there are several of them depending on the stakeholder.
No, well, not anymore.
And they all start with the exploitation.
You have to pull from them.
You
So
there,
this is the number of exposed secrets
is there an
that our
exploit,
research team found in
or
all
a
of these
POC,
repositories. We ran tooling to look for exposed secrets.
Mature exploit, etc.
In
And
Docker
then,
Hub, of course, Docker files are huge.
You go to the next
bits
phase
of
where
stuff
you
nobody
determine
understands.
the
So that was 5.78 million.
whether or
Next
not it's
highest
easy to
was
automate
NPM
the
with
exploit,
1.16
which
million.
maps roughly
And
to
this is a big problem.
the attack
Now,
complexity
let me give some
concept of
tips on
CVSS.
how you can
And
avoid
then
exposing
the next phase,
your own secrets.
at
Okay,
least
so
in this
first,
decision
number
tree,
one is not
you're
using
trying
automation
to understand
check
the
for
technical impact, which
if you're
roughly
not
maps
using
to
automation to check
the
for
severity
exposed secrets, then you could
CVSS,
potentially be using
whether or
exposed
not
secrets.
you have
So
partial
we do this with our
impact or
product.
full
TruffleHog
impact,
is a good open source
which
tool
maps
to
to
use on your project. So
low
if you're not
severity,
using
high
TruffleHog
severity,
or some
and then the
commercial
business
solution for this,
impact or
highly
environmental
recommended. And then
impact
this
is
way,
the last
you're
phase
at least
of
have
the
like a
decision.
layer of insulation
So
in your
the,
build, where it'll throw a build check or flag it, or
The
you can head
problem
it
with
into
the
your
existing
your
decision
Git commit hooks
trees
to
is
make sure
that
nobody
they were
accidentally
designed
checks
for
in.
large
Their
organizations
exposed
and,
secret. We actually
large
recently
commercial
found an
organizations
example
and
of
large government organizations.
corporate secrets which
Probably
somebody
you
inadvertently
won't have
sent
something
to an
called
open
public
source
safety
repo,
impact.
and then gave access
So
to their internal
to
Slack
get the
and
best
internal
results,
GitHub repo. So
most of the time,
it's very
you need to
scary
take
what
what's there
people
and then
do just do
customize it
accidentally
to
in
your
coding.
environment with
Mistake number two is
the
generating
phases
tokens
that
with
make
broad
sense, but
permissions that never
it's
expire.
a way to put it all
So
together.
when you're doing token generation, always do it for a finite amount of time with the most limited
I'll
amount of
briefly
permissions you
mention
can. This
SBOM
avoids if somebody
and-
does
and
get access
Vex,
to the token, they have a
because
very
it's a part
short
of
period of
the
time to
overall
use it,
picture
and
to
they
capture
can't get
the
escalated
information,
privileges or do additional
about,
damage. Mistake three, no access moderation
components
for
we
the
have
secret.
in the environment
So
and a way to
you want to hopefully be using
filter
something
out,
like Kubernetes
vulnerability
secrets,
related
Docker
noise, but
secrets,
Vex,
or
it's a
HashiCorp
way to
Vault
say,
for
hey,
making sure that you're managing your
scanner
secrets,
X
making sure
gave
that
you
you're not exposing things
a
unnecessarily.
vulnerability match
Mistake
on
four,
vulnerability
fixing
X,
a leak by
A,
unpublishing the token.
and then this is
So
a way
this is
for us to
this
say
is not
that we're
a
not
fix
vulnerable.
when you
So
accidentally
if you're a
commit
supplier,
something with a
it's an
token,
easy way
because
to provide
Git has a very, very long memory.
level of filtering.
You can
There are
never
different,
ever get rid of that token,
options
which you've now
for Vex
committed
and
to the public
SBOM,
repository. So you
CycloneDX,
actually have
SPDX,
to
for example. SPDX
make sure the token is
traditionally
expired, like
is
revoke
more,
the token, make sure
aligned
that
with
nobody
the
can use that token which got
license
published, and
management
then publish,
and
that, don't
and
publish the new token
CycloneDX is more
that you
aligned
generate.
with the security
and then your
supply
systems
chain,
won't be
use
exploitable.
cases.
And
But
mistake
obviously,
five,
both of
exposing
them,
unnecessary
they're
assets
evolving,
publicly.
you know. For example,
something which
CycloneDX
happens a
has
lot
built-in
is
support
people
for Vex.
kind of post and they do
SPDX
things
doesn't,
where
but they're
they're
working on it,
posting internal
to
test
add,
libraries, internal projects, which have a lot more data,
good
information,
sign
and things which
which are kind of access to internal servers. So make sure that you're not accidentally publishing your test repositories, your debug repositories, and other stuff into production. And we saw a bunch of cases for this.
It's a simple app.
Okay, and then to use open source safely, we need good standards as well. And I think OpenSSF scorecards is a great example of like how you can use an automated tool to help make sure you're up with the latest standards. This is a new OpenSSF project. We have some automated command line tooling, GitHub tooling as well, so you can hook it up with your GitHub. I think we just announced a couple weeks ago, we also support for GitLab. So if you're using GitLab, you can also tie in scorecards with that. It'll run a whole bunch of checks. It'll check for CVs, which you might be exposed to in libraries, upstream libraries. It'll do maintainer checks to make sure you have the right maintainer code reviews and things happening. And it all does all this in an automated fashion to make sure you have good hygiene either on your own projects or on upstream projects which you're consuming. So I think this is really important and something exciting. Now, the next section, I'm gonna go a little bit quickly on this because I want to leave some time for questions. But does everyone know what a CV is? Okay, so pretty much everyone knows what a CV. Now, what you might not know about CVs is that CVs actually, a lot of CVs, the way they get scored and the way this is done can leave you vulnerable. And when I say when it leave you vulnerable, if you look at the naive approach for how CVs are evaluated,
about the services,
basically what they do is they're looking at the exploit, like how commonly this library is used in industry, like what level of security exposure that it gives you. And the CV rating is often heavily overrated or underrated
on this screen
based upon your industry. So for most of us building, enterprise applications, cloud-native applications, there's certain factors about the configuration we run under, the environments we run under, how we do things. And CVs, for example, in GUI command line tools, while they may exist, you're unlikely to be running GUI command line tools from an enterprise application where while it's running an exploit could be injected. So there's a whole bunch of these CVs which get very high ratings where it doesn't really make sense. The other thing about CVs is often there's very specific information about how it has to be run, what the prerequisites are.
And that's an example.
So it has to have a certain configuration. It has to have
the results of it were used.
Possibly you have to call a certain method in it or something. And again, you'll get high severity warnings.
So as a result,
so if you run a typical source code scanning tool, you'll end up with a bunch of CVs which have high severity warnings.
I only have 4 vulnerabilities.
Simply because it doesn't apply to your environment, but it's a very high critical exploit. So this is an example of a critical vulnerability, right? So it's CV 2022.
And we'll focus
2612.
This
it's a
vulnerability. That's the vulnerability
in the untar function using get canonical path. And the environment prerequisite for this
if you look carefully,
is you're running in Windows.
You actually have 2 vulnerabilities.
So who runs a production workload in Windows?
And 2 CVEs, and they are actually
you're a very brave man.
I don't know the full history there, but what's interesting is how they were rated.
This CV
if you look at the vectors and the severities, they look very different.
But like this is a lot of the analysis of CVs happens because of these sort of is it applicable to your environment?
388.
So something we do at JFrog is we have a contextual analysis capability which automatically looks for have you mitigated in the code, is the configuration set up? And there's other tools to do this as well, but like I think one thing to do is when you're looking at CVs, don't just look at the severity, look at how applicable it is for your specific environment. And the other issue with CVs is often it's very, very high, the severities are high. CVSS 4.0 solves a lot of this with the changes to how they're doing scoring in the new version of it. And we also in our products have our own severity score for enterprise customers. Okay, so key takeaways. Don't take a CVSS at face value. Consult different sources for your CVSS data. So look at, often the project maintainer will dispute the CV score on issues. Like there was a curl exploit. It was like a 9.8 or some very high severity. But it turns out that it wasn't a legitimate vulnerability.
The EPSS score is
folks that
not even
maintained the project showed that
1%.
it couldn't be exploited in practice, even though it
So
existed since
the
for a
CVSS
lot of
scores are
versions.
all
And they ended up
messed up.
revoking the CV
They're
3 days
very
later.
different, even
but a
though
lot
it's
of
the
teams
same
jumped on it
vulnerability.
because of the criticality and
If we
because
look
everybody
at the
uses the system
vector,
which has curl.
and if
Okay,
we look
so last thing, can we
at
trust
the
the
attack
machines
vector
with our
information,
ingredients?
one says
So it wouldn't be a complete presentation this year
It's a
without an
network.
MLAI reference. And does anyone want to guess what the answer
attack
is?
vector, and that one said
No, we can't.
they don't show
okay,
it there,
so
but
machine learning models are already
in
being
one of the
maliciously
slides,
targeted.
it showed
So
that it's
this
a
is
local
one exploit
attack
which
vector.
we've seen
So,
hackers doing. So the
it's not
H5 format for models
objective. It depends on the
allows
person
you
doing the
to
scoring,
put code inside
and
of
then
there, which gets
the reason
injected when the model
why
gets
they're
loaded
so
on a
different
developer's
in terms
computer.
of EPSS
And,
is because
basically it gives you
because of the
arbitrary code
exploit
execution. You could use it for
for
ransomware, for other purposes.
21388,
And this is
exploit,
an attack
and
which
at
is
least
fairly
nothing
new
that's
because
tagged with that
it's
CVE.
on
So
a
it looks
entirely
like
new
nobody's
technology,
exploiting
which
it,
a lot of us
but
probably don't even assume is
other
subject to a lot of
vulnerability,
malicious attacks.
3.15, actually has a proof of concept that was weaponized.
Okay, so what else can we do?
The PSS
So I think the most important thing we can do is educate ourselves. So thank you all for coming to my session and
there's a high
learning a
chance
little bit
of
more
exploitability.
about security,
So,
about what
that's a good
OpenSSF
example
is doing to help
that
secure
shows
the
that
supply
EPSS
chain.
is also
Hopefully I gave you some examples you can apply to your workspace as well to improve your
this
security
is,
posture.
Again,
here's some great resources. So the OAuth
an
cheat
example
sheets
of
are great
doing,
resources for you to look at and to learn more about how you
reachability-based
can get developers
prioritization.
trained
So
on
instead of
security. There's some great
30
OpenSSF courses as well,
vulnerabilities, I only have
which
4
are great resources to teach
and then,
developers about security
what I
and
have
make sure
there,
that
I can
you
just,
have a better security posture as an organization. And
prioritize
also
what's
our
there.
research team
And
at
for
JFrog
that,
has a lot
I'm going to
of
use a tool
good
called
information and
CVE
exploits which we're
Prioritizer.
working on. So this
And
is
what I
just
did
the
there,
blog
I'm going to
only
run it
for our
again.
security research team. So
So
it's
I
all
plugged in
technical about
the
things which they're
CVE,
researching and putting out.
one of the few
So
CVEs
thank
I
you
had,
very
and
much,
one
and
that-
hopefully together we can
that
create
this
a
demo was
healthy
designed
software
for.
supply chain.
And then it gives you
Thank you so much, Stephen.
different
Questions?
properties, but the most important one is priority. So priority 1+ means you should fix it
great talk.
ASAP, right away.
You mentioned about OpenSSF
they also
scorecard.
provide
Right?
the EPSS
The
score
major
and all
problems
of
I
that.
had with that is when
And
I
they
have a
5
project on
priorities.
GitHub
So
itself,
now
and then when I
had
register it
4
to actually
vulnerabilities to
check
deal with.
for the
depending on the
scorecard,
scanner you use,
I go through all their
a
automation.
little more, but then
if I
whatever's
don't want
left,
that, if I'm developing some software
you
and if I
can
want to
run
run
through this tool, and
OpenSSF on that software, and then I download scorecard locally, and then I run it on my
and then you
software.
need to combine
It doesn't do all the
that
checks, like it
and
just
use
does
your
almost
custom
less than half the
decision
checks. So
tree,
it's not
with,
kind of, I did not
with
find
the
it very
environmental,
reliable for my software, which is
details, because again,
like
this tool
downloaded or
also
not
doesn't
on
know whether or
GitHub.
not
If I don't,
I see. So
your
like if the
application,
project's
server
the open source
application
project on
or a
GitHub, it
CLI
runs all the
application.
checks and it works, but then on the local, on your maybe your commercial projects for work,
Exactly.
it's less useful in terms of the range of checks you run. So I think that's great feedback. So like everything else in OpenSSF, Scorecards is a community-run project.
What are the
So
key takeaways?
right now, actually, we
Mentioned,
just talked about this
quite a few
last
problems.
week, that we need more folks to contribute to Scorecards to improve it. So the code base is written in Go. If you're a Go developer and you're interested to help out, I think it'd be great to get contributions here. Also, there's a mailing list and regular meetings that you can attend to participate in Scorecards. So, I mean, I'll be happy to give the feedback on Scorecards to the team working on it, but also, like, as a community member, you can just join, participate, and help to make it better for everyone. So, thank you. And it's great to hear that you're using Scorecards on some of your projects as well. So that's exciting.
Hi, I have a question about the supply chain metaphor for all this. In the physical world, supply chains are usually accompanied by contracts and commitments and money changing hands. And in the open source supply chain world, none of that exists. And I wonder what it means to use that way of thinking when the things that we're depending on are provided with no warranty, are provided best use maybe by people we don't know anything about. And
Yeah.
I'm just wondering where we seem to be pulling on a chain that starts with weak links.
So I think that's actually a astute observation on the state of open source supply chains, is that it's not like a commercial supply chain. And not only is it breaks the metaphor, but also it leads to things like there's currently some EU legislation which is attempting to put the onus on security to the owners of the repository or technology. So, for example, I'm also involved in the Rust Foundation, and they've been trying to push back and fight some of the EU legislation, which would make them responsible for crates.io and all the software distributed on that. And it really doesn't make sense in a software space that as an open source maintainer, if I release something, I'm wholly responsible. Of course, I should patch vulnerabilities and release new versions, or somebody should contribute a patch, but you can't be held liable for like vulnerabilities which appear in the future. So that's a good observation.
One more, last one, okay?
So it's great to have supply chain security for our own stuff, but when we start talking about dependencies and kind of the same building on what he was asking about, how do we ensure that when we import dependencies from other places that we can say, not only that they attest that they've followed good supply chain practices, but that somebody has actually demonstrated this? Because it's one thing for me to say, yeah, I followed all healthy supply chain practices, and it's quite another for me to actually do that.
So I think scorecards is one attempt to make it easy to check a bunch of the things which you want to do as a project to improve your security posture. The SALSA supply chain levels, that gives you kind of provenance, and it gives you the ability to make sure that all the dependencies are known and that there's attestations along the way. Now, I think that in practice, you really can't trust all of the upstream projects right now to be following good security practices. And the hackers know this, and they're finding vulnerabilities in the supply chain. And so like at my company, we basically have a whole division, like 50 people, who just spend their days looking for security holes, tracking the hacker groups and seeing what sort of exploits they're doing, and then creating automated fixes for those for our customers. So, I mean, at some point it's an arms war. The hackers have a lot to gain, and they've found a lot of value in doing supply chain attacks against developers. As open source projects, we have now better tooling for this, and then I think as companies, you have to make some investments in security if you want to make sure that you're keeping up with the attackers. All right,
thank you. Sorry, no
you.
question, no time for more question, but if you want to speak with Stephen, he will be around. So thank you so much. Great talk.
It's on now? Yeah, good. Okay, hi everybody. My name is, actually we'll get to that in just a second. So this talk, you've been here for like 10 minutes, so I guess you're at the right place. This is the talk, or an introduction to Inspector Gadget, a containerized framework for eBPF systems programming. My name is Chris Kuhl. I'm a principal technical project manager at Microsoft, and
yeah, I'm Mauricio. I'm principal engineer and the technical leader behind the Inspector Gadget project.
Yeah, and unfortunately in this talk, I'm doing most of the talking, but Mauricio has a talk at actually KubeCon, and so if you want to hear more of Mauricio, then you can go to that talk, but we'll get to that later. So this talk is basically going to have a brief overview and a little bit of history for Inspector Gadget, because this is called the reintroduction, and reintroduction is what we're saying because what we're presenting here is kind of a new vision that we've been implementing in Inspector Gadget, but Inspector Gadget has been around for a little while. So Inspector Gadget can be used as a tool, so this means interactively. When you're trying to debug something, you can work with it directly, or you can use it as a framework to build something on top of, or to integrate into your system. And then we'll talk a little bit about looking ahead. And a little bit of a disclaimer, all this stuff is under active development. Many of the things are behind an experimental flag currently. Many of the features we're going to be presenting just landed 2 days ago in a release. Others are still in development. And where they are in branches that are still under development, when we demo something, we will actually put links to those branches or tags, or not tags, but issues. And then we will, this should stabilize in the next releases, and we do basically a release every month, so that means in the next few months. And we're really eager to have your feedback on this and your, your feedback on the functionality and the UX experience. So let's get into it. So what is Inspector Gadget? It is a set of tools to inspect Linux and Kubernetes systems using eBPF programs. So this is pretty much the first time we've mentioned eBPF. Do people have an understanding what eBPF is? Can we raise your hands if you know what eBPF is? Okay, that's most people, but not everyone. We'll get a little bit into that in a second. And it's also a framework, so you can use Inspector Gadget to build, package, and deploy what we call gadgets. Gadgets are basically eBPF programs, some metadata, and possibly optional user space processing programs. And you can build this as a framework to also build things on top of. So I did want to, because this is, I don't want to assume that everybody understands eBPF programs, even though most of the people raise their hands. But eBPF programs here, in a Linux system, we have kernel space and we have user space. eBPF programs are a way for people to tap into the Linux kernel to get extra information. Previously, to get this information, you needed to build a kernel module, and a kernel module is not necessarily safe. For example, you can easily crash the kernel. eBPF programs are safe. They are dynamically loadable, and you can get a lot of information that previously was either difficult or not, you weren't able to get. And also very interesting, because it lives inside the kernel, this stuff is very performant. So you don't have to do context switches between user space and kernel space to get this information. So this big question mark over here is, when you get the data out of the kernel, and basically these eBPF programs, when an event happens, they put that information inside an eBPF map, and then it has to be pulled out, and you have to do things with it in user space. And so Inspector Gadget handles loading the eBPF programs, but it does a lot of stuff in user space that you would normally have to build yourself. And so a little bit of background. Inspector Gadget started in 2019, very early in 2019. We wanted to bring eBPF and BCC tools. So BCC is a collection of eBPF programs developed by some engineers at Netflix, and it basically allowed you to inspect Linux systems. However, those were individual systems and not a Kubernetes cluster. And so Inspector Gadget was originally designed only for Kubernetes, and you could really only use it in the context of Kubernetes. This has been changing, and so it now supports running on Linux hosts directly, and so you can use it simply on the CLI on a individual node, but you can, of course, also still use it in the context of Kubernetes. And it's one of the main use cases. But what we did, because we were building a lot of things around BPF, what we found is that we essentially built a framework. And so the work that we have been doing and what we are talking about in this reintroduction is we have been transitioning from a collection of individual gadgets that were built in to Inspector Gadget to a system where you can basically package BPF programs and similar to container images, you can share these gadgets, as we call them, with other folks as OCI images. And then you basically can write your own gadget, and then you can, Inspector Gadget can operate on those, run them, and do the other stuff that we'll present in just a second. So is this, yeah, okay. So why did we start the project? What we were talking about before is there's a lot of stuff you have to do in user space, and there's no reason for everybody to implement that themselves. And so things that you would normally do when the information comes out of a BPF program and is put into a BPF map is that you want to enrich that data. And when we say enrichment, what this means is that an eBPF program runs inside of the kernel. It does not have any concept of Kubernetes. It doesn't have a concept of the container it's running in. But it does know about the kernel primitives, like the mount namespace, the PID, and these kind of things. But you want to get the information as you understand your system. You want to understand it as these high-level concepts, Kubernetes pod, which container it's in, or even systemd unit. And so you also want to be able to filter this information based on those higher-level concepts. So you want to say, only show me the information that is relevant to, for example, this pod, this Kubernetes namespace, or this specific container. And other things you do, you might want to do something with that data. You want to send it to, for example, Prometheus or a log server, or expose it via an API. And often, when the data comes out of the kernel, you want to do some kind of post-processing. And so all of these things are covered by Inspector Gadget, and we try to make a framework that you can simply tap into and use. And some of this stuff will be done automatically for you by using Inspector Gadget and packaging your BPF programs or consuming gadgets with Inspector Gadget. So, and one of the things we also wanted to do, we wanted to make sharing BPF programs very easy. And to do this, this is why we used OCI containers or images. And we also want to make it so you can use this in a lot of different ways. So we support running it inside of a Kubernetes cluster. We support running this directly as a tool using the IG CLI tool. You can also run this you can run IG as in daemon mode and interact with it with a client. And so this allows you, for example, to run IG inside of a Linux node, but be able to interact with it from, for example, your Mac or your Windows host, which has no concept of BPF really. And so where we showed you before the BPF overview, all of these things on the user space, this is what Inspector Gadget tries to take care of. So this is basically the tools that you will interact with Inspector Gadget. We have IG, which is a CLI tool that you can use on Linux. This is kind of the kitchen sink of Inspector Gadget. You can use it interactively to collect information, but you can also use it for the building, pushing, and pulling of gadget images. kubectl Gadget is the client that you use whenever you deploy Inspector Gadget inside of Kubernetes cluster. And very similarly, you can use GadgetCTL, which is a client. We will probably merge these two eventually. A GadgetCTL is a client that you can use with IG when it's in daemon mode. And so this bears the question of what actually is a gadget. We mentioned that it's an eBPF program, but it also includes optional user space modules. And we'll talk about that in a second, and we'll actually have a demo of that. We are basically using WASM for the user space processing. So you can do that in process the data in user space. And then we have metadata. And this metadata should basically give hints to Inspector Gadget of how this information can be used. It should give basic information like the author, but it also should be, tell you what kind of formats it supports. Does it support exporting to Prometheus or logging, etc.? And what we're actually interested in also exploring is basically automatic visualizations. Whenever you create a gadget, that data can be automatically visualized in various tools. But really, the gadget is a deployable unit, similar to how a container image is. And it's a shareable unit. You can just send somebody a link, and then they can use that. So this is a more visual way of looking at it. So you have your OCI registry. You push that gadget to the OCI registry. That includes the metadata, the eBPF program, and the user space module. Okay, and now I'm going to hand it off for demos for Mauricio.
Yeah, thank you, Chris. So I want to show you how to build a gadget, how to run a gadget, and how to push and pull a gadget image. So here we have, usually it's here. So this is one of the gadgets that we provide. It's trace open. This is based on BCC. And yeah, this gadget provides information of the files that are being opened in the file system. So it could be useful for you to understand if a given process or container is trying to access a file that is dangerous, like etcd shadow, or etcd password, or something like that. So yeah, this gadget is composed by two different things, as Chris was mentioning me before. So we have the BPF program. This is mostly based on BCC. I'm not going into the details there. And we have this metadata file. So this metadata file provides additional information about the program. So in this case, we have like basic information of what is the name of the gadget, what is the description of the gadget. So that's like some documentation for the gadget. And we have information that says, okay, this gadget provides a tracer. A tracer in Inspector Gadget is a gadget that provides events as they happen in the kernel. And then we also have information about the structure of the events that the gadget is providing. So we have different columns or different fields of a structure, and we are able to tell Inspector Gadget how to format, how to print that information to the screen. So for instance, we can say, okay, this is the width of this specific column, or there are some columns that maybe the user is not interested in by default, so we can hide them. Okay, so let me show you how we can compile that. So the first thing that we have to do is to enable the experimental mode. We are still developing that, so that's not so stable yet. And yeah, so let me go to the folder there, and then I can run the image build command. So this is like similar to the Docker syntax. So we are building the container, the gadget, and putting that into an OCI image. Okay, so we already have our image, and we should be able to run that. So if I do this, it should be this one. Okay, so here we have our gadget that is running. It's providing information about the different events that are happening on the cluster. In this case, there are a lot of events because I'm running also Minikube on this machine, so Minikube is doing a lot of activity there. But yeah, this is interesting, but so far I only have the image on my local machine. So what about if I want to share that gadget with other people, with customers, and so on? So what we can do there is to tag the image. So I'm telling what is the remote URL of the container registry where I want to push that, and then I can push that to the container registry. Okay, so right now my gadget image is available for everybody that wants to run that. So yeah, let me show you also how we can run that on Kubernetes. It should be this one. So yeah. So what is going to happen in this case is that Kubernetes is going to contact that OCI registry, is going to pull the image for the gadget, and is going to run that on the different nodes. So if I execute into a pod of my cluster, we can see the different events that are generated there. Okay, that's it.
Yeah, so really, thanks, Mauricio. Really interesting there is to note that all that additional information you got about the pods, about the container names, that's all in, that's not what eBPF provides, that's what Inspector Gadget is enriching the data with. And we demonstrated that running on a Linux host and on Kubernetes. And so what I mentioned earlier is that we support running this in many different ways. For example, it's very easy to understand, if you run IG directly, it's simply a process, and then it loads the eBPF programs in the kernel, and then it interacts just right there on the host, your own. You can also package IG inside of a container, and you can deploy it like you would any container, given the proper permissions and flags down here. But like I said before, you can run IG interactively, but you can also run it in daemon mode. And in daemon mode, for example, if you deploy this as a systemd unit or a service, then it's running here in the background or as a service, and you can interact with it using Gadget CTL. And obviously, Gadget CTL can be running on a Windows or a Mac OS node. It doesn't have to be Linux in that case. And similarly, kubectl Gadget doesn't matter which OS it's on, but when you do kubectl Gadget deploy IG, then that will deploy Inspector Gadget as a daemon set, and then it will give you the information in the context of all of your nodes inside of Kubernetes. And additionally, very recently, Kubernetes added a debug node command, and what this different than the previous one where you have everything on all the nodes. This allows you to basically debug an individual node, and we added support recently for Inspector Gadget to use that, so you can use it using this built-in command in kubectl. So yeah, there's a lot of different ways to use it. But really, we've talked about this a few times, but enrichment is really one of the most powerful things because when you generally, this eBPF program is not giving you the information you want as you understand your system, and you have to do a bunch of stuff for that. And so we want to make sure that all the data that is output from Inspector Gadget is basically relevant to your situation. And so, yeah, and very important though is not only can you display that, but you can also filter it based on those high-level concepts. And so Inspector Gadget basically, if you say, give me only the things that are interesting for this Kubernetes pod, then it'll translate that to what the eBPF program needs in the kernel to do the filtering inside the kernel. Because you don't want to be filtering in a user space because it's much more performant to be doing that inside of the kernel without the kernel switches, the context switches. And so, here's kind of a diagram of what we have here. The eBPF program is loading into the eBPF maps. Inspector Gadget then is talking to all of the services that the Kubernetes service, the container managers and runtimes. And I say others here because we're looking to add, we have actually an issue in a POC right now for systemd units. So if you want to, if you're basically using systemd, and we're interested in in adding other targets for enrichment. And so what we want to do is basically populate the information that's coming out of these BPF programs with all the information that's relevant for your system. And so we have a demo of that.
Right. So what I'm going to do here is to run one of the gadgets designed in Kubernetes and show you what is the information that it provides. So if we try to access, so this is a gadget that provides information about the different DNS requests and replies that are going on the cluster. So when we're trying to access a service that is running on the cluster, we can see that on the left, we provide information about what is the Kubernetes pod where that request is coming from. And also for the destination and source endpoints, we don't only provide the IP address, but we also enrich that information with that data with information about the pod or the service where that request is going or coming from. So this is useful for people when you are debugging something, you don't want to do this IP to container, to pod, or to service machine manually. Inspector Gadget is doing that automatically for you.
Okay.
Oh, let me go back.
Yeah, sorry. So one of the most exciting things we've added recently is user space processing. And so what we mean by this is that, like we said, the data that comes out of the BPF program is kind of raw, and you might want to add additional data, or it might not be in a format that is how. So one thing we should add, BPF has certain limitations on what you can do inside the kernel for safety reasons, or things that are just kind of complex to do even if you possibly could do it. And we'll give an example of that in just a second. But we wanted a way to basically allow people to, when information comes out of the BPF programs, to do something with that data that we might not imagine ourselves, right? And so we wanted a general purpose way for people to do user space processing. And so we've decided to turn to WASM for this, because it basically provides good sandboxing for us, and it provides support for multiple languages. So we have a demo today doing it in Go, but we also have some programs written in Rust that do the same thing, and so. Yeah, it's kind of a perfect match for what we're looking to do. And one thing we're looking to do with this in the future is to add some language-neutral APIs for common things that you might want to do. We have an example, for example, today for formatting some DNS stuff, which is hard to do inside the kernel, but very easy to do in user space. And so, basically adding a library for that kind of stuff would be very nice. And so we have Yeah, so basically the way this looks is, similarly, the BPF program puts it into a BPF map, we pull it out, and then we just send it to the WASM module, and it sends this output out. So very easy to understand, I would say. So we have a demo for that.
Yeah, so one of the cases is the DNS name of a request that's encoded in a variable len approach, so that's very difficult to handle in a BPF. So in that case, we do the processing of that data using WASM in user space. So this is the program that is doing that. I'm not going into the details, but this is the program that takes the information that is coming from eBPF and produces a human readable version of that. And yeah, in this case, for just demo purposes, I'm going also to provide some additional logic there, like masking one of the domains. Okay, it should be here. Okay, so let me run this. So yeah, the gadget is running. If I try to access, actually it should be this one. If I try to access, for instance, this food.com, we can see that the name of the DNS is not provided, but if I try to access something different like Google, we can see that the name of the URL or the domain is present there.
Okay, thank you. We only have like 3 minutes left, so yeah, one of the goals is not only to be able to use it as an interactive tool, but be able to build on it. And you have kind of several options to do this. You can use the IG binary directly and just parse the JSON output. Or you can, start IG as a daemon and then talk to it, using it should be Gadget CTL and connect using gRPC or connect using gRPC because we have an API for that. But you can also, interestingly, import the Go library into a Go program. And so we have users, for example, the KubeCon project from Armo. They're actually going to be presenting, I think, tomorrow. They use Inspector Gadget in this way. And so they previously used Falco to do this, and Inspector Gadget, they switched to Inspector Gadget because it was a little more flexible for them. But we actually, interestingly, for this, and using this Go library package, we were able to actually add kind of Inspector Gadget support to Falco, because Falco only really responds to syscalls. And so we wanted, with Inspector Gadget, we can actually add different kind of things that you can attach to basically be a source for Falco. So yeah, we try to make it very flexible. So if there's a use case you have that's not covered, please tell us and we'll work with it. So coming plans, I just want to show this slide because we don't have much time. We're adding scriptability. So there's a project called BPF Trace. We already actually have that implemented, but we don't have enrichment for that because that's actually turns out to be a lot of work, but we want to do that work because we find that very interesting to make it very scriptable. So you don't even have to have a BPF program, you just script it. We want to bundle gadgets, so you have basically a defined set of gadgets that you can deploy and for your use case. We won't add more security mechanisms. For example, only load from this specified repo, only load signed gadgets. We have 1 minute. Or don't load any gadgets at all because I've defined that all when I started the program. So we want to add that to make it very flexible. Clustering as a concept outside of Kubernetes. So you might have multiple nodes and you want to act like that's all in one thing, and we can aggregate that. Runtime configuration, so you actually can just provide a file similar to like Docker Compose, where you can run multiple gadgets at the same time using certain parameters, and you basically do run and then provide the configuration file and it takes care of it instead of doing that individually. And always proper documentation, which we're working on continuously. So we actually don't have this demo time for that. So we're going to end with that. But I do want to mention we have a project booth at KubeCon. This is our first time. Actually I didn't mention that. We're a CNCF sandbox project since the beginning of the year. And so we're taking advantage of that by having a project booth, so please come to talk to us. And Mauricio has a talk at 5:25 on Tuesday, collecting low-level metrics with BPF. So thank you, and we have time for questions.
Thank you.
You kind of half answered my question already answering his, but I was going to ask, have you talked to the Istio people about using this to debug and expose things about their sidecarless mode that uses eBPF?
Well, I mean, we think it could very well be a good match. Yeah.
Any specifics you can share?
No, because I've been on vacation for the last 3 weeks and I've forgotten, and I have to catch up on those conversations.
That sounds like an excuse to me.
Yeah.
Okay, thank you so much, Chris and Mauricio, for this great talk. Yeah, we will.
ready, Victor?
I don't know what's going on. Yes, I'm ready. Yes, I'm ready.
Awesome. Welcome to Choose Your Own Adventure. I am so glad to be here. Presenting to this room is very scary because I'm in a room full of people I respect so much and my peers, and it's so cool. And I appreciate you in advance for thinking of us, me especially, with a kind mind, while I probably talk about projects that you maintain. So here we go. Meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users. And we're going to help Hero on their journey today. So our job is to help Hero navigate hundreds of CNCF projects, choose which ones to use, integrate them with one another so Hero can live their dream. Victor and I host a show called You Choose that streams on his DevOps Toolkit YouTube channel. And in that show, each episode, we make a system design choice. So for the system design choice, we invite maintainers or super users of a project to come on. There are probably 2 to 4 projects for each system design choice. The maintainers get 5 minutes to present, only 5 minutes, and we will cut them off. Don't cut us off today, though.
We are also very bad at making choices. And the proof of that is that, look at this picture. That's obviously not a good choice.
And so they get 5 minutes to present. And then at the end of the episode, there is a vote. We have a community vote, and whatever technology the company chooses, the community chooses, is the one that we implement into our ongoing demo. Now, this is not a popularity contest. The one that gets chosen is not at all the best technology. It's simply the one that people want to learn more about. We've also limited the scope to only CNCF tech. So in our first episode, we had build a container image from the laptop source code. And the chosen technology was BuildPack. So our hero leveled up and became a container image. Then there was a container registry choice. The community chose Harbor. Yeah. And then our hero leveled up and is now hosted in a container image registry. So now we have 4 system design choices to make today, and we want your help. There's going to be live voting here. So please scan this QR code so that you can vote today for which technologies. We're going to build these into our live demo. That's what Victor's here for, not just a wallflower. To our live demo as we go today. So right now you won't see anything. You won't see anything until the poll comes up. So we have 4 system design choices. We're going to provision a production cluster. We're going to implement GitOps. We're going to add Ingress. And we're going to choose application configuration. So let's get started and help Hero live their dream and frolic in production. So first, we're going to provision a production cluster. Our CNCF choices for this are Crossplane and Cluster API. But before we dig in, we're going to talk about cluster provisioning generally. So there's a lot to consider when you think about cluster provisioning. Whether you're thinking about provisioning a cluster in the cloud or on-prem, no matter which bootstrapping tool you use, no matter what, it's going to be super complex. There's a lot to think about. You have to consider node sizes, subnets, VPCs, cluster authorization, node groups, roles, policies, security groups, gateways, route tables. It goes on and on. So no matter what technology you choose, the complexity is always there. You can't avoid the complexity. So then the question is, what are you considering when you're thinking about cluster provisioning tools? Well, first of all, you want your resources to be declarative. So definitely declarative paradigm, but more specifically, you want it to be declared with Kubernetes resources. So that has a couple of big benefits. One is that you can use the Kubernetes control loop to keep your desired state in sync with your actual state. The other big benefit is that, oh gosh, I'm nervous, it integrates well with all the other tools in the Kubernetes ecosystem. So for example, GitOps and observability, say. So with that, let's talk about the tools themselves. Cluster API is a focus tool. It does one thing. It provisions clusters, and it does that thing really well. So it works well with all different kinds of cloud providers, all different bootstrapping tools. It's a great job. Then we have Crossplane. Crossplane makes it so that you can interact with any API on the planet via the Kubernetes API. So one very popular use case for this is to provision clusters, but you can use it to do a lot of different things. Crossplane has a couple other benefits. For one is you can it has a way for you to offer a simplified interface. So people who provision clusters don't always need to know about all that complexity. Maybe you have developers that need to provision clusters. And so you can offer a simplified interface so they only see the knobs that are relevant to them. It also has a way for you to compose lots of things together. So you have you can provision not only a Kubernetes cluster, but maybe it also has attached to a Google Cloud database. And maybe it also has Knative already running in there. And it's all behind one simplified API. So to recap, Cluster API is awesome. It's a focus tool. It provisions clusters. It does an awesome job. Crossplane offers some more stuff on top of that, but if you want to, it's going to give you extra complexity that you need to mess with. And there it is. Let's have our first vote. What do you choose, Cluster API or Crossplane?
Depending on your choice, I might not have a job tomorrow.
Oh, Victor, they're rooting against you.
It's not, it's recorded, fuck.
Victor. A couple of people are struggling. Okay, Victor.
Okay.
There's no getting around it.
Shall we go for Cluster API then? Okay.
Yes, Cluster API it is.
Who said that?
You put your terminal on the...
Yep.
Okay, cool.
Terminal, yes. Okay, so Cluster API, right? Now, the only thing that I actually did in advance...
Will you make it bigger?
Yes.
Thank you.
Yes, I can. There we go.
Thank you.
Okay, so the only thing that I did in advance was to actually... you'll see what I did in advance. What does matter is that I defined this, this file here. Actually, you can auto-generate it more or less. That contains everything needed to everything. I mean, everything is relatively simple in case of Cluster API. All the resources required to define a cluster in AWS, right? No time to explain what each of those does. You can probably guess what the kind cluster means and what is the AWS managed cluster and so on and so forth, right? So I have resources here, and all I have to do is just say kubectl apply, and then apply, and the file. Okay, is AWS CKS YAML. Now, this is the only time that I'm cheating slightly, right? I already executed this command before, and don't blame me for cheating. Blame AWS. It takes 20 minutes, give or take, to create cluster. So kind of blame me for choosing AWS. You can do that, right?
How did you know that you were going to use Cluster API?
I knew that the audience will try to mess up with me, kind of like that. That was so obvious, kind of so. Yeah, a guy from Upbound who works with Crossplane comes and lets you choose, and you're going to choose Crossplane. Of course you're not, kind of like, come on. That was such an obvious thing from my side, right? So production, and if I get all the clusters. And AWS, whatever, doesn't matter. All the clusters, for example, you can see that my production cluster is provisioned 16 hours ago, meaning last night after a drink. Now, what I'm going to do is, first I'm going to leave you wondering how did I know it's going to be Cluster API. Second, I'm going to execute this command, which just which essentially, no, there we go. Which will go to the cluster, get the secret, transform it to kubeconfig, all the funny stuff. And I'm going to export kubeconfig. I'm going to call it prod. And I'm going to prove that the cluster is up and running, get nodes. And there we go. And I can interact with it. I can say create namespace production, right? And then we'll see what else you're going to choose. There we go. Cluster
all right.
Up and running, Cluster API.
Cluster API, will you put the slides back, please?
No. I want to see you talk without slides. No? Okay.
All right. So next up, we have GitOps. Our GitOps tools are Argo CD, Flux, and Carvel Cap Controller. So before we, just like everything, we're going to get some background information about the choice before we dig in on the tools. There are 4 main rules of GitOps. The first one is that you need to define your app declaratively. The second one, you need your application definition to be version and source controlled. This is almost always done with Git. The third thing, we want our GitOps tool to continually be pulling from Git to get the most fresh version of what's in there. And then finally, we need the desired state to be continuously reconciled with the actual state as was deployed. So this diagram, our application got deployed by the GitOps tool, but also it's going to make sure our application stays in the state as it's defined in GitOps, in Git, even as we change the Git definitions. So first up, we have Argo CD. Argo CD does GitOps, and it does GitOps really well. The thing that makes Argo CD stand out from the rest is that it has a really great UI. Next up, we have Flux. Flux does GitOps, and it does GitOps really well. The thing that makes Flux stand out, it has tighter integration with Helm. And then finally, we have Carvel Cap Controller, which does GitOps, and it does GitOps well. A couple things set it apart. One is you don't have to give root access to your entire GitOps tool. You can do that on a per application basis. And also it integrates well with the Carvel suite of tools. We're going to see another Carvel tool later in the presentation. So to recap, you cannot go wrong. Every tool does a really good job. Argo CD has a great UI. Flux integrates more tightly with Helm. And Carvel Cap Controller integrates well with the Carvel suite of tools. So what do you choose?
Now you can choose any.
Oh, wait. I don't have to choose. Oh, it's close. Ooh. Oh.
Okay, last chance. 3, 2, 1. Argo CD.
Argo CD.
Okay. So Argo CD, right? So I prepared some scripts to just help me set up, environment variables and stuff like that. Nothing really important. The only thing that matters with scripts, you always answer with yes to any question. You don't have to look what it is, right? So I already have prepared here Argo CD Helm values file that contains a couple of Helm chart values. The only really thing that matters here is that I set it to reconcile every 60 seconds instead of you waiting for the default 3 minutes. So I'm going to, and this is going to be hurtful now, upgrade -- install. I don't know whether I have it in memory. Probably. Yes. Okay, so I'm going to install Argo CD. This will take 30 seconds, give or take. You're going to hear now a joke about the stick. No, that's the answer to the joke. No, then some other joke. Yeah.
I have a Halloween joke. Oh, I don't know if it's appropriate. Well, I'm going to tell it now. Why don't zombies like to eat ghosts? Because they taste like sheet. I love how much you hate
Is it finished?
That was
Oh, it's finished, sorry. Okay. No more. You cannot, don't do those jokes. They're too. Okay. For Argo CD, I need to define 2 things, project and applications, right? Project is essentially all about defining the rights. What will Argo CD have permissions to do in your cluster? I don't come from security background, so I'm saying everything, right? And then somebody else will correct it later. So kubectl, apply, -- file name, Argo CD project, and I have the project created in my cluster. Now, there are 2 things I want to install first, which might or might be needed later. First, I'm going to set up Schema Hero, because the original intention was to show you schema database, but we will have no time. So what does matter is that I have Schema Hero files define in this directory schema hero in the, I'm currently in a repository, local version of the repository, right? So the second thing I need now is schema hero file. Now this is Argo CD application file that essentially in a nutshell says, hey, go to this repository, go to this directory, whatever is defined there, that's what you should be have running in a cluster. So you figure out what you want to put that there, I will synchronize it, right? So what am I going to do? I'm going to say Argo CD schema hero, copy it to the infra directory. There we go, right? And I have another file because I need cert manager for what I'm doing, and I have that defined as well. Cert manager, which in this case is not going to my repository for specific directories, they're just going to monitor the Helm chart that is defined here. Whatever is defined there is the Helm chart that it will use, and it will override a couple of parameters of that Helm chart, default values, right? So I'm going to do that as well. Cert manager, I'm going to copy it to the infra directory, right? And then I'm going to add stuff. I'm going to commit something, and I'm going to push. Now, the last piece that I need for Argo CD to work is the application itself. So this is app file, apps, that will tell Argo CD two things. First of all, there is this repository over there, and whatever I put in a directory, where is it? Apps, that's going to be application of applications, the root for all my applications in my cluster. And the same thing, repository and directory infra, that's where I'm going to keep the rest of the things that I need in my system, which in this case is schema hero for now, insert manager, right? So, did I push everything? Status? Yes, I did. Cool. Now, so I'm going to say, this is the first and the last time I'm going to actually interact directly with my cluster, unless I'm cheating. So I'm going to say, hey, Argo CD apps, there we go, apply this file inside my cluster, right? And from now on, Argo CD is watching and monitoring and doing stuff, and I can do something, get applications in all namespaces, and you will see that right now Argo CD figured out apps and infra directories, and inside of infra it found cert manager schema hero, and right now it is synchronizing the stuff. And if I do namespace, what is the name? Schema hero, here we go. Schema hero is running and cert manager is running, and now I can we can come to the application that, no, Ingress is next.
Ingress
we can
is
now
next.
use Argo CD to install Ingress and whatever else I might need. You need slides?
I need slides. Yeah, I didn't get a chance to change away from the poll, so we did it. And
now, this is a message to you Flux people, right? This is a similar story like UI. You come late, right? But it's already too late to change the mind. I'm sorry.
So now we have our fresh production cluster set up. We have GitOps implemented, and it's now time to implement Ingress. So our choices are Ingress Nginx, we have Contour, we have Emissary Ingress. But just like every single thing, we're going to talk about why do we need Ingress at all. So the way things go, once our application's running in production, it's not happy yet because it also wants to serve end users, and that can't happen until we have an Ingress in place. So once we have an Ingress in choice, that's going to be able to let us say what kind of traffic we want to let into our cluster, where it comes from, what kind of authentication mechanisms, and like a bajillion other things that aren't even listed here. So one thing that's hard for me as a newer learner to get straight about Ingress, at first when I learned Ingress, I thought it was all about, oh, there's the happy folks. Oh, this is what I want to say here. The Ingress turns around and it configures a networking layer that does the work of actually routing requests to where you want to go. That's one thing I didn't know when I was a new learner. And the other thing is I thought everything had to do with the native Kubernetes Ingress object. And so there's actually some pretty big shortcomings with the native Kubernetes Ingress objects, one of which is it doesn't give great status information. It can't easily do these more advanced things unless you add annotations. And then it also doesn't separate concerns well between different personas who want to use the native Ingress resource. So some of these Ingress implementations use their project-specific custom resources. In fact, that's just a common way to do it these days. And so not only do you have your project-specific custom resource, you also have different networking layers that are doing the work of actually routing the requests. So when you consider that there are like 30 different projects in the Kubernetes documentation, 30 different Ingress implementations, they all have their own custom resources. They use many different types of networking layers. It is a lot to navigate. And that's why we have the Gateway API specification. And I'm looking right at the Gateway API maintainer while I do this talk. No pressure. So the Gateway API specification, it's a group of resources that's meant to model the way service networking is done in Kubernetes. And that's all I have time to say about that. So good job, right? But anyway, we can help Hero live their dream, but they're not deployed in our cluster yet. Let's go ahead and get an Ingress implemented. So we have Ingress Nginx as our first choice. Ingress Nginx is maintained by Kubernetes and by the Kubernetes project. It does use Kubernetes Ingress objects to configure Nginx, which does the actual work of routing the requests. So it does have some of those problems that I mentioned before. You can add the additional functionality, but you do that during using modules that are in the annotations, which is unstructured data. Next up, we have Contour. Contour supports the native Kubernetes object, but it also has its own object called HTTP proxy. And then it uses Envoy to do the networking layer of routing the requests. This HTTP proxy resource, it does have separation of concerns between personas. You configure your additional things in the spec fields mostly, and it has a status field so you can know what's wrong. Also TLS cert delegation. And then finally we have Emissary Ingress. I believe the docs say that's an enterprise-grade self-service Kubernetes native API gateway. And so Ingress, it also uses Envoy as the networking layer, and then it introduces 3 custom resources. We have a mapping that's developer-facing, that gets the developer can define how they want traffic to get just to their application. We have a listener, which configures what protocol to listen for and what port to listen on. And then we have a host, where you can do host name with wildcards, and it also supports TLS. And with that, let's vote.
Nobody gives a damn about that. Okay.
I'm tied again. Oh, I think, what's it gonna be? Contour.
Okay. 5, 4, 3, 2. One vote. One vote. Come on.
Oh, you got Ingress Nginx it is.
Yeah. Contour folks are gonna complain. They're sitting right next to Flux folks later. They're gonna do it. Okay. So what did we say? Ingress Nginx, right?
Yep.
Okay. Cool. So I have defined here Argo CD. What did I call it? Nginx Ingress, right? This is since we are now using Argo CD, just yet another Argo CD application definition. I'm putting a couple of annotations and essentially telling it, hey, install yourself from this chart, and this is the version I want to use. So I'm going to take that CP, Argo CD, Nginx, put it into infra directory because that's the directory I'm monitoring inside of this repository. I'm going to add and commit and push, right? Now I should have, what is the namespace? kubectl, come on, namespace, Ingress Nginx. No, Ingress Nginx, Nginx get all, right? Within 60 seconds, give or take, Argo CD next cycle will figure out that there is something pushed to the Git repository. You need to start installing Nginx. I'm going to give it, and I'm not patient. Let's go to the next one and then I'll come back. No, I will wait. For some other thing that is AWS related directly, it takes horrible amount of time to propagate changes to DNSs. There we go, right? Nginx is being installed. We're almost there. If I do get services, SVC, There we go, right? It created the external load balancer in AWS because that's what I'm using. This is the address. Now I will use nip.io to generate the domain. And this is the part of DNS waiting until it propagates and generates the IP and all that stuff. Come on. Come on. Okay. Not okay, but we'll wait. We'll wait, and we'll wait, and we'll wait, and we'll wait. This is like Bart Simpson.
I have another joke. Why did the monkey fall out of the tree? Because it was dead. That would be like.
Okay, this is a genuine smile now this time. Yes. Okay. Okay, let's. We'll get back to it. We'll get back to the monkey. Wait until I get the IP. We can go to the next choice.
Now we need to define our application with application configuration. Our choices are Customize, Helm, Carvel YTT, and CD K8s. Back to me and my new beginner, my learner's mind brain, I didn't understand why we needed a technology for this. Like, what's so hard about it? Why don't we just put it into YAML? So now I'm slightly more seasoned. I can see that there's like application definition itself. There's all the supporting services. There are the environment variables, the Kubernetes specific stuff, the infrastructure specific stuff. It gets to be a beast. So we need tools to help us manage our application configuration. First up, we have Customize. Customize is built into Kubernetes with the apply-k command. It uses a patching strategy where you have a base manifest, and then the changes that happen between your deploys, you describe those in small patch files. And then once you're ready to deploy, the patch is overlaid onto the base, and then it gets deployed that way. So it's a patching strategy and customized. Next up is Helm. Helm is a package manager for Kubernetes. You've likely interacted with it if you install third-party stuff into your cluster. It uses a templating strategy where the values that are likely to change between deploys are factored out, and then you have them in a separate values.yaml file. It also adds the dynamic configuration with Go templating. Next, we have Carvel YTT that does both patching and templating within one tool. It also adds those dynamic capabilities with a Pythonic language called Starlark, and you add that in with the YAML comments. So it's YAML all the time. It can always be processed and validated as such. And then finally, we have CD K8s. With CD K8s, you can define your application in any language you want, as long as it's Java, JavaScript, TypeScript, Python, or Go. You can bring your CD K8s library, can have your company best practices, developers bring that into their IDE. They can interact with simplified Kubernetes abstractions, seeing only what they need to know. Once they've written the CD K8s code, do a synth command, which will synthesize the code into pure Kubernetes YAML that can be deployed to any cluster. So to recap, Customize Helm, Carvel YTT, CD K8s, what's it going to be?
And while you're choosing, I'm going to go back.
Wait.
Okay.
Oh, I guess they could see the interface
I'm going to
on your phone
not going
still,
anywhere.
even
You're
though you
choosing
can't see
it.
it up here.
Export. Now you're putting pressure on me. Okay. A couple of variables. Class name. Class name is going to be Nginx. Nginx, and I need to define the domain that I will use for my application, the one that you're choosing right now, and that's going to be nip.io. Cool. Now you're choosing, right? Continue choosing.
All right, put it back. Oh, do you need that?
Oh, no, yeah, choose it.
It looks like the people have spoken.
Helm.
Helm.
I'm disappointed.
Yeah, this is a first.
Such an obvious choice. Such an obvious choice. Okay.
All right, 3.
No, I kind of copy
two,
you. They're going to change their mind. No.
I'll
Okay.
give you a chance.
Yeah.
All right.
Okay. Let me do that. Minor script first the setup. I define it for all and Helm message. This is the one that you say yes to all the choices. Cool. Now, what I'm going to do is Argo CD. What is the name? CNCF demo Helm. Right. I'm going to copy the definition of my application to the apps directory because there's a directory that I'm monitoring. cncf demo.yaml. There we go. I need to change a couple of things. Wait, echo domain. This is now a lot of pressure, people. Since it's Helm, I need to change a couple of values in Argo CD app. I just need to remember which ones I'm changing. The ingress host is going to be different. Come on, Shift A. Come on. There we go. There we go. Up. Okay. I'm going to call my application silly demo. Silly demo.app. And what else? Ingress nginx is ingress. That's cool. Tag. Where is the tag? I don't know. Pressure. Nobody knows. Who cares? Who cares about tags? Okay. So where is my application defined? It's defined here, cncf demo. Right. This is Argo CD repository. It will use a Helm chart defined in this directory, and it will overwrite certain values in that Helm chart. And then if I do git add and git commit and then git push, my application will be defined as Helm chart, is defined as Helm chart, and it will be up and running one time in the future. And get all, you will see it up and running here within 60 seconds. And we don't have time for that, so you will never find out whether it worked. Yes, you will. Now you found out also the schema here doesn't work. But no, it will work eventually. Anyway, my application up and running, and it will be accessible through Ingress, through Nginx, through the domain. Where is it? eng here. Over there. It's up and running. Thank you so much.
Woo! We put the slides back up?
No.
That's it.
She likes to give you orders.
This QR code, we have a demo. If you wish we made different choices, if you don't really respect your peers' choices and want to make your own, you can go to our demo and you can play with all these technologies and choose your own path for Hero. So thank you so much, y'all.
Thank you so much, guys. It was a great adventure, really well done. And sorry, we are run out of time for questions, but if you want to hang around with the guys, everybody will be around, so just feel free to contact.
No, we will not be around.
Well, they will be here for the whole week, so probably at some point you will catch them. No worries. Thank you so much.
Thank you. I have stickers around.
for a talk about webhooks. What's the worst that could happen? And this is, so I'll hand it over to Marcus Noble.
Thank you very much. Yep, so I'm going to talk about webhooks and Kubernetes and kind of what is the worst that could happen. I hope you're all kind of awake after lunch. I hope you had a nice lunch. Before we get into that, let's just get to know each other a little bit. As I said, my name is Marcus Noble. I'm currently a platform engineer at Giant Swarm. I'm a CVO ambassador and one of the new CNCF ambassadors, as in the fall. If you want to get in touch with me, if you want to talk to me about this talk or anything else, you can find me on Mastodon generally at marcus@k8s.social. Or if you want to get in touch with me on any of the other thousands of platforms, everything's on marcusnoble.com. You can reach out to me and we can chat. At this point, I've got about 6 years worth of running Kubernetes, 6 years of experience running Kubernetes in production. Over that time, I've had a whole bunch of different roles. So I started out as an app developer, deploying Node.js applications onto Kubernetes. So I was a consumer of Kubernetes clusters. I then moved into like a DevRel role, not DevRel, DevOps role, sorry, where I was managing like a couple clusters for a single team. Then moved into more like R&D, where I was building out tooling for an entire company, and then finally into like a platform engineering role where I was building, maintaining, and managing clusters for customers. So I've kind of had a lot of different personas working with Kubernetes and kind of the different ways that different people deal with Kubernetes and interact with it and all this kind of thing. So over that time, I've hopefully learned a lot that I'm able to share with you, and a lot of pain that I've had over that time that I'm about to share with you. So webhooks in Kubernetes are powerful things, but with that power comes risks. So before we get into that, I just want to make sure we're on the same page as to what I'm talking about when I talk about webhooks. We're specifically talking about the webhooks within Kubernetes, so validating webhook configurations, mutating webhook configurations, the custom resource conversions with CRDs, and more recently, the validating admission policy, which is not technically a webhook, but in the same kind of area. We're talking about these sort of things. There's a lot of uses for these webhooks, for this functionality within Kubernetes. They've become quite a core part of pretty much every cluster that people work with. So I loosely see these as grouped into 4 different categories. There's a lot of defaulting logic, so this is where your mutating webhooks come into play. This is things like injecting of image pull secrets into namespaces, so your developer teams don't need to know those credentials, they can be handled automatically. Injecting of sidecars, so for example, Istio back in the day, it automatically injected a sidecar into all pods created, and that was through a mutating webhook. There's also things like policy enforcement, so in an enterprise environment, this is used quite heavily to make sure things like the latest tag is not used on any Docker images because it's mutatable. Who knows what that could potentially pull down at runtime? It's not verified and all this kind of thing. And that's generally enforced through a validating webhook policy. And a bunch of other things. We've also got best practices. So this is things like ensuring that your clusters have things like pod disruption budgets or a minimum number of replicas in your deployments to make sure that the applications that you are deploying to that cluster are resilient, reliant, and can be kind of trusted. Sorry, the rest of my teams just showed up. And finally, like problem mitigation. So this is one of my most favorite areas where webhooks come into play within Kubernetes. We've heard a lot about security throughout the day so far. Webhooks, especially mutating webhooks, can be used to actually avoid things like CVEs and stuff like that. So who remembers the log4j issue from a few years ago where basically all Java applications became vulnerable to it effectively? This could be instantly turned off through a mutating webhook. So there was a particular environment variable you could set with a particular value that effectively shut off the code path that was vulnerable. So we were able to fix we were able to mitigate this problem in all our clusters by setting a mutating webhook that injected this environment variable into every pod that was created. Didn't matter if it actually had log4j or not. We just applied it to everything, and then the entire cluster was safe. Very cool sort of things you can do with this. So let's have a quick look at the life cycle of a webhook and how it plays in the API requests and stuff. So in this example, we're going to deal with a pod resource. We're going to create it, update it. It doesn't matter exactly. But what we do first is we make an API request to the API server, and we say, create new pod. What that first does is the API server will have a look at all of the mutating webhooks within your Kubernetes cluster, iterate through them all, and see if any of the rules that they define match against the API request you are making. So if they apply to pods, if they apply to creates, things like that. Any that do apply, it will perform the actions that it states, and then it will move on to the next thing. The next thing is CRD validation, schema validation. So if the mutating webhook has made changes, it then checks to make sure that it's still a valid schema that it's working with, still a valid type. Then it moves on to the the validating emission policies. So these are the new ones that are introduced in 128. Goes through all of those and checks if the rules match or not. If it doesn't match, it will block the API request and return an error. And then finally does the same for the validating admission controllers, which is the webhooks. Now that order that I've just gone through is set, but it's worth noting that in each of those blocks, the order that it actually applies those webhooks is not guaranteed. Technically speaking, it generally does it alphabetically today, but there's no guarantee that that is the case, and there's no guarantee that another webhook might be created at some point that alters that order for you. So don't rely on one webhook running after another webhook. Once we've gone through all that, finally it can be persisted to etcd as long as everything along that chain has said, yes, this is an OK request, go ahead. So that all sounds great, right? We can do all these nice things with webhooks, we can default, we can have policy enforcement, etc. So where is the risk? I want to give you a little quote from a blog post on the Kubernetes website. I'm going to read this verbatim with some extras. Admission webhooks can be burdensome to develop and operate. Each webhook must be deployed, monitored, and have a well-defined upgrade and rollback plan. To make matters worse, if a webhook times out or becomes unavailable, the Kubernetes control plane can become unavailable. The Kubernetes control plane can become unavailable. Now, I don't know about you, but that's a pretty big risk in my books. I don't want that happening to my clusters. And this is from the Kubernetes blog, pretty big deal. So I wanted to have a look at kind of what the risk is here. So I had a look at 129 of our customers' clusters and get some numbers as to how many webhooks we are dealing with. Of those 129, all of them had some form of webhook in place. They had at least one validating and one mutating webhook. Overall, they had an average of 9 validating webhooks per cluster and 7 mutating webhooks per cluster. The cluster that had the most validating was 25, and the most mutating was 15. So this isn't just like a small risk we're talking about here. This is quite widespread and in pretty much every cluster. And the numbers here was a mix of dev, production, staging, clusters of varying sizes, massive ones, tiny ones, all this kind of thing. So it was across the board. So how bad can things actually get? Seeing as you're all now energized after lunch, I want to play a little game with you all. I'm going to show you some scenarios of either misconfigured or malicious webhook configurations, and I want you to decide through a show of hands whether you think it's going to break the cluster or not. So raise your hand if you think it is going to break, keep it down if you think it's going to be fine. Sound good? Yes? Cool. So the first one is a different content type. So in this scenario, our webhook service is going to return a response that has a different content type header to the actual response body. Who thinks that the Kubernetes API server is going to break in this scenario? Things are going to go bad? Okay, a few of you. Okay, yeah. No, it's absolutely fine. Absolutely fine. The API server completely ignores the content type header and just treats everything as YAML. It expects that whatever you're returning back is YAML or JSON because it also supports both. Absolutely fine. Doesn't matter. So the next one, a cutoff response. So in this scenario, we're going to set a content length of like 1 billion. But our actual response is just going to be a normal response. So it's going to effectively expect more data to be returned. Who thinks this is going to break the cluster? A few of you. Okay. This is fine. So yes, you get an error returned back, but the API server correctly understands that, we were expecting more, but it didn't appear. So you get an error, but the cluster itself is still okay. So a redirect. So in this scenario, we've got multiple webhooks here, and the webhook is set to redirect to somewhere else. So when the API server does the request, it's going to get back like a 301 or whatever response to say, go look elsewhere for it. It's going to keep doing that infinitely. So it's going to keep sending the API server somewhere else. Who thinks this is going to break the cluster? A few more. Actually, this is fine. They've thought about this, and there's a limit of 10 redirects. If it hits 10, it goes, this is ridiculous, I'm going to stop. And throws an error back, but handles it fine. A label override. So this is a misconfiguration of a webhook service, and what this does is it has a mutating webhook that is trying to add labels to the resources being created. So it's trying to say, modified by webhook XYZ, something like that. But it mistakenly overwrites all of the existing labels rather than adding to them. Simple enough to do when you're creating a JSON patch response. Who thinks this breaks? Okay, not as many. This breaks. Oh my God, so many pods get created here. So many pods. So in this scenario, when we're creating pods, it overrides the labels on there so that the label selector on the deployments and the replica sets no longer match. So it creates another pod to replace it. Again. And eventually you saturate your entire cluster with hundreds of pods. If you have auto-scaling involved, I hope you've got an upper limit, put it that way. So yeah, this one isn't great, but this is hopefully easily caught during development because we check these things before deploying to prod, right? Okay, reinvocation. So webhooks have this property on their spec called reinvocation policy, and you can set this to a value called if needed. What this means is if more than one mutating webhook is applied to a request, if the resource has changed, we want to reinvoke our webhook again to make sure it runs against the most up-to-date version of the request. In this scenario, we have two webhooks that both want to reinvocate, and they're both changing each time. So we're effectively like adding the timestamp as an annotation, for example. Who thinks this is going to break? Okay, few hands. This is actually fine. The Kubernetes actually will only allow you to invoke a webhook twice. So you can only reinvoke once more. After that, it's like, nope, we're done, we're going to move on, we're going to do other things. So it says here from the documentation quite clearly, if additional invocations result in further modifications to the object, webhooks are not guaranteed to be invoked again. It's fine. Fork bomb. So this is what I'm calling a fork bomb. It's not technically. But the idea of this is it's a webhook that triggers other resources to be created that in turn re-trigger the webhook, right? So in the scenario here, I'm creating a webhook that responds to an event resource being created. And as part of the handling of that webhook, we are creating an event to say we've handled it. So we're going to basically call it again. Who thinks this is going to break the cluster? So a few more. It depends in this scenario. So it very much depends. We've seen scenarios of this in production where it's effectively denial of service itself because it's created too many requests and the API server then can't handle it. If you've got a large enough cluster, this is likely to happen. Also, that resource in this scenario events is going to keep building up in the cluster. So you're hopefully eventually going to hit some sort of limit, etcd limit, resource limit, whatever. Things are at the very least going to start slowing down because you've got more resources you're dealing with. So it very much depends in this scenario. Okay, finally, data overload. So in this scenario, our response is just going to return as much data as possible. Just random junk. We're just going to stream as much data as we can from the crypto rand package in this specific scenario. We're not going to give it a valid response. We're just going to say, here's a bunch of data. Just keep sending it to the API server. How do we think of this? Going to break the cluster? Okay, not many. Okay. Yeah, this blows up. The API server just dies. It cannot handle this. To resolve this, I had to restart the API server, effectively like restarting the node or whatever. I was able to mitigate this by reducing the timeout seconds property on the webhook itself down to something small, but the default of 10 seconds broke the API server. It did not like all that data coming into it. It just locked up and was unusable. So what's the actual risk? I mean, there was a few scenarios, but generally you would have caught them early before it goes to production. So what's the actual risk we're talking about here? So the actual risk of webhooks is more, they're rarely the cause of a problem, of an incident or whatever, but they have a tendency to exacerbate them, to make a situation you're dealing with much worse. So when something falls over and webhooks are then involved, things get much harder to resolve things and all that kind of thing. And because that webhooks are on that critical path, so we saw earlier that every API recall goes through all of those webhook calls if they match. If they fail and fail in a non-resilient way, that's going to have a knock-on effect to everything else as we're trying to fix things. So you don't want to be dealing with these things like at 2 a.m. when you're dealing with a P1 incident or whatever. So we've seen examples of this. So the Reddit incident, the outage on Pi Day, not necessarily related to webhooks exactly, but there was a scenario where they suspected the webhooks were at fault. They were causing problems with them debugging, so they basically got rid of them while they were investigating. At Giant Swarm, we've seen a couple issues of this. So during a cluster upgrade, a webhook failed to come back up, which prevented then the API server pod from being created because it couldn't call the webhook and couldn't create itself. Not ideal. We've seen issues with an availability zone dying, and all of the webhook pods were in that availability zone, instantly not available, and then couldn't recreate themselves because they were blocked by themselves. And countless other issues. I've heard people tell me all sorts of stories about this. So basically, they're not really the cause of these problems, but if they're not built in a resilient and self-healing kind of way, they make a bad situation much, much worse. So what's the fix? Not a huge lot in a lot of scenarios, but there are a few things we maybe can do. One of the things, if you're building these webhooks, please try and set the failure policy to ignore wherever possible. So this means that if the API server failed to call the service behind the webhook configuration, and it returns an error, it times out whatever, the API server is just going to carry on with whatever it's doing and not stop that creation. So if it's pods that you're creating, it's going to still create the pod even though it failed to call the webhook. Now this is all well and good, but if you're having webhooks for like security reasons or anything like that, not ideal. You don't want this way around it. So it's not every scenario you can do this. Wherever possible, please try and make use of things like the namespace selector and the object selector on your webhooks. So this allows you to limit what resources actually trigger against the webhook. If at all possible, please, please, please ignore the kube system namespace in your selectors. You want to make sure that those system critical pods are able to be created wherever possible. And ideally, target specific labels that you know your resources are going to have if you can. Wherever possible, auto-remove your webhooks when the service that's backing them scales down to 0. So Kyverno is a tool that kind of abstracts webhooks for you so you can do them in a more cloud-native way. They have a really good implementation of this where they have a shutdown trap that when they detect that they are the last replica, they will get rid of the webhooks, the webhook configurations within the cluster so that once that pod is gone, those webhooks are no longer going to try and call it. So it safely cleans up after itself as it shuts down, which is very nice. Otherwise, because it triggers the webhooks against everything, it's going to cause problems for everything else. Do you even need the webhook? If at all possible, maybe whatever you're trying to do can be done as an asynchronous operator that's not blocking. So if whatever you're doing is trying to add some labels on or add some annotations or metadata or whatever, maybe that doesn't need to be done at creation, but can be done immediately after creation as a background job, the background controller that runs in your cluster that doesn't kind of block that critical path. During an incident, wherever possible, you might want to just scale down you might want to disable your webhooks while you're investigating things and fixing things so that they don't get in the way and make things worse. Don't do this as your first reaction because you may make things worse by doing so. But if you are finding yourself fighting against some of these webhook services, you may want to scale them down. Disable the configurations. Have a look in your API server logs to see if there are errors about failed to contact webhook, or something along those lines is the error message. If you haven't already, I highly recommend you review this Kubernetes admission control threat model that's provided by SIG Security. I'll message out these links and stuff later. But they've done a really good job of explaining all of the different threats with admission controls and things like that. And finally, if you can, when it's available, 128 onwards, make use of validating admission policy. So we're going to have a quick look at what this is. So this is cell-based admission control. So unlike webhooks that actually call out to a service running in your cluster. This will run some cell expressions in the API server itself. So you have a couple resources that you deal with here, a validating emission policy, which kind of looks like this. You have some match constraints and some validations. It's very similar to how the webhooks look, but again, this runs all in the API server, so there's nothing that can be failing or scaled down that's going to cause issues. So in this scenario, we're creating something that ensures that, that all deployments have at least 3 replicas. And then along with that, we have this validating emission policy binding. You tell it which policy you're associating this with, the validating actions, what to do. In this scenario, we're going to deny because we want to block it. And then the match resources. So in this scenario, any namespace that has the environment production label on it, that's where we're going to apply this. And this is what it looks like if you don't do that. So here I was trying to do a deployment with a single replica, and you get an error like this. And this was all handled by the API server itself. So as long as you're able to contact the API server and it's running, you can do validation without a problem. There's a bunch of other things that also come into this. It's quite a new tech within Kubernetes. I highly recommend you having a look at it, but it does require 128 onwards in a more stable manner. There's things like parameters, variables, and like custom message warnings and things like that you can do. So you can have quite dynamic configurations in here that look up from other resources and things like that. Highly recommend looking at the official docs. They are fantastic. There's a lot of detail that they go into. So, in summary, webhooks are rarely the actual cause of problems, but they do have a tendency to make things worse. Be very, very aware of that critical path. So the API requests that go through every single one of these webhooks. It may not necessarily even be webhooks you created. There's a lot of third-party applications that have webhooks as default. We have them with Istio, Kyverno, Linkerd, all these kind of things come with webhooks by default. They're not always in the best HA configured state, so you may want to review the ones that have been installed that aren't under your control. Ensure that they're resilient and highly available. You want 3 pods behind all your deployments, multi-AZ, etc. And where possible in the future, move to validating admission policy instead. And with that, I'd like to say thank you. All of the links and code to the scenarios that I showed you earlier are available at the link at the top or the QR code. If you want to reach out, any more questions, etc., get in touch with me. And thank you very much.
All right, we do have time for questions, so anybody want to ask a question? Anybody want to take pictures?
So while you're doing the research on all these scenarios, what was the one scenario that made you squint and go, how did that even break things?
Anybody else? All right, thank you, Marcus.
So, as I said, I'm a principal engineer at Cloudera. He's a senior staff at Cloudera. We are pretty much architects and leads for the tooling that we do at Cloudera in the DevOps streams. We use Kubernetes, OCP, VMs, in-house, in the cloud, everywhere. So, and also we do a bunch of tooling. So we build around 10,000 containers a day, and we have around 50 plus products that we offer. And it's a very vast and huge scale that we operate at Cloudera. So for us, I mean, we have multiple products, and pretty much except to everything else is in container mode at this point. So we basically deal everything in containers every day. So what we did was, in order to eliminate the duplicate base images, we just normalized the base images so that all applications could use a single set of base images, which helped us in maintaining and rolling out the CV issues. And then we have a bunch of third-party images that our applications uses in production. Even this, we try to bring it in-house, run the CV scans and normalize them and make sure they are security compliance, they meet the security compliance before we roll it out. And then the application images, this is our IP. So Cloudera, we generate like around 1,500 application images overall. And then the volume of builds that we do, there are a number of images that we handle on a daily basis. So that's around 10,000 images that we build a day, and our registry size is of 40 TB, even after regular cleanup and everything. And as I mentioned earlier, security is a big step in our Cloudera, whatever we do, because we need to meet the security compliance standards and everything. So CV fixes and the CIS benchmarking. We do a lot of image hardening steps in our images that we roll out to the customers. And once we have hardened the images, I mean, it reduces the area for the security attacks. And CVE management, as I mentioned before, we track CVEs using EchoSec, which scan all the images, and we try to fix critical and major CVE issues as soon as possible, and we just roll them out. So everything was going smooth. Both our lives were happy. We were just functioning it, and one day Apple came up with their silicon processor. And suddenly we saw these Macs coming into Cloudera, and the developers started complaining that they couldn't use these images on their machines to test it out and do development work, right? So that moves us to the topic multi-arch at Cloudera. So with the introduction of Apple Silicon MacBooks, we were asked to solve the problem of developers using the images in their work laptops, and that introduced us to multi-arch images. And after that, we found more use cases where we could actually roll it out to the customers as well to use them on ARM-based machines in the production, which could actually cut down their cost by 40% and giving the same throughput. So we wanted the ability to run these Docker images on multiple CPU architectures. And as I said, the Graviton, the AWS Cloud offerings for ARM and everything, I mean, these are eco-friendly CPU architecture because for less compute, you could still get the same throughput and reduce the cost as well. And we wanted to achieve seamless migration from one architecture to the other rather than building images for different architectures and releasing separately. So we wanted to have one solution that works on any architecture. And better performance and cost saving. And then as I mentioned about the third-party images or the external images that we use in Cloudera, so now that we introduced the topic of multi-arch, the first problem that we saw was how do we bring these multi-arch images from external and roll it out? So with the regular Docker images, we didn't have a problem because it's a regular Docker pull and push. So we used to pull from the external registries, be it Google, Microsoft, Docker Hub, wherever it is. And then we used to host them in our registries internally. But with this multi-arch, I mean, it comes with many flavors. We didn't want to tag or track images per platform kind of a model. So what do we do now to scale the external images and still not break the developer functionality and the production of functionality. So it turned very complex. If you were to treat image per architecture, we just made it simple by using Scopio. Right? So Scopio came to our rescue. So Scopio was able to handle everything with a single command and still treats images as a single image, though internally it tracks different architecture-wise. So we were able to perform various operations on the container images and the image repositories. In addition to just pulling and pushing the images to our registry using Scopio, there is one more functionality that we were able to leverage Scopio with, which I will cover in the next sections. So using Scopio, yeah, we were able to copy all these multi-arch images from the external sources without losing any platform-specific data. So this is a quick way of just demonstrating. So we just do a single pull command, same tag, we don't mention anything specific to architecture, but when the pull comes, right, it just considers the host CPU architecture, and based on that, it resolves automatically to the right image layer. So that's the external images. Now let's move on to building the multi-arch images at Cloudera for our applications. So to build these multi-arch images, we adopted BuildX instead of the regular Docker build because it was able to build multi-arch images, and we also leveraged QEMU to emulate the architecture during our build process. Instead of building our applications on different platforms for different architectures, we just used x86 as our base and then still continued building or generating multi-arch using QEMU emulator. So thus we were able to build and generate images for multiple platforms, AMD, ARM, Apple Silicon, V8, etc. So we could also have done differently, like using BuildX. BuildX has an inbuilt capability of doing a distributed image builds on different architecture using Kubernetes. But at Cloudera, we didn't have this architecture, and that was a big project by itself to support multi-architectures, in the Kubernetes cluster, because our Kubernetes is in-house, and we didn't have any ARM-based machines in our data center. So what did we do? So we used a Docker container driver, which with emulators for different architectures. So our host is still x86, and we have different operating systems running on it, but using the BuildX and the Docker container, we were able to build our multi-arch images internally. So these are the set of commands that we used before we did any Docker builds. We used to set the context. Instead of using the Kubernetes distributed model, we were using the emulators, right? So we used this open source project to run and build containers for any architecture. So thus we were able to build distributed Docker images for ARM, PPCs, and various architectures. But emulators do have their own drawbacks. It's not a perfect solution because it does not provide the full range of functionality that is available in the native environment. As opposed to building on an ARM-based machine, emulators do have some disadvantages when it comes to native libraries and stuff. But and then it also could result in missing or incomplete features in the built images. But that wasn't a problem in Cloudera because for what we are doing, it's not really depending on any native libraries in the ARM-based architecture. So this is a simple workflow that we designed and implemented. So without changing much functionality in a regular build system on how we generate a regular x86 images, we just made little changes and still were able to achieve multi-arch images. So depending on what kind of image we are trying to generate, it uses either Docker build or Docker BuildX. And then once the build is successful, the image is successfully generated. Depending again on the architecture of the image, we either do a Docker tag or we used Scopio to generate these OCI tarballs. I will explain why we had to use this OCI tarball model in the next slides. And then once the manifest is created, we used to either stitch it up or just push it directly to the registry. So as I said, we were using Docker build for a while, like few years now. I mean, the whole build system, developers, scripts, everything was tied up with build, Docker build commands and everything. But now with the BuildX, we didn't want to make it a big deal in the development community at Cloudera, like as in to change the build scripts and everything from Docker to Docker BuildX. So what we did was we just came up with a small wrapper around the Docker CLI, and that wrapper, it manipulates the Docker build command to be like Docker BuildX, and a little more tweaks we were able to achieve it. So we were able to successfully switch to BuildX without disrupting any developer workflow. And also the BuildX, by default, it creates the SBOM so that it has all the Docker manifest and everything that we could use it. And one of the disadvantages of this is it's not compatible with the older versions of Docker, which we were having in production, and they were not yet ready to move to multi-arch. So we were also challenged to do it backward compatible. So we just used a flag that BuildX provides, and thus we were able to achieve backward compatibility. So another thing we had to do was improvising the manifest generation code that we had to create the multi-arch images and distribute them correctly. So we improved that to create manifest lists, which allowed users to pull based on the architecture of the underlying platform. And also we use Harbor and ECR for all our registry storage purposes, and these registries, they support multi-arch out of the box, and we had no issues continuing using them. And previously I mentioned about the OCI tarballs in the flowchart, right? So let's look at what these OCI tarballs are and why we had to do this. So traditionally at Cloudera, what we do is we only do a Docker build from the build scripts, and then we have a build framework that takes all these built images and then tags them depending on the registries and uploads to the registry. But we do it as a final step of the build rather than building every image and pushing it. We used to make sure that if an application produces, like say 10 images, we want all those 10 images to be generated successfully before we even start publishing them, so that we don't end up with partial build images in the registry and making it a problem for cleanup and everything. Right? So for that, we treated build and push as two different sections and actions. So build happens within the build step, whereas push is actually a wrapper, a section in the build framework that actually takes all the images that are built and it pushes them to the registry. So that was with the x86 model, with a single platform. Right? Now with multi-arch, the Docker BuildX, by default, it publishes every image as it builds to the registry. And it breaks our fundamental approach as not to push partial images, right? Partial built images. So what did we do? We didn't want to continue with that, so we had to do a separate design for that. So we leveraged OCI tarballs. So using the BuildX, we were able to generate OCI tarballs, which still live in the local workspace. The reason why we couldn't do it with BuildX is the built images for QEMU, using QEMU emulators, they don't save the images in the local Docker workspace, right? It rather pushes directly from the emulators. But whereas here, to save the images locally in the Docker's workspace, we had to leverage by creating OCI tarballs. And once we create the OCI tarballs for all the images, and if all the images are built successfully, then we take these OCI tarballs and push them to the registry. And that's how we were able to ensure the atomicity and consistency across all the builds. So this is a simple command that we had to use before generating the Docker images, and that enabled us to create OCI tarballs using BuildX and not just push images directly once an image is generated. That's the whole image generation part. So next is we need to sign the images. So that's where we'll see the next section.
Yeah, thanks, Shesha. Next step is, now we build the images. So next, improving the supply chain security and, keeping the integrity of the images. So how are we handling it in Cloudera? Is it audible? So like there are various challenges signing and verifying container images that we build. Like there are multiple tools available, and multiple tools comes up with different features. So what we had to do? So we had evaluated different tools and we came up with a solution. And why do we need container attestation and integrity? The first one is trustworthiness of the product. Like as the many supply chain product, that we'll have to maintain that, hey, this image is coming from Cloudera. There is nobody in the middle attack, can go and change the images, modify the images and deploy in the customer environment. To do that, we are using container attestation. And also it maintains the SALSA level 2 standard and protect from supply chain attacks. So these are the different things, we kind of evaluated and come up with a solution. So Notary, so this is one of the provider that we have evaluated. The one of the pros is like, it is easy to use with Docker CLI. But with the container world, we use Podman, Docker CLI, and different kind of CLI, for the building container images. And it is easy to integrate with OpenShift, and also it supports, PKCS 11 via GPG. But the main con with Notary is like you'll have to maintain the signature server. So maintaining signature server when you are operating in large model, maintaining the signature server is going to be operational overhead. So for that, what we want is like we preferred serverless solution. And also there are multiple cloud native service solutions. For example, there is AWS Image Signer from AWS and Image Integrity from Azure, and from GCP they have their own native support for signing the images. But it all works fine. Yeah, these are all the great tools. It works perfectly fine. For example, if you are doing in AWS, you can use AWS Image Signer. But since we are on a hybrid cloud, it is not the solution for us. So because it is not the cloud agnostic, then after everything, we come up with a perfect solution, Cosign. Cosign, since we built all the images using OCI, this container signing verification and storage in OCI registry, which is handled by Cosign. The multiple advantages, what you can see here is like it is cloud agnostic and supports containers and blobs. It is not only containers, right? We have multiple other files and platforms we'll have to sign. So Cosign really helped with that. And the signatures are not really attached to the image. So signatures are detached from the image so that even if you are building multiple versions, what is happening is like you have the particular SHA what you have signed, and you can use it for the verification. And you don't need the different signature server, and it's a very simpler architecture. So yeah, this is our winner. And what is the how are we signing containers with the Cosign? And when you are signing containers, again we'll have to protect security. It is not like you have the private key and public key. I'm signing it from my containers and giving it to our customers. So we have to maintain that integrity and security in our system. So that's why what we have done is like during the CI/CD process, we are just not building the using the private key. So instead of that, what we are doing is like we are using the projected token. So we are creating the projected volume, and from that, we are authenticating with the AWS KMS server and signing our containers. Yeah. So every time when the pod gets launched, right, every container gets a new token, and we do not want to share all the this token with all the namespaces. For example, like let's say I'm building in namespace A, and namespace B in the cluster you are building something else. But we do not want to this token to be worked with the namespace B. For that, what we have done is like we have restricted the access to specific namespace in the cluster. So yeah, everything is working fine. As we mentioned, right? x64, everything works. There is a single layer, single SHA, everything works. But what happens when there is a multi-arc containers? So you know that for multi-arc containers, for each platform, there will be a different SHA. For example, SHA-256 for ARM64, and there is a different SHA-256 for x84. So for that, what I had to do is like, cosign kind of supports that. Like once we sign that, it signs all the containers as a top SHA, and each platform it signs as a different SHA. So it really helped us to solve the multi-arch solution as well. Yeah, this is our common command what we use to sign the token, sign our images. Here you can see that we are importing the AWS role to get the token to sign with our private key, and we have the projected identity token file which is mounted on the Kubernetes containers. So you can see that it is running on the where run secrets, and it's a normal token where each pod gets a new token. Yeah. So okay, now we signed. Everything is fine. No, everybody what they do is like they done the signing and say that hey, our job is done. But your job is not really done when you just sign the containers. So you'll have to verify those containers. So, but how we are doing the different verifications? You know that most of the developers, like there is a development process happens. Then we'll have to push to production. So all the builds or the versions what you publish, which will not go to the production. So what we do is like you use cosign verify command with the public key, and only promote signed containers to production registry. If the containers are not signed, either it's a base images or the third-party images or even our IP images. If they are not signed, we are not promoting them to production registry. So like as I mentioned, fail build in case of the verification is failed, so that customers will not have to face this kind of issues in the production. And that happens in the promotion stage. Yeah, everything is fine. Okay, we have verified it in the promotion stage. What happens if somebody comes and attack, like customers have not secured their cluster? What happens? Somebody comes and try to attack the clusters and try to change the images in the middle. So for that, what we are doing is like we are doing the verification in the Kubernetes cluster. And for that, what we are using is Kyverno. Kyverno has it has a very good policy administration. And we can, with that, we can check SHA-256 digest attached to the available, or images, whether images are signed or not. If the images are not signed, when the containers are not coming up at all, that policy itself is restricting that pod is not coming up. And using all this, like we could able to build all the multi-arch images, sign the artifacts, and verify all the containers in the production and the Kubernetes clusters. That way we are maintaining all level of security. And this is our high level overview. As you can see that, as Shesha mentioned, we are using hybrid clusters. We are using on-prem clusters, and we are using RK2, and we have AWS, and we have different kind of models. And as we say that, in this one, you can see that we are using publishing container process as part of the build process, and we have installed different things like Scopio, Cosign, and our pod containers. And our pods are as, our Kubernetes cluster is talking to our AWS KMS OIDC server, and from that, we are signing it. And once everything is done, we are publishing into different Docker registries. Either it might be Harbor or ECR or different container registries. And once it is done, okay, everything is, that's where the signing part is completed. The signed artifacts is uploaded to registry. Then during the deployment side, this is where the CD comes into the picture. So what we are doing is like whether it's OpenShift or Cloudera provides different solutions for both private and public clouds. So we have Kyverno installed on the control plane. So it is checking the policies, like saying that hey, whether this image is signed or not. If the image is not signed, it is not bringing up the pods. So your control plane itself is not coming up with the new version. And we also have maintained different policies like pod disruption and other things, so that the customers will not get impacted by the policies and the new upgrades. Yeah, this is about our overall journey about how we maintaining our containers with our old platforms and the hybrid platforms and the new platforms, and how we are developing and securing our containers from our CI/CD to our customers. yeah, that's all about our talk. Any questions, we are happy to take.
So just for the stream, I guess, is it like a lot slower when you're using like Docker to build like an ARM image on an x86? Like, and if it's slow, is it worth investing in like native nodes for these builds?
So in our case, right? So we didn't have too much of native code that is specific to ARM based. So for us, many layers were common between these two. So the builds weren't taking too much of additional time. Yes, we did see a difference, but it's not like 2x.
Anybody else? All right. Thanks, guys.
Yeah, thanks, Rejekts, for hosting us. Thank you very much.
All right, so we'll take a 5-minute break and we'll do the next talk.
Can everyone hear me? Testing. Hello? Testing. Oh. Testing. Okay. Let me. Okay. Hopefully that comes through. Hi, I'm Jeff. This talk is about talking about identity, authentication, authorization, all the way from Kubernetes to the cloud provider and back. There's a lot of material to get through, so let's just jump right in. Try to keep this zippy so we can get through the afternoon lull. The agenda today is to talk about the relationship between Kubernetes and, I'm going to talk about AWS because that's what I'm most familiar with, but these principles apply to all the major cloud providers as well. There are a lot of moving parts between identity authorization in Kubernetes and their equivalents in the cloud. So we'll talk through some of those components. I would like to also talk about what this end-to-end framework opens up as far as potential vulnerabilities and attack paths. And then so that we don't end on a sad note, we'll talk about some tools and strategies you can use to secure your Kubernetes and cloud providers. So the first question is why I care about this. Increasingly, Kubernetes is your cloud. If you run workloads, if you run stateful workloads on Kubernetes, this Kubernetes, in many senses, is your cloud, especially once you get into things like running cross-plane on Kubernetes, you can directly affect your cloud. So this is a primary entry point, and for, I would say, given certain styles of running engineering departments in organizations, Kubernetes may be the primary entry point to the cloud for developers. So here's kind of a high-level overview of the end-to-end flow. This is a complex process, somewhat simplified here. I won't dwell too long on this so we can get into the individual components, but broadly speaking, you'll have some users or workloads trying to interact with Kubernetes API, which then performs some authorization mechanism to understand what they're allowed to do within the cluster. And then depending on the workload, it may try to interact with some cloud resource. So then there's then some cloud interaction as well. So we'll talk through this. This is a simplified version of what we just saw, but I just wanted to represent it this way so we can focus our discussion on credentials, configuration, and then resources. These are all separate areas for us to focus on and keep in mind when trying to secure our workloads and how users interact with these workloads. But of course, they all interact with each other. This will just help us organize how we talk about this, because especially credentials, as we get later into the talk and talk about these attack vectors, securing these and thinking about what actually has access to our cluster is going to be important. So authentication. Hopefully this is familiar to many of you, but just to set a baseline for everyone. There are many ways of authenticating with the Kubernetes API. A client will make a request to the Kubernetes API, and then whether it presents bearer tokens or client certs, when you're spinning up the cluster and new nodes are being created using Bootstrap token or other means, there will be a variety of mechanisms that we need to think about when we're thinking about securing these clusters. Just to take a quick look at client certs, for example, every Kubernetes cluster has certificate authority, and they can be used to issue client certs. We can bind these to a context for a user, so that when they interact with the Kubernetes API, you can present that certificate to authenticate against the cluster, and then, as we will talk later, get authorization to perform certain actions. But the reason I'm bringing this up is, again, depending on how the organization is set up, this means one more thing to secure. There are certs on some engineer's laptop or possibly some CI/CD system that's interacting with the cluster. But I would say, for purposes of this talk, the most common use case we're going to talk about is bearer tokens, specifically authenticating with your cloud provider, usually taking the form of JSON web tokens. Just as a quick aside, for the most part, we will be talking about OIDC. There are still several use cases that use SAML. Broadly speaking, OIDC is considered the more modern means of doing things. It's JSON, so it's nice. It plays better with APIs, but there are still use cases that require SAML, and you will find certain industries that just prefer it in general. Like, for example, federal agencies, you will find often use SAML more. So everything we've talked about so far has been more or less oriented towards users. How do users interact with the cluster? What effects that could have downstream to the cloud provider? But when we talk about workloads, primarily we're talking about machine users or service accounts. These are the primary mechanism for system components. And just to talk through what the request lifecycle looks like, whether it's a user or a machine user, whether it's kubectl or even a kubelet or controller manager, scheduler, all go through this flow, interacting with Kubernetes API, go through the authentication mechanism, which we've already talked about. Then there's the authorization step, which determines what permissions this identity has to interact with the Kubernetes cluster. Then there's admission control, which is the opportunity for the cluster to validate, possibly modify, inject environment variables, use policies to check to make sure that the manifest or the API request that's being submitted is valid. And then finally, schema validation to make sure that what is being submitted is well formed before being admitted into the cluster. So finally, this is the hopefully more interesting part of the talk. Speaking of authorization, what does this entail? Authorization at its kind of easiest to understand level is who can perform what function on what resource. So we talked about users, we talked about system, a lot of the things you see here, like for example, if I had a user registered in Kubernetes directly, or some of the built-in users for Kubernetes, there are a series of verbs that you can specify. We will talk through some of those a little bit more in detail later because some of them are a little bit surprising in terms of what they can do and how these can be exploited. But these can be assigned, and then those can be assigned one or more in any combination with certain resources, whether that's workloads, secrets, config maps, etc. So just very briefly to recap, when a client is interacting with the Kubernetes API, it is posting some information that specifies these subject verbs and resources, and depending on whether it's a namespace resource or a cluster-wide resource, that will also be used to constrain this. So just to review what this looks like in terms of manifests, when you have a service account that needs to interact with Kubernetes, you will provision your service account. You will create a role that, as we talked about, gives verbs to access certain resources within the cluster, and then you'll bind them together to enable that service account to interact and operate on those resources. Just as a word of caution, as with anything else, whether it's cloud or Kubernetes, you can stack these roles, you can have multiple bindings, and it becomes increasingly difficult to reason about what the blast radius of a particular identity is in Kubernetes. So we'll talk later about some tools that can help reason about this. But just as a visual representation, it's a little hard to read here, but you can see we have a user here that's bound to many different roles. And then at the bottom, again, take my word for it, you can see that it basically has the full spectrum of permissions, even if each of these individual roles was well scoped. So just something to keep in mind when you're reviewing your permissions. Way in the past, the quick and dirty way of accessing things is to provision a cloud user and get an access key and secret and just give that to some workload. You're off to the races. Not good. That opens a lot of potentials for any time credentials are created, they can be exfiltrated potentially. So the modern and preferred way of doing this is through IAM rules for service accounts, or URSA. This is how it looks. You will provision some IAM role in AWS, and then annotate your service account with the IAM role that it is allowed to assume. And then once that service account is available, you can mount that service account on your workload by specifying the service account name. And if you, some things we're about to talk about will be taken care of automatically in the background depending on the tools they use, but I just want to mention explicitly that there has been a tool over the previous several years called KIAM. You also may be familiar with Kube2IAM. These are still out there in the wild. Broadly speaking, they achieve the same thing. The underlying mechanisms are slightly different, but it's the same considerations when it comes to security and things to think about for these authorization mechanisms. So not to get too deep into the details, but as we just talked about, when you're arranging this, you will provision some IAM role that has some policy attached to it. You'll have some service account that you want to be able to assume that role. And then you need to establish a trust policy which enables identities that are external to the cloud to assume these roles. As I said, if you're using a tool like EKSCTL, it will do this in the background for you, but just to be explicit for what this is doing, you will see here what this is essentially doing is allowing this identity to perform this action, STS assume role, with web identity, which we will revisit later. But this is the underlying mechanism for how service accounts can start to interact with the cloud. So just to talk through this in, again, one level deeper, and this will be, I think, the deepest that we go. When you submit a workload to the API server, there's an identity webhook. We talked about the API request lifecycle. The identity webhook will examine a workload that you are submitting, see if there's service accounts attached to it, see if that service account is annotated, and if it is, then it'll perform all these magical actions on the right, which is basically translating that annotated service account so that it can inject these environment variables on the workload, so that when the workload uses the AWS SDK to make a request to cloud resources, these environment variables will be available to that SDK. And again, we talked about the STS assume role in the trust policy, and that's what this web identity token file is going to be used for, and then the role ARN is the role that it would like to assume. So just to note one last thing, you'll notice as part of this process, the webhook has mounted this volume with a token on the workload. As with anything else, when there's a token, that means the token could be stolen. So just to keep in mind, this is there, and together with this information can be a bit dangerous should a malicious third party get access to these things. So just on a higher level, now that we have all this information, how does this work in practice? Well, you have your workload. We talked about the AWS role ARN, the role that it would like to assume, the token that's mounted on the pod. When the workload would like to interact with the cloud resource, let's say S3 in this case, it will send to STS with the assume role with web identity command, that token and ARN. STS will validate that request and then pass the token on to IAM for final validation. The IAM role, the IAM, after validating this, will check that the role is associated with the correct policy to be able to interact with that resource, and then when everything checks out, will ultimately forward back temporary credentials to the workload that are time limited in a number of hours. This is configurable, but generally speaking, a matter of hours to be able to interact with that cloud resource. So after that validation cycle, the pod has the necessary credentials to be able to interact directly with the resource. The bridge between Kubernetes and the cloud has been established. One more mechanism to talk about. We've talked primarily about going from Kubernetes to the cloud. There's also the reverse that happens. We talked before about users, for example, using kubectl interacting with Kubernetes. And if they use AWS SSO login or some other means of authenticating with an identity provider, how the mechanism through which that external identity is mapped back into Kubernetes permissions is through this AW auth config map that is created in EKS. This is close to what it looks like on just a default AWS config map, but you can imagine if you have provisioned users, if you have specialized roles that might, for example, might be viewer only able to interact with certain resources, or kind of full-blown cluster admins, it will use this to map back to enable those users to use the correct permissions and operate on the right resources. One note is that while I will get to vulnerabilities in a moment, but while there aren't that many vulnerabilities that have been discovered out in the wild regarding this config map, it is possible to incorrectly edit this config map and basically break Kubernetes, your EKS cluster. So when operating on this, generally speaking, use tools. Try not to do it manually. So again, we saw this image before. Hopefully you have a better idea of the various components of this. Identities on the left, interacting to get a Kubernetes permission set. and then depending on the process involved, possibly further trying to get access to AWS resources and getting permissions to interact with those AWS resources as well. So now is the fun part. Let's talk about some vulnerabilities. As I mentioned before, there are a lot of moving parts here. The internal Kubernetes moving parts and the cloud moving parts. So we'll start with the Kubernetes stuff. There are a lot of different verbs that you can assign to different workloads. I think what is obvious to many people is trying to lock down your secrets and who can view those secrets, but even things that might appear on the surface to be more benign, like the ability to create a pod or update a pod, are also potentially dangerous depending on what the actor is trying to do. So for example, if you have the ability to create a pod, you may be able to provide host path access to that pod. And that provides the workload with the means to access the underlying node's file system. So if there are tokens or kubeconfig files or anything else on that system, that particular workload may not have anything particularly bad, but it now has the ability to hunt for things laterally that other workloads mounted on the same node may have. Just as a quick example, there were some crypto miners who exploited some of this to create crypto mining apps. They used some of this to mount volumes with privilege because they had the ability to create pods, and then they escaped the containers that they could mine directly on the underlying nodes. This was something that it's kind of funny because these two crypto miners were actually competing with each other, coming in and then deleting the other actors' deployments that they could monopolize the resources to mine more. The next one is something I think is surprising to some people, which is normally when you think about protecting secrets, you think about being able to get the secret. I want to get the secret and then it's base64 decoded by default, decoded and then use the secret. But even the ability to list or watch secrets can expose the values of the secrets in a namespace. So again, something to keep in mind. Another obvious catch is wildcard resource verb. Do not use star or try to limit your use of star on verbs, being able to do everything to a resource or being able to do something to any resource. And then of course, again, another, if you can create role bindings or patch role bindings, then that means you can elevate privileges. So this is just an example. Again, it's hard to read, I'm sorry, but of the list secrets. If you try to get the secret and you don't have permissions, you may get a forbidden response. But if you list the secrets in the namespace, I've redacted it there, but it will reveal the values. There was another case where kubefs is a storage and file system protocol, or I'm sorry, mechanism for Kubernetes that's popular with ML and data science workloads. There was a CVE a while back where kubefs deploys as a daemon set, and the daemon set had cluster roles. And so a cluster role that had the ability to list secrets, which, as we just discussed, potentially exposed secrets across the board for anything that compromised the daemon set. This is, again, this touches on a few things. Number one, there may be access into your cluster that you don't normally think of, like through an observability tool like the Kubernetes dashboard. This is one more reason to use Ursa instead of during AWS access keys and secrets, because it was exposed here. But again, thinking holistically in terms of how to secure a cluster and how people might get access to these credentials is important. Something I just want to quickly mention, EC2 Instance Metadata Service. Kubelets interact with EC2 instances through this service that is link local. So you can just call some URL and get an instance profile with AWS credentials to be able to interact with the node. And V1, it was just straight permission. Anyone with local access could access this and get these credentials. Generally speaking, it was only to access the underlying nodes. But again, there are still things you can do when you have access to the nodes. So AWS introduced a V2 version of this that uses session authentication. V1 still exists by default, so you have to go in and purposefully disable it to kind of close this loophole. But I just wanted to call it out because Scarledeal, which was a crypto mining operation that also did some data exfiltration side work took advantage of this IMDS v1 exploitability. So just to keep in mind that this is still out there, be conscious of it. Thank you. Just a couple more things. I'll just run through this really quick. There are a couple of things to keep in mind, like even your workloads, if they're not configured well, if there can be a remote code execution to extract these secrets. We already talked about tokens are mounted, environment variables are injected. There are ways to exfiltrate this data if these remote code executions exist and the pod has the ability to read files. And then on the other side of this, there's the so-called server-side request forgery. For those not familiar, this is a means by which you can force a server to make an API call that it normally wouldn't necessarily do. And again, through exploiting this, you might be able to call IMDS or interact with the Kubernetes API and extract these credentials. I'll skip this since we're running out of time. I am sorry to mention this, but just because it's been in the news recently, we talked about OIDC and authentication. That can be another attack vector. So unfortunately, Okta had some issues recently. But if you have users that are authenticating through these third-party vector providers, it's something to keep in mind. And then, yeah, so again, talked about this just to emphasize a lot of moving parts, a lot to cover. Then as far as tools to keep in mind, here's a list. Sorry, it's a bit kitchen sink. But the one I want to highlight the most is the top one, because this can get very hard to reason about with all these roles and permissions. AWS has a tool called Access Analyzer that will actually look at your audit logs to determine what you're actually using. So if you have over-provisioned roles, it will help you right-size those roles. And then there are a bunch of other tools that can help you reason about inside Kubernetes, what your RBAC policies are, who can do what. And then as a last line of defense, some things slip through the cracks. New vulnerabilities are coming up all the time. It's important to review audit logs to determine who is doing what in your cluster, so you are familiar with patterns of access. What is abnormal? Are people accessing things outside of normal hours? Are people accessing things they've never accessed before? Things that, are they granted new permissions that they didn't have before? Very important to do. So just to recap, in summary, there's no magic bullet here. This is all about defense in depth. We mentioned some of the techniques here. Something I didn't mention before, if you have a workload that doesn't need to interact with the Kubernetes API, it's just like running something, don't mount the service account token, so you can explicitly disable that. You can also use the network boundary to try to limit access. If someone penetrates and gets these credentials, they just cannot escape Kubernetes to actually interact with those AWS resources. Finally, as we talked about, principles of least privilege, right sizing to make sure that your roles are not over-permissioned. And again, review your audit logs, stay vigilant. Thank you. Any questions?
All right, does anybody have any questions? All right, going once, going twice. All right, thanks, Jeff.
Thanks, everyone.
Yeah, so who here has heard of confidential containers or confidential compute before? Wow, quite a few people. Okay, cool. I mean, we'll go through like all of it, but yeah, I just wanted to know. So here, I'm Suraj Deshmukh. I'm a software engineer at Microsoft. I work on the confidential containers project, and yeah, today, although Microsoft sponsored this travel and everything, but I'm representing the project here today. So, anyways. It's a packed agenda today. We'll look at what isolation is, what confidential computing is, then attestation, containers, and all of that. But yeah, we'll try to go through all of this in 30 minutes. But if not, I'll at least try the left side of it. Okay, so what comes to mind when we say isolation? Any words? Anything on cloud? In context of cloud? What? Virtual machines, yeah. Sorry, say it again. Yeah, inability to affect others. Yeah. That's why platform owners or cloud providers have isolation, right? They want to protect their other customers from from the hostile customers or somebody getting access to their machines or whatever. So it's very much a platform owner's bias. So when I say platform owner, as in any cloud provider or whoever is providing you hardware to run your application, they also want to contain that container or application or function, whatever it is in its that enclave, the way it looks like, right? And of course, they want to do bin packing and all those good stuff to extract the maximum efficiency. So typically, the isolation looks like you have this, whatever cloud provider has this, infrastructure. You may have orchestrator or you're using plain VMs. And this is where app, pod, VM, whatever function it comes in. And the red line is what isolation boundary looks like, right? And then you can get data or application inside it. So that's isolation. Like nobody can get out of the red boundary on the orchestrator level or the infrastructure level. Not in absolute terms, people can get out, if they find some CV or whatever, but that's the idea of isolation. The platform is trying to restrict whatever is inside to not come outside. But what about the outsiders? What about whoever is owning the orchestrator or whoever owns the infrastructure? They can still see it, although they promise that they won't, but they still have the capability of seeing what's inside, right? As in what's inside, as in what application you're running. Even if your data is encrypted or whatever, they might not see that, but they can still see inside. They can do a memory dump or whatever. So that's where isolation has this whole, it doesn't affect the app owner's concern. It's the platform owners what they're addressing here. So what if you want to keep the platform owner outside? You don't want them to come inside. How do you do that? So what's the technical feasibility of it? How do you keep platforms out of your trust boundary? How do you for some paranoid users who cannot risk losing their data, especially if they are dealing with some personally identifiable information? They want to. They don't. They cannot risk losing data even accidentally or whatever. So how do you? So because of that fear, they never come to cloud. They choose to remain on-prem, and that's why they lose on the innovations of cloud. So okay, so how do you solve that? So I guess that's where confidential computing comes in. So before we go into confidential computing, let's look at what confidentiality is. By the way, the image that you see, here you can see there are locks on these doors. So it's a way of showing isolation that nobody can come out because it's locked from outside. And yeah, so confidentiality, it's in the contrast with isolation. I won't say exactly opposite, but it's addressing the concern of app owner. So confidentiality keeps the other apps, users, platforms from looking into what you are doing inside your application. So for a paranoid user, they can still start using this it's for addressing the paranoid users so that they can come to public clouds and also get the elasticity of cloud. And so yeah, I got this image using AI, which shows like a latch, like an old style latch, which you can put from inside and nobody can open it from outside. So it's kind of signifying that. I guess, but that's the only. This is where the analogy between confidentiality and isolation ends. So yeah. Anyways, moving on. So we saw this with this thing before isolation, and that's where confidentiality comes in. Like it's blocking outsiders from coming in. So taking a closer look, like what's confidential compute. So traditionally, what happens is the basic premise is protecting data in use. So generally, when you're doing any processing, like data is decrypted or it's in plain text when it's being processed. In memory, it's in plain text. So if somebody has access to your underlying host operating system, they can do a memory dump and see what's running in those VMs. They could like decode it. I mean, it's not hard to understand what secrets look like, right? If you have a good enough regex, you can decode binary to those secrets. So if somebody has the access to the underlying machine, they can see it. But with confidential compute, the processor encrypts and decrypts the data. It knows how to encrypt and decrypt it. It has keys, and nobody else, even if they get access to that, underlying machine, underlying host, and they do a memory dump, they can't see anything. And so basically, the computation happens in an enclave, which is supported by hardware, as in by the CPU. It prevents any unauthorized access or to apps or data, both. So today, what's the state of data encryption, right? Like we have solved this problem of storing data when storing data encrypted. There are so many solutions out there. Like almost every storage provider has some support of it. We have solved encryption in transit with SSL. Like, I mean, I don't think anybody sends data unencrypted over the internet today. So but this is the last frontier where data was unencrypted. It was when it is being processed, and it's stored in memory. It's unencrypted. So this is where confidential compute has this final cover. Like it got you covered with encryption while the data is being used. So yeah. So how do you use confidential compute, right? So this technology is available in two forms. Like you can encrypt processes memory, and you can also encrypt VM memory. So, but most widely used is the virtual machine memory encryption because it's easier. It enables lift and shift. With processes, like Intel came with the technology first, but then you needed special SDKs to encrypt the memory and use it. But you had to change your developers had to change their development pattern, which obviously they don't like it. So VM became popular because it enables lift and shift. You bring your application as is and start using in VM, and you get the encrypted memory. So yeah. So what are the various offerings that exist? Like AMD has this technology called Secure Encrypted Virtualization and Secure Nested Paging, SEV-SNP. It's available on Azure, AWS, GCP. This is a new technology from Intel Trusted Domain Extensions. It's in a private preview on Azure. ARM also has their own offering. I'm not sure where it's offered today. And NVIDIA also came with confidential GPUs. So even when you're training your models, you can have your data encrypted. So yeah, like I said, like this, all this happens transparently. Apps don't have to worry about how the encryption is going on behind the scene. Processor does it. That's what enables the lift and shift model. And if we talk about AMD's case specifically, so every time a new VM is created, new virtual machine is and confidential virtual machine is created, it generates a private key for that virtual machine, a unique private key. So even if from whatever mechanism somebody gets access to those private keys, they can they'll only have access for that one particular machine. So yeah, any questions so far? I can take questions. Yeah, go ahead. like performance overhead. Yeah. So we'll see in drawbacks, but I can quickly. So the question was, is there a penalty on encryption decryption? So yes, like one of the drawbacks of confidential compute is like you will see some performance overhead compared to the regular computing because it's there. But from the studies that have been done by Intel and AMD, it has found that it's around 10% or less than 10%. So yeah. Cool. Moving on. So, like trusted compute base, right? Like the definition of trusted compute base is like these, like whatever components are needed in computing system that gives you like a secure environment for operations, right? So the bigger the TCB, more problems you'll have. You're exposing more yourself to various types of CVEs and attacks. So in a regular setup, what it looks like, right? Today's stack, you have hardware, you have BIOS firmware on it, your host kernel, host operating system, hypervisor, and then that's where you come in. Like you're trusting this whole thing, like bottoms up. Especially, like these internal components that are provided by a platform, like you have to trust them. And when confidential computing comes in, you have this different hardware, so you can stop trusting everything that's in between. And obviously, like as a guest, you have to trust yourself. But yeah, these internal stack, you can the intermediate stack, you can stop trusting it. This is how it reduces the TCB and then reduces your exposure to various attacks. So what are the use cases, right? Like why would you not trust your cloud provider? Like so, I think it's more than just cloud provider. This type of technology enables something called as multi-party computation, where two parties have different data they don't want to share with each other, and they still want some environment to do their computation. So especially in the AI world, where different people are coming with different models, and they don't want to share with each other, but still want to use each other's technology. The other thing is obviously legal requirements, right? Like with advanced laws that are coming in around personal information protection. So this kind of gives organizations place to click like check boxes. And the next one is obviously like protecting your IP, especially around AI being like today's hype around AI so much. So this technology gives you this additional protection around whoever, around unauthorized access. So so we saw like that like memory is encrypted, but how do you know like it's really encrypted? Like the cloud provider could be just emulating whatever whatever hypervisor calls. How do you really know that it's encrypted? If you own the underlying machine, you could do memory dump and see that it's really working. But that's not the case with cloud providers. You just get a VM. So hostile, like how do you really verify? So that's where attestation comes in. So attestation, I guess, has been talked about term even in this supply chain security. Here too, attestation is important. So obviously, attestation is about verifying the trustworthiness of the environment that you are running in. And so in this case, it's remote attestation. You're not doing like a local check, because there could be a possibility that they give you an altogether different operating system image, emulating the same application that you're running, and then you could just say, oh, this is good, and then you move on. So that's not how it is. You need a remote attestation where you send like evidence that you gather locally. In this case, you talk to the processor, get evidence from the processor, send it to a remote entity. That entity knows how to do processing on it, and then it gives you or NAC, and accordingly you can go forward. A lot of the efforts that are going on in supply chain security are about like reactive processing, like you gather evidence and later if something goes wrong, you figure out what's wrong. Here it's proactive. You don't go ahead until you verify you are really in a, until attestation happens, you don't go forward because it's a risk. You might be introducing or downloading data in an unsafe environment. I think I talked about this remote setup that you have to have. We'll see how, like in a block diagram, how it looks like. So remote attestation in a background check, like background check is a way of how attestation is happening here. We'll see the other way as well. Let's say this is a node with confidential hardware. You bring up this VM or trusted execution environment, and then whatever attestation tool you have inside that machine, this could be part of your boot process. It has to be part of your boot process because then if it fails, you don't go forward. It talks to the hardware, gathers evidence, sends to this remote entity called relying party. So these terms that you see, relying party and all, these are from RFC. It's a IETF RFC called RATS, RATS. It's a protocol that is being defined on how to do attestation, like a remote attestation in confidential computing. So yeah, it sends that evidence, and then relying party sends that to a verifier. This verifier has a logic on decoding this, whatever evidence is. Generally, this package that you see is encrypted with a private key of that hardware, and it can only be decrypted from the public key of AMD or Intel or whoever you're using. So once you can decrypt it, that means it was actually signed or encrypted by the real hardware. Nobody else can do that. So it either gives ACK or NACK. Now what happens after this is completely how you design this whole application deployment. Once you get an ACK, you can either just send out ACK, or it's confidential, and you go ahead and start processing, or you can release something like a key, which you can use to decrypt data that you'll download later. Or the last step can be variable. It can be anything, but rest of it has to be you have to rely on it. The passport model is where like all these components exist. It gets this evidence. It sends to verify it directly, and then it gets a token, call it passport, like real passport, and then you can use this passport to any other relying party, which can use this passport to say, oh, you are really running in you're not spoofed, you are really running in a TE, and then I can give you key or whatever. So this is generally needed when you really want a key. So that's passport model. So how is this technology coming to Kubernetes, right? Kubernetes world. So before we go into that, let's look at this puzzle, right? This technology that we are talking about, it only runs in VMs, and on the other hand, Kubernetes can start like runC-based containers, right? Like it uses Linux technologies, C groups, whatever. But this is only in VMs. So how do you get this VMs to run with Kubernetes? So we need something that can marry these things together, right? Like VMs running as pods and Kubernetes. So I guess that's where Kata containers comes in. So show of hands, who knows Kata container? Oh, who don't know Kata container? Okay, quite a few. So Kata is a container runtime that was started by I think Intel. It's an open source project, and it's part of the Open Infra Foundation. And so the idea is that it's compatible. You can start containers similar to runC, but it starts lightweight VMs behind the scene. So you have this compatibility with Kubernetes. It understands CRI, and then it creates VM. So this is a perfect place where you can enable this confidential containers technology, right? So Kata is part of this whole thing, and confidential containers is a project like one of the aspects of confidential containers is it's a CNCF sandbox project right now. One aspect is to enable Kata to run confidential VMs, and the other aspect is to enable this whole attestation flow that we saw. And the main goal being like enabling confidential compute for cloud native applications. So before you see like how it's really done under the hood, let's look at this. I think like you all are pretty aware of this whole thing. Like there is control plane and there's worker node. Who doesn't understand what's here? I don't think anybody. Yeah. I think everybody understands here like what's this. So we'll zoom in at the node level. This is a typical like regular hardware. Kubelet gets the request, it sends to containerd, which talks to runC, and then your Kubernetes pod comes up. But with Kata, the way it happens is like you have to have a hardware that has virtualization enabled. So you get the same request at Kubelet. Kubelet sends to containerd, then to Kata runtime. But this time, instead of using the local technologies, or using runc, it will talk to KVM or whatever virtualization exists on that node. It will create a VM, Linux guest, and every Kata machine has this thing called Kata agent, which acts like a init process for that VM. And then Kata runtime talks to the Kata agent to start containers inside, which the image is pulled. So Snapshotter is the pretty recent addition with Containerd 1.7, which enabled which allows you to pull images on the host instead of inside the guest, so that you can do image sharing. But yeah, depending on if you are using Snapshotter or not, the images get pulled and the Kubernetes pod starts. So how does it look like with Kata confidential compute, right? So the same thing, you have kubelet, containerd, Kata runtime, starts a VM, virtual machine. There is Kata agent, but there is this, before images are pulled, there is this other two components that come into picture, the confidential data hub and attestation agent. This is responsible for doing attestation. So even before, so in terms of Kubernetes, any workload will start only after images are downloaded. So if you put this whole thing before images are downloaded, the whole attestation piece of it, then you can, at that point, you can decide whether to go forward or stop at that point. So so CDH talks to the relying party, does the whole attestation process, gets a key. Let's say if you are using encrypted container images, then you can block anybody from getting access to them because they don't have the key, as in like you're protecting your IP. So yeah, you use that key to download the container images, you decrypt them, and then the pod is started. And at any point this fails, none of that will happen. Yeah. Moving ahead. So yeah, drawbacks, right? Like there is perceived complexity with all this, but I think from a developer's point of view, they don't have to worry about the attestation piece of it, because you can use sidecars, init containers, and all of that to abstract out the attestation logic. So that can happen transparently. Yeah, there is a complexity on the SRE side because they have to deploy the infrastructure that you saw on the right. But most of the cloud providers have that infrastructure deployed, but then that kind of defeats the purpose. If you don't want to trust the cloud provider, then what's the, you want to host it on your own end. So yeah, and then the boot time can increase because there is this extra network thing that you're doing before it comes up. Depending on how the network is set up, if there is some glitches on the network, things can slow down, but that's minor. And the performance overhead that I talked about, right? Like there is like almost 10% cost that you pay. But I think for greater protection, people who are really paranoid will, kind of accept the drawbacks to some extent. So today, how do you use it with Kubernetes? It's using something called as Kubernetes. There is an operator that can install QEMU and all the required components on each host. And then later it exposes itself as a runtime class. So you start pod, change the runtime class with whatever that name is, and then okay. So I think I have only 5 minutes. I'll jump to the demo quickly. And I'll start this. So I have this demo. Like even this recording is available later. I'll post links to it, and you can access it. So here I'm just showing okay. So what's happening in this demo? Here what I'm doing is I have this. Assume that you are somebody who wants to do AI inferencing. So these models you don't want to be you want to use these models in a confidential environment. So you'll encrypt these models, deploy it somewhere where you can download it later, and decrypt only after successful attestation. So that's what we're looking at here. So here I go into a bit of details of how it's happening. Hold on, I'll move forward. Okay, how do I? It goes into details of how, then I deploy AKS. I mean, you can deploy any Kubernetes cluster, but here it's showing that it's deployed. And then the KBS is also deployed. I think so KBS is what we saw on the right, like which held the key, which did all the attestation piece of it. So in this case, I'm deploying it on the same Kubernetes cluster. It doesn't have to be. It has to be somewhere you're sure that this is a safe environment because you're hosting keys for your data. But yeah, for the demo purposes, it's on the same Kubernetes cluster. And then I deploy something called as a project called Cloud API Adapter, which is part of this whole Coco project. Here I'm doing the client-side stuff where generating keys, encrypting the model. So this repo also has models included. You can include your own model if you want. And yeah, here it encrypts the model, uploads it to the Azure storage. It can be any storage. It just has to be it could be downloaded from within the Kubernetes cluster. That's the idea. And then I deploy. Okay, here I'm just showing. Yeah. Okay. Here you can see I have abstracted out the whole attestation process. Here you can see I'm providing the actual application is Triton server. It doesn't know anything about encryption or anything. It's this init container that downloads. It does the attestation, downloads the key, downloads the model, decrypts the model, and makes it available for the underlying server to use. So in the end, once the models are available, the server is up. I'll directly jump to the here the client is being used where I give it a image, and it tells me it's dog or cat. Hold on. I think I'm almost out of time. So yeah. So here I run the Python client for the Triton server, and it tells me whether it's cat or whatever. So I guess that's the demo. We'll stop here. I'll jump to the. There's so much more content I have to cover here, but I'm out of time. So I'll jump to where is it? Takeaways. Right. So the first takeaway is confidential compute. Remember encrypted memory. Confidential container is an effort to bring confidential compute to Kubernetes. Kata containers is the underlying runtime that's enabling this whole project. And attestation is very important. Without attestation, none of this is useful. And we didn't get to talk about this last piece, so you can forget about it. That's image credits, and if you want to get involved, this is the thing. Also, these are some other talks around this same effort going on at KubeCon, and so questions if I have time.
Any questions?
When I first read the talk the title for this talk, I thought you were going to be talking. I thought this was coming back around to clear containers, which I think was where Kata containers went. How would you? Are you familiar with clear containers? Intel's project. Been a while. Intel clear containers. Yeah. It's a neat one. It overlaps a lot with what you're working on. It was an Intel one, but yeah. It's a neat one. I really like how you presented this. Clear containers was a similar thing, but it was. I think it became Kata containers. It did, yeah. Kind of devolved into it. Yeah. But it was more about making sure the file system didn't change before startup and that kind of stuff.
Anybody else?
Okay. Yeah. So you refer to something kind of with a generalized term. I think it's a relying service, right? So what's the implementation of that relying service on a generalized cloud service? Is a virtualized TPM? Who does that attestation to hand you those keys?
Sorry, I didn't. Well, like, so what's the implementation of a relying service? Like, how?
It's a general web service. It knows how to decode the attestation, verify like it's really a valid thing, and then it's a general web server.
Okay.
Would you say that Spire could be one of these?
I think so. Yeah. But I have to look into it. I'm not very familiar with Spire.
Right on.
Anybody else? Okay, thanks, Suraj. And the next talk will be at 4:30, so we'll see you then. is Let's Talk Community, How to Grow, Nurture, Engage, and Measure. Welcome, Kim McMahon.
I'll take that. Thank you all for joining my talk. I'm not done yet. Okay, anyway, thank you all for joining my talk. As he mentioned, Kim McMahon, I know many of you in this room, longtime open source, marketing, building community. You probably all, if people are like, I know her from somewhere, that will be Cloud Native Computing Foundation, where if your company was a member, I was hounding you to participate more. So anyway, Rejekts, thank you so much for having me speak today. This is a great lineup of speakers. I'm really humbled to be part of all of them. And I always want to do a shout out to anybody who sponsored this event, because for any of us who have worked in foundation and nonprofit and just trying to make enough money from an event to cover it, we can't do it without the sponsors. So thank you to the sponsors. Anyway, here we go. We're going to go on a journey together, and we're going to talk about software. We're going to talk about open source software and other software. We're going to talk about technology adoption. We're going to talk about using your software, helping somebody use your software before they buy anything. And we're going to talk about how we're building a community of users and contributors and advocates, what that means and what it takes. And we're also going to go on this journey in this community. We're going to focus on the users, while we also focus on what our organization needs. And yes, we can do both. So this is why we're going to now talk about the elephant in the room. And this is the elephant in every community builder's room. We don't like him, but she's because she's pink. Companies are in the, we're going to talk frankly, companies are in the business to make money. And they do give back, and as with the company that, the last couple companies I worked for, they gave back a lot. You know, they have a lot of open source contributors, they donate to foundations, they sponsor events, for example, so they do give back. But at the end of the day, that company, my company needed to make money. They needed to drive revenue. And if they don't drive revenue, then they don't have money to help develop new technologies, which is the open source engineers, or the marketing resources and community resources for awareness of projects, helping users get started and contribute, for example, or providing user support. And if we don't see that path from open source or free usage into paid usage, jobs start going away, as we all know recently here, and a lot of those are the marketing community jobs. And some of you might be saying, well, yay, you know, we don't really like marketing and community people anyway, because they're always trying to sell us something. But I'm going to say no, you're wrong with that, because there are many of us in this industry, some of them in this room, who know how to do that, who know how to do it right, where we respect the privacy of the individuals who we are trying to get information in front of. We understand your processes. We know what it is that you're trying to do, and we're never going to sell you anything. And you really do want more of us around. You want more people like that around, and where we're focused on the end-to-end user experience. So now I'm going to do another little pivot, and that's actually product-led growth, kind of in a nutshell. So we're digging a little deeper into that PLG model, and I do want to be clear. I do not believe, nor am I ever going to support, that open source software is around to drive into product usage and drive revenue for a company. That's not why open source was created. But it has a set of benefits that many of us who are in open source, we all know and we live by, things like transparency and collaboration, inclusivity and community. And then you get, you know, open source, you get those benefits of shared innovation and adoption, resources, improved reliability. And with that, the goals of an open source project are to be bringing in users and to get contributors. And bringing in the users at the open source software level is a great first step to give people that hands-on experience with your technology. And the benefit to the project, the more users you have, then maybe you have contributors, and you could be driving your open source project through the different maturity levels. So free and beer or isn't puppy puppy picture number 1. So you have take any open source project. We're at KubeCon, so we can say Kubernetes. They live as part of a foundation who's providing a set of benefits, the oversight and resources in some cases, governance. But there's a whole set of open source projects that I just call it, they're just out there, right? They're not part of a foundation. They're likely either somebody who is just developing on the project, similar to the BioDrop app that I've been showing a lot of you, or a corporation who has an open source project. So for simplicity's sake, we have our users of the project and we have contributors to the projects, and they are individuals, hobbyists, but they're likely part of a company who has an interest in that open source technology. And that company is making an investment in that technology through their employees doing their open source stuff, but they're also making an investment through, as I mentioned, foundations and sponsoring events. And this is that cycle that is building, cycle feeding this whole open source project and this whole open source industry. Corporations are consuming the technology, but they're also giving back, and then they're going to go ahead and they're going to wrap services around those technologies so that they can sell, which then they have money, blah, 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 blah. We already went through how marketing people go away when that doesn't happen. Kidding. Anyway, how this relates back to product-led growth. So this is a flywheel, and if you haven't seen this product-led growth, it really... I kept hearing this word last year about this time. I kept hearing this PLG word, and I'm like, what is this PLG thing? Like, I've been working for the foundation and in open source for so long, I hadn't really heard what that was. So I started Googling. I'm like, this is what we are doing here in open source. So this whole flywheel here is taking everybody on this journey from activation, trying out the project, to adopting it, bringing it into production, to loving it and advocating for it. And how we are helping people do that from a community standpoint is through events and digital events like KCDs and of course Rejekts here, through our digital activities on social media platforms and Slack, supporting people on Slack, for example, by providing the high value content and helping drive people into that open source adoption. And as we do that, so now we're getting into the community stuff. As community managers or DevRel, any of these roles that we're helping people with the technology, we need to continue, make sure that we're doing this with our open source tenets of integrity and respect and openness and transparency, with collaboration, et cetera, et cetera. And let's see. And when we do that, we take people on this journey through content and through transparency that helps them figure out, helps the user figure out what is right for them. So if the open source version is working great, fine, that's awesome. But do they need additional services or features, or they just don't want to manage it themselves? Then through this community process, and through our content, we're helping you realize as a user when you are ready to go ahead and make that purchase. And when you're ready to make that purchase, we're there to help put you in contact with the right people to make that a seamless process. And where this is different, where PLG is different and coming from the bottoms up, and where open source is different and coming from the bottoms up, is we're helping you with that process without selling to you. And many organizations, they have their tops down, and they're going to continue doing that. But what's important with community building is it is all bottoms up, helping you realize what's right for you. Now, when you're going to build a community, you need to define your why, and there's a whole lot of reasons that you may want to build a community, whether it's customer support, you want awareness, you're looking for brand recognition for your organization, you're trying to bring people together, recruiting, whatever it is. Like, we all know the whole reasons why you would build a community. But the important thing is that you need to know why you specifically are doing it. Like, you're not going to do it for all of these things. You're going to do it for maybe a couple of these things, because you really can't effectively do it for all these things, especially when you're starting early in community building. And even after you have started this in community building and you've maybe said, well, I really want to get more users, so I'm going to get more awareness for my project, then you're going to kind of move on to another one of these things within building your community that makes sense for where your community is. And the other thing that we need to make sure when we're building this community is when you define your why, know why your organization wants you to do this. What is it that they are trying to accomplish? Is it a certain number of users? You know, you really need to be tying your community efforts back into your organizational goals. Because when you don't, you really can't prove your community efforts and DevRel efforts are making a difference if you're not doing something that your organization is seeing as a success. So there is a caveat that, and I've had a past job like this, where your leadership may ask you to do something in your community building and DevRel efforts that are not within those open source tenets. And that's where it's your responsibility to step back from that, educate your leadership, and tell them that it's not right. It's not the right way to go about it. We can go about it another way to accomplish your goals. So just because your leadership says go out there and grab all those leads from KubeCon, mine that database, or give them out to our sales reps to sell to, you can step up and say no. And there's a more thoughtful way that we can go ahead and help drive those names that we've gathered at KubeCon into our product use. So I have a couple examples, and these are real organizations. I don't name their names or anything because I don't want to. And but I'm going to give you a couple of examples of community building. And the reason, we'll go back here for a minute. And the reason I wanted to share some examples, because you can start identifying where maybe you or your organization or your team is in maybe building your community or getting more users or getting more contributors. And hopefully this will give you some ideas that you can take back. So this first example is an organization, is a large corporation that had purchased smaller companies that had open source projects. And with many acquisitions, when that happens, a lot of assets, and in this example, the community, the assets just kind of got lost. So they then decided, they said, well, wait, they had a big community, have a large number of users. How can we reinvigorate the community here? But their leadership really didn't know what they wanted to do or what they were trying to accomplish or what that really meant. So these community managers went and said, well, how about let's provide something of value back to the organization that we don't have. And in this case, it was providing user feedback on the product and on the projects. So, and they knew that they had gaps like in documentation and user journeys to fill, and they thought that by talking to them, they could understand how that journey was and see if they can improve it and increase adoption. So it was very simple. Talk to users, give feedback to product management, and put in requests for improvement on documentation and different steps along that user journey. So they looked at just one very easy thing that they could fix. And I put a couple of quotes up there that I always, when they shared that with their leadership, these quotes were just so valuable to their leadership. When you start hearing users say secret sauce, like you can never tell your VP of marketing to never say secret sauce, but when your user says it makes you look ridiculous, they start listening. So the second one is a community. They had an open source project that was at the stage of crossing the chasm. And they knew the technology was good, it was sound, it worked, but a lot of users were reluctant to use it in their production environments because it just wasn't proven. They didn't feel like it was proven. So what they decided, their marketing and community resources said, well, I think we need to spend some time proving out this technology. And they did this through end user case studies by talking to end users, how they were using it, and what kind of results that they saw in their environment when they were using it. such as, improved reliability, decreased latency, et cetera, et cetera. And they wrote up these case studies, they created snackables, tiles, they promoted it, they helped get those speakers at events such as a KubeCon like this or a Rejekts to be talking about the benefits they got from using that technology. And then they took it a step further and started bringing them together to talk about how they were using the technology and how they could provide more feedback back to the project on what was really important to them, as opposed to engineers and maintainers from companies directing the open source project, getting the users together to direct the direction of the open source project. And my third example is of an established open source community. And they were a long time established, drama-free community. Their goal was focused on driving adoption and showing how easy it was to use the technology, their open source version. And then if the user was ready for that enhanced support, how easy it was for them to make the decision themselves and to make that conversion from open source into subscription. So they were not working on this part of it. They were staying at the top. They had typically stayed at the top of funnel just with education, for example, but they wanted to move down into the middle of the funnel, and they did this through an educational product. So they offered a set of education on how to use this open source project, and then how to use this open source project in the environment which their product was. So they believed in this adoption-led strategy model that if you could get people understanding how to use something complicated like Kubernetes with their open source tools, that then when they were ready to move into the product, they made that seamless and easy for them to do. And my last slide. So what I want to really stress to you is that when you're looking at building your community, it doesn't have to be a grand plan from nothing to everything. Take a look at where you are, what you're trying to accomplish, and just do something. Just take one of those initial steps. And when you finish those steps up, then go ahead and move on to the next thing that's going to help your community grow and help meet your organizational goals. So, I do want to stress that as community leaders and DevRel people, I know we have a lot of DevRel and Dev advocates here in this room, our job should not, and does not have to be, and should not be about driving revenue. Our job should be about supporting the users of our technology and providing what they need, whether it's learning or getting started, or providing a platform for them to shine, such as presenting at an event, for their voice to be heard, and to be part of the community. But again, you need to make sure that you've aligned it, the scary part, back to your organizational goals. So with that, I'm done, and that's my princess.
Questions?
Yeah. So in the last slide where you talked about my question is, how do you measure? What's the metric? And especially when the project is new and when you are trying to prove it to your management or whoever, it's not productized yet or whatever. So how do you justify it?
So it's going to depend on your management's goals. Like, what are you trying to, has your leadership bought in on, we want to get X number of new users? Or has your leadership said, we want to make sure that we get X number of revenue that gets driven up from the funnel? So it's going to depend on what your leadership goals are. Like, what are their goals? Is it X dollar amount of revenue? Is it X number of users? Or do they believe that if if you grow your community members by 20%, that's success. So when you know what their success is, you can align your activities and then report your success based on what they see as successful. So do you have an example of one of your leadership goals?
Yeah, I don't think so.
No.
I don't have.
You don't have. He has no examples. But yeah, so a lot of them are going to be revenue, right? So I mean, if we're working for a for-profit corporation, it's going to be revenue. And so if depending on the maturity of your community, let's say you have you at least have a Slack community and you going on, you got people talking out there, and you have a handful of users of your open source project. So what you're going to want to try to do is measure as best you can the users of those open source projects as they move down into your funnel. So your success could be more open source users, and then it could be more contributors, and then you want to try to somehow measure with, hopefully, if you have a good CRM, measure when those users move from open source into product. But it's the other. The hard part. No, it's not hard. The hard part is that there's not one answer that fits all, because it depends on what your organization is going to find important and where you currently are. So if you had an example, then yeah, Ralph. Oh, you need this.
So one of the problems we have, for example, at our company, by the way, I work for Microsoft, so it's a mega corp looking for the funnel kind of experience, sort of thing. But I work in the open source part, and my critical thing is the growth of the ecosystem. And the assumption is that, if we're doing our job right and services support the stuff, that in fact there'll be a funnel. So when you talk about a funnel, you talk about tracking people moving from open source into the corporate funnel. Where's the boundary for you from that perspective, or in this kind of, from different communities and so forth, between, hey, the ecosystem is growing, so that part is fantastic, but then there's this cutoff between the ecosystem and the telemetry or so forth between that and the funnel is generating more revenue. How do you think about that?
Well, so Ralph and the rest of the Microsoft people, as well as anybody, if we have any Google or AWS people, you all are really lucky because your organizations are funding open source. Solo's funding open source, right? So you are really lucky with that. And so in your case, Ralph, we'll get to your funnel question in a second, but in your case, you probably have set saying, I need to grow, I need to have this many contributors, or I need to have this diversity of contributors who are not all Microsoft employees. And that is a measure of success. And there are tools out there. So if you're not familiar with K8s, which is one of the Linux Foundation projects, they have a lot of tools to help you measure that. Of course, Bitergia, and I don't know if they're going to be here at this event, they have tools that will help you measure how many new users, how many new contributors, are they all from your company, as best as they can figure that out. Actually, there's another great tool, Common Room, who also helps figure out who people are, even though a lot of our GitHubs are with our own personal email addresses. So in a case like that with the big organization, they have a mandate to grow the community and continue with their open source, with awareness of them doing open source things. And they do that by showing that they are contributing themselves, as well as growing contributors from other organizations. Now, as people, so how we were going to do it at Cisco, and I say we were, I believe that they're going to implement this, is when we go to something like a KubeCon, this is a developer event and we're not selling, and they go in, if I've had a conversation with them, they get marked in our CRM system as a community-led lead. And then if they eventually buy something, then that will show that their initial touch into any of our open source projects or our free version was via this community. I think we're going to call it a community lead. And that's how we track them. Now, I'm not selling to them. I'm using these people in the database, and I'm providing information to them on a periodic level, a white paper, opportunity to listen to a webinar, come and do a hackathon, come join us for a hands-on lab. I'm providing them opportunities to learn. That's all I'm doing. I'm not ever saying, hey, did you know that you should look at this other product? They will find that out as I'm providing them with opportunities to learn how to use the technology. Did that answer it? Kind of? And it is really hard, and that's why a lot of organizations, as we're seeing right now, I mean, this is a difficult time in tech. As we're seeing right now, there's a lot of organizations that are cutting back on their community and DevRel people because they're not seeing the value. And I'll be talking more to Dawn, Dr. Dawn Foster on this. It's like we've got to figure out how we can show the value of community activities, right? And again, I showed a couple of examples where what's important to my SVP, not what's important to my manager, what's important to my SVP, and try to put the activities I'm doing in something that they care about.
So my another question is, more than question, like you talked about the virtuous cycle of how, companies get involved and then they use the project and then it's helping the whole ecosystem. But I think the cynical side of it is like, the other side is this project is super successful for whatever reasons. If you don't get involved, you're losing out because you may lose potential customers who will ask for this project on your platform. And so sometimes companies are also involved because they may not be able to drive the decision of that project because it may not, if the project takes up different decision and it's not aligning with their company's goals. So, so sometimes companies could be there because they want to control the direction of the project, right?
Did you just say some companies do open source so they can control the technology? Yes, they are, and I was having a conversation with somebody here at this event a little earlier that, yes, there are companies that will want to control the open source project, but as soon as you try to control it, one, we all know who they are and what they're doing. I mean, if you've been in open source any amount of time, we know you're doing that, and we can tell because you've lost your transparency. All your contributors are from the company. You're not open to any other contributions, and let's just say you get rid of your community, open source community person, right? Like you're not serious about doing your open source in a transparent manner that engages the community. So people who are true to open source, we can tell. So yeah, so don't do that. Don't try to control the project.
All right, that's all we have time for. So thanks, Kim.
Thank you.
Our next talk. optimized to Linux? What, how, and most importantly, why? So welcome Andrew and Ralph.
All right. Great, thank you. So, hi everyone, I'm Andy Randall. So I'm a product manager at Microsoft, and I work mainly on Linux technologies within the Azure organization.
And I'm Ralph Squillace. I'm a product manager in Azure Core Upstream, which is next to, not Andy's group. And so Andy specializes in Linux and Linux technologies and so forth at Microsoft, and I specialize in open source application infrastructure, so containers and Kubernetes and WebAssembly. So first of all, we're going to start with why would we even bother with WebAssembly? Now, a lot of people here are Docker experts, a lot of people are Kubernetes experts, a lot of people are Linux experts here. But one of the interesting things is we have to sort of figure out what the space is. Like, why would we even talk about WebAssembly here? And the answer is because for 10 years, we've learned a lot about containers. They're fantastic, right? But we now know that they can be too big. People don't have enough time to go ahead and do it, right? I'm going to just point at you and you click, right? They are also tied to a particular architecture. So you got to recompile or have multiple versions of something depending on the architecture that you're going for. They're also tied to operating system. Now, most people here would normally be using Linux in some way, and so they don't really think that there's another operating system or that there are other operating systems. There's also Windows, because I'm from Microsoft, but there are many operating systems that don't have containers or that kind of infrastructure on them. And those are also great computing platforms. So there's no particular reason we should ignore them, for example. But finally, the thing about Docker is that the container ecosystem brought along the VM and native metaphor, which is the idea that you could make new use of code that always assumed, even whether it was 10 or 20-year-old code, it assumed an entire control command operating system that it can manipulate as it wanted to. And as we've discovered over the last 5 years, that turns out to be an obstacle in a lot of cases. We don't want all code. Some code, but not all code requires a full direct access to an operating system, which containers gave us. So what are we doing about that? Well, WebAssembly is a thing, but we got to take it a little bit seriously. And so I'm just going to go over this. Caleb, raise your hand, he did a great WebAssembly 101 a couple hours back right here. And if you want to dig into it a little bit more, find the video, or just better yet, tackle him outside the door and have him do the whole presentation all over again. But basically, a few short bullet points to get us going. One is that WASM and WebAssembly, that's the same thing. The assembly part, it's not really an assembler language, but it's a language that looks a lot like assembly because it's sort of an assembly-ish format that closely models machine code. And so it's easy to parse and convert directly to machine code. It's one of the reasons it's very fast. By default, it has a very secure sandbox model because it was built in the web, right? WebAssembly. It comes from the browser ecosystem. And so in the browser ecosystem, which is one of the most heavily attacked surfaces in software, it had to have a very secure sandbox. So you can mathematically prove in advance of a deployment that the sandbox and a module will not have a breakout in it, and which is an amazing thing. Most languages compile to it, multi-language. That's sort of a check mark you have to have in the modern world. Obviously, you can put pretty much any language inside of a container, and you've got to maintain that, so you've got to bring that along. It also runs on almost all modern mainstream operating systems and architectures because it was built in the browser, and the browser ecosystem had to put a browser on every operating system you could find. And those operating systems would be built on different architectures. And so it turns out that because of the work that had been done by browsers, WebAssembly, no matter where it is, inside or outside of the browser, actually has this ability to execute everywhere, pretty much, right? And finally, it's got very small size, right? You can compile down. It is essentially very close to assembly, not assembly, but very close. So the size is extremely small depending on the workload, and it can start super fast. Not as fast as native, but strangely, there are some weird edge cases where it actually can be made to start faster and be more performant than native. Those are edge cases, but the fact that it can do that at all in any case is really amazing. So to give you an example from a feature sense, go ahead and start the video. This is just a Kubernetes cluster. So what I'm trying to do is give you a sense for why WebAssembly is actually useful. This is an AKS, could be any Kubernetes cluster. And we've got a bunch of node pools here, but you'll notice that one of the node pools is Windows on AMD. So great, fantastic. One of the node pools is Linux on an AMD architecture. And we also have a node pool that is Linux on an ARM. So this is very heterogeneous. And in normal case, a single container will not run on all of these nodes. You'd have taints, tolerations, labels, the whole ball of wax, right? So in fact, if we deploy Azure Voting, which is it's like the Kubernetes, the CNCF voting app. It's got a back end and a front end, and we notice that depending on where it got automatically deployed to, we don't have a multi-arch build. We don't have a multi-OS build here. And so it only deploys on the 2 Linux AMD nodes successfully. Now that's normal for us. But if we take a WebAssembly, you'll notice it's exactly the same. Duffy, there'll be a test afterwards to see what was different. You should have noticed it. If we deploy a WebAssembly application in Kubernetes, 5 replicas, you'll notice they're all running right away. But look at the nodes. Doesn't care. And it's one module. This is the same deployment. It just deployed wherever, no taints, no tolerations. You saw the YAML. And to prove that that's useful, like that we're not lying about it, watch what Kubernetes does if we go ahead and deploy and delete one of the Linux node pools. Right? Go ahead and delete the node pool. And we watch up here, you can see it's terminating already. We wait for a second, and there it goes, and it all redeploys. I cut it short there, but you can see it redeploy very quickly, and we'll prove it again by deleting the other Linux nodes. And now we only have Windows nodes. And what happens? The containers are all done, right? But the WebAssemblies are all fine. I have just used Kubernetes' native abilities to redeploy, okay? Now Duffy's squinting, so I know he's really focused here. How is this working? We have just redeployed from Linux ARM and Linux AMD to Windows. And most people here at KubeCon will probably think, okay, but I'd really rather redeploy from Windows to Linux. The point here is, it doesn't matter. You can now actually have the application be the same application, right, for any of those things. And suddenly, Kubernetes almost becomes a PaaS. Not quite. It's still Kubernetes. But you don't have to, as a developer, care which node you ran it on. You just have to build one thing. That's really cool. So where is this great, right? So now we can talk about it. The opt-in security stance, by default, denies access to anything on the operating system. That's for people who care about 0 days. Anyone who's going to be closer to hardware calls, right? Anyone wanting to skip the container epoch entirely. There are people who are slow on the cloud native trail, and they're like, can we get past it? Did I wait long enough? We actually talk to those people. Portability, you can see that Kubernetes can become, in a sense, nodeless. You can now opt into that 30% ARM SKU savings without rebuilding all your containers every time. You can just say, yes, I want 30% less cost, or a smaller SKU. And there's OS support where there are no containers. In theory, if Kubernetes runs there, right, you could actually make it work. Size is important for network, storage, and memory costs. They all go down, right? And size is fantastic. The changes can be on the order of 10x to 100x, and I've even seen 200 times smaller than the original container. But it really, again, depends on the language and the workload. And fast cold starts, we've got a new wave of serverless. Kubernetes can become more lively. It can be more active, closer to a real-time reactive operating system, distributed operating system, than it is with just containers. And in IoT, you can add performance to very constrained environments because things are so much smaller and they start a lot faster. The network connection can be flakier or less robust, and you can still deploy in a normal way. So finally, just a couple of high-level things. Kubernetes can reach more places, and it can be used as a scheduler, not just as an orchestrator, right? You can do more, you can take places where there's a lot of artisanal code because it was hard to reach and make that a cloud-native workflow with using a cloud-native binary, not a cloud-native operating system, for example. And Docker files become less necessary, even if containers are the core workload of Kubernetes and the data center cloud. And in short, if anybody is old enough to remember the Java promise, my take is you write once and run maybe 75% of the places. But all of the chips in these buildings, all of the chips in our pockets, is a vastly larger compute space than all the chips we have in data center. Now, Andy has a different bet.
Yeah, we were talking about this earlier. I said he should put 95%, but that's the difference between a marketing guy and the guy that actually understands the technology. But in theory, I mean, this is built anywhere you can run a browser, anywhere, WebAssembly runs in every browser, runs in pretty much any environment. So I think in terms of the way we're thinking about cloud native, it kind of is right once, run anywhere. But Ralph won't let me say that. Another way of putting this is, it is the original promise of Java combined with the value proposition of Docker.
Yeah, that's a good way of thinking about it. Again, I wouldn't get so excited, but Andy is very excited. But sounds great, right? Not so fast. Not so fast. Sure, WASM's great, but it's still hard to find all these little runtimes, all these little WASM tools. They're all new, they're appearing, they're disappearing. And even if you find them, right? Even if you find them, you've got to run the infrastructure underneath it. How do you get things updated? And how do you fix things and so forth? It turns out that's hard. So go ahead and click one more time, because you've got to run production stuff. You've got to manage and deploy a fleet at scale. We know how to do this with containers. How do you do that with these fancy WebAssembly to prevent drift and maintain security? This gets a little bit hard, right?
So, Ralph, these all sound like things I've heard before. I think if I kind of cast my mind back 10 years, if only we could get into a time machine and go back 10 years and think about how did they solve these challenges with containers? Because these challenges were all there with containers as well. So we're going to go do that and think about what did the world look like when containers first came on the scene. Well, the first thing is Docker itself didn't invent the concept of containers. They existed before. All of the building blocks were there. But Docker created this fantastic user experience around it that made it usable. That's what made it take off. So having that in place was super important. The other was we knew how to build containers on a single node. But in practice, if you want to build an application at scale, you needed to build a cluster. How do you manage a cluster of nodes all running containers? Well, we know today the answer is Kubernetes. There was some discussion around that at the time, but today that's done using Kubernetes, and that came out really very quickly after containers first hit the scene with Docker. And then you had this question of standardization. Docker defined a model which everyone loved, but it was very much a vendor-specific implementation. And due to various industry pressures, we created an industry consortium around that and a standard to define what it means to be a container within the OCI. And then the other thing was, in the early days, containers were all built on general-purpose operating systems. And one of the things that the CoreOS founders realized was you could build a container-optimized Linux and not have to use a general-purpose one. Now, what do we mean by that, or what did they mean by it at the time? There's a number of things. The first thing is, if you've got all your dependencies packaged in a container, you don't need them in the underlying operating system. So you can take out 95% of the packages that you have there, just keep the things you need to run containers, and deploy the containers on top of that. So you have a minimal distribution, reduces the surface area for any attacks. The second is you can make that operating system immutable. So the actual file system that the operating system is installed on cannot be modified at runtime. And this has a bunch of security advantages as well as manageability. You want declarative provision. You want to treat your nodes as cattle, not pets. So you want to have config files that defines what nodes look like, and then you can arbitrarily scale your deployments. And the last thing is you want these nodes, if you're going to manage them at scale, you can't go around manually SSHing into each node and doing a node-by-node update. Those updates have to be automatic. And I see various friends in the audience who were at CoreOS who've probably given this pitch to customers 100 times or more. But that was the pitch, and it took off. It was very successful. And in fact, the original idea for CoreOS was the very first container-optimized operating system, but it derived from work that Google had already done, making the laptop scalable in the same way with Chromium OS. So you saw Google introduce the same concept with their container-optimized OS. Red Hat came out with Atomic Host. Then they acquired CoreOS and merged those two things together. And then the team that's now my team within Microsoft took the original CoreOS and forked that, and that became Flatcar Container Linux. AWS came out with their own Linux and for containers, and within Azure we have a thing called Azure Linux that you can run AKS nodes on as well. So there's a whole ecosystem of these kind of optimized Linuxes for containers. So that's where we were with containers 10 years ago. Where's the ecosystem today?
It's not as smooth, shall we say. Go ahead and click. So we're going to use the same schema that Andy had introduced with the container evolution. We started with limited compilers and languages, and I would say even 1 year ago this was still true. We have not reached a full developer UX. We now have VS Code extensions. Every app service has their own developer environment. They're not unified at a kind of generic level. So we do have dwarf support generally, but it depends on language, things like this, right? So it's not a full developer UX. I would go a little greener than my kind of orange checkbox here, but we'll talk about that. And move on to the progress from in-browser only. As we've mentioned, the WebAssembly started in the browser environment. We do now have a ton of general purpose, open source, well-maintained runtime environments. A whole bunch of WebAssembly runtimes are available. It's relatively easy to build a runtime for WebAssembly because of the design and the specification is very clear. There's a lot of good source code to reuse and so forth. So that's actually a darker green, I think, really at this point. If we go from, like, say, hey, you've got a couple implementations in browsers, we now have industry standards. This is the WebAssembly. The icon is really supposed to be like a puzzle piece or something like that. And those standards for core WebAssembly are in the W3C. The oncoming component work that allows interoperation between languages and runtimes across the entire ecosystem is entering various stages in the W3C, and so that'll eventually be a W3C spec as well. So with that ecosystem support and the standards, this is probably more of a green. It may be like the kind of soft green that I have up above. So we're getting better. And then I think we've got this one, but gosh, this one. Yeah.
So this is the point where Ralph gave me a call about 6 months ago and said, we have this gap in the ecosystem. I'd love to work out how we can make WASM easier for folks to adopt and build something that just works out of the box as a WASM optimized OS in the same way that CoreOS was a container optimized OS. So, so we decided, let's do this. Let's build a Linux just for WASM. And we, of course, decided to do that on Flatcar. Why would we do that? Well, it's a community-driven project. So we wanted the results from this work to be something that was out in the community that everyone could adopt. And Flatcar is actually going through the process of being submitted into the CNCF right now. So it ticks that box. Flatcar's already widely adopted. We weren't picking some immature technology that no one used or understood how it worked. It was already pretty widely out there in the wild. Something we've added recently to Flatcar was this ability to build modular builds, so you can customize how you deploy the operating system with additional layers. And we're going to get into this in a lot more detail. And the last point, just to be honest, we had a team who knew it, and we could collaborate and actually get this done pretty quickly.
So let's make it a little bit real. So we'll talk about the process here. So Andy alluded to the modular layer build system. We're going to talk about building individual layers and then baking that into an immutable image. Those who are familiar with CoreOS, this talk will all be like, oh yeah, been there, done that. But it's a great idea, so we're still doing it, but with different tooling. So first you're going to create layers that have your things. This is creating a file layer, right? And that layer will have one or more tools from the ecosystem, right? It doesn't matter, I'm talking about WebAssembly, but this could be any specialized system. You could use this same mechanism to build, say, a Python ML research distribution that only has those tools, for example. But all the operational stuff I show you here would be directly applicable to that as well. So think of it in a larger sense, but we're using WebAssembly as the example that I'm motivated by. So you push your layers to storage accounts, and those can be used on an initial boot. Initial boot, the operating system reaches out, grabs the layer, comes in, unifies it with the base OS image, and then that becomes the immutable image that is run. So you get to configure what you want. You can create, to do that, you create an ignition file. Think of this as a configuration manifest. I want these things to be pulled in on initial boot and not other things, and I want them to be placed here and not there. You're going to deploy locally with a neato script trick, which I'm going to show you. But then when you get to a production quality, obviously that would be in the cloud and so forth. And most importantly, going to have some fun, because you can do this with anything. But I'm giving you a WebAssembly because I think it's really, really cool. And if you're interested and convinced by my pitch, then you'll go and try this out, right? And it'll make it easier for you to do. So, quick digression about layers. For everybody who, for example, might be watching this or watch later and you're not really clear with layers, you might want to be able to move one tool in with one layer. Go ahead and click. When you build the image, that WASM-time layer will slide right into the location that you wanted it at. And so eventually when it executes, your user bin might look like that. Click. So if you want to follow along, there's the repo that has all these recipes. If you're going to bake the stuff, now we need to make a layer, right? Going to clean stuff, download stuff, place stuff. But if you notice, that's pretty much what a Docker file does, right? And in fact, that last one, creating a raw layer file, that's pretty much Docker build, right? Okay, yeah, upload your raw file to an endpoint that your distro can reach. That's pretty much Docker push, right? So here's my Docker pushes. This is Azure blobs. It can be like S3, whatever it might be. Doesn't matter. But as long as it can be reached, you can select any number of those things and mix and match them to your heart's content. If you're interested about this, go look at the repo. This is the list. Now, when you're building your image, you got 3, 4, 5 pieces of bread you want to put. You put them in your ignition file. That gives the bread you love. This is an example. The very simple one. We're going to load the file called Lunatic. It's a WebAssembly that uses kind of Erlang actor style. That tells us where we're going to do it. This particular demo is in WSL. So it's a little bit slower than in native Linux. If you're in native Linux, anything with QEMU, this trick will work. Go ahead and click, and we'll run the demo. What you're doing here is grabbing the image, copying it into the local directory, and then you're going to execute the image with the recipe for Lunatic, the one you just saw. I'm going to have to go ahead and do this. And then the script that we loaded basically kicks the whole thing off locally using QEMU rather than the cloud. If you're familiar with cloud and cloud inits, custom metadata and so forth, you can run the cloud that way. And so right here, we're all loading up. This is first boot. And we're going to get to about 8, 9 seconds. And then it'll freeze. And it freezes because it's now building, it's taken the layer and it's building the layer onto the base image, making it immutable, and then it's going to release the image into execution. Now right there, it takes a little bit longer. You can see it jumps forward a couple of minutes. That's the WSL lag. All of you here in native Linux will be like 8 seconds. So here, we booted in. We can go ahead and type Lunatic. And sure enough, it's there. Go ahead and click through. Now, to make this solid, you can put it in the cloud. You can do it in private cloud, private environments, and so forth. But you need to update it securely.
Now, the actual underlying base Flatcar OS image, we have a tool called Nebraska for doing this, which is an update server built on the same mechanism for Chromium, and it allows you to, basically you have 2 partitions, the running partition, and then you upload the new version into the B partition, and you can switch from one to the other, and if it fails, you can roll back. So it's, and then you have policy and auditing controls, so you can view what's actually happening across the cluster. So for the underlying OS, we have a great set of tools there.
So notice he said that, remember the updating is the base image, and we're talking about, go ahead and click through. We're going to actually show you the update. Down here, we cleared up, and we've installed WASM-time. And we've also used Ignition to configure a reach out for an update of WASM-time only in 1 minute. So we've gone through about 10, 20 seconds, and we keep looking at the version. This part is very boring. It's not an active demo. But remember, when we get to 1 minute, and this is real time, I haven't crunched it down, so it really will take 1 minute, which is great because apparently that's all we have, right? At 1 minute, systemd will reach out to that same endpoint and check the SHA list and see if there is a match for an update for WASM time for this architecture. It's even architecture specific. And when it finds that, we'll see systemd dump out some dmessage stuff because we're all running as root because it's immutable. We don't need users. So right about now, boom. Now if I do WASM version, you notice we've updated conveniently to the new version that is also there. And that's how it works. Go ahead and click through. And we should mention, yep. So what we got to do is how to play, what we want to do is the call to action, standard stuff, which really means please do this and see what you think, right? This is how to play with Flatcar and WASM together. Go to those repos, go ahead and modify the image using those techniques. There's a prod Flatcar and a dev Flatcar so you can see different kinds of usage. Go ahead and push new layers for yourself to use or as PRs. And read about Flatcar and the ignition configuration process. If you like what you see, hopefully any of you can submit PRs back to the same repo in Flatcar upstream and make your recipe part of the ecosystem itself.
Yep, and the thing I wanted to mention there is this update mechanism for system extensions. We're looking at integrating that into the Nebraska experience as well, so you can kind of manage across both the sysx layers and the underlying OS layer. So yeah, try it out because this is something that we're building for the community. We want to drive community adoption of WebAssembly, and yeah, we hope you enjoy it. Thank you.
All right, any questions?
Since we're basically doing a Docker build and we're basically doing a Docker push, can we push those WASM layers to an OCI registry?
To my knowledge, okay, let's do that. So we don't have to repeat the question now. Yeah. So in fact, WebAssembly WebAssembly itself, modules, and then in the future iteration, components and the metadata that goes with them will be and are now available in OCI registries. So you can push and pull WebAssembly modules right now. This particular mechanism of updating doesn't support OCI API right now, but there's no reason it can't be upgraded to do that. So that's actually a great feature to have and add to the systemd checking mechanism. But we don't have it right now.
Yeah, just to clarify, so that mechanism is part of systemd, right? So it's the upstream systemd project that implements system extensions. So it's systemd that's actually doing the HTTP pull of the layers. Right. So I mean, we're very active in that project, but kind of that's where that interaction has to happen.
Any other questions?
This looks great. Seeing all the benefits of the WASM runtime, especially the security, and seeing that the performance is great, do you think in the future it will just replace the Docker containers as we know them today?
Easy question. the question that we always hear all the time. Did anybody replace VMs when we got containers, really? Do VMs not get used anymore? Right, right. No, in fact, so the various technical aspects, I'll even back up further. Really, this is all engineering, right? And so every time we take a technology step, with whether it's WebAssembly or containers, we take a step that helps a certain category of behavior, right? But we actually still run some things on VMs because it's actually better run in VMs. And so what you're going to see is obviously every technology has a feature set that creates some new opportunities and some evolution of current stuff. But at the same time, there are real reasons to run containers. So if you ask me, my short answer is, no, look, in Kubernetes, in big data centers, and when you've got a lot of computing power and so forth, you will, if you migrate to WebAssembly, you'll get, you can use smaller SKUs and it'll be more agile and the whole thing. But the real question is, how hard do you have to work to get there for the particular feature? In most Kubernetes scenarios, containers are going to remain the vast majority of the workload. That's the answer. But we're talking about WebAssembly being able to take Kubernetes to places where containers are actually hard. And so actually, that's the way you need to think about it, as an expansion of both Kubernetes and containers into areas where just containers and Kubernetes don't really fit the engineering setup.
All right, and that's all we have time for. So thank you, Andy and Ralph.
this is just going to be an awareness of a cool project that we're working on called KubeWarden. So a little bit of background on me. I'm Aaron Quill. I work for SUSE Rancher. I'm a cloud native and Kubernetes specialist for them. I live in San Diego, California, so that's normally what I get to see on a Friday night. I have done a ton of different things in computers. I've done technology evangelism for a while. I was a PM over a variety of security products and directory products. I am a home automation fanatic, which we'll talk about in a couple minutes, because we're going to kind of hit on that. And outside of that, yeah, I'm over 50 and I still skateboard almost every day. And I have worked and traveled to over 50 countries, which has just been awesome. This is young Aaron, man. This is me probably about 1981. This is my first computer. That is a TI-99 4A. Anyone, you had one? You know what one is? I had one, and I had the awesome memory expansion box. I had the TI-99, and I upgraded to the 4A so that I could have 4K, right? Because this was actually, back here is when I thought I wanted to be a programmer, right? Because I just discovered computers. I wanted to learn everything about them. I wrote my first computer game on this. I wrote 2/3 of my first computer game on this, and I ran out of memory. Ran out of the 4K, and I was like, I am done. I no longer want to program. Now, here's the funny thing. That computer was very cool, right? The reason why this was so cool, all your friends had those crappy VIC-20s, right? What was cool about this had a 16-bit processor in it, right? And had 4K of RAM, and was a blazing 0.136 MIPS. I gotta tell you how long it took me to find that actual speed, because Aaron, the idiot, was searching for MIPS. It didn't do MIPS, it did instructions per second, right? Cool. So 1.36 MIPS. Now, like I said, I am a home automation fanatic, right? Anybody here do home automation, right? Anybody have these cool little Shelly devices in their wall sockets, right? So I have these all throughout the house. They replace my wall sockets, give you Bluetooth, give you Wi-Fi, give you a web server. That is 200 MIPS, right? There's a lot of math in between what I started on and what we're currently working on. Now, just for comparison, like I said, I do just about everything on Kubernetes at the house. So that's a Raspberry Pi 4. A Raspberry Pi 4 does about 2,000 MIPS. Of course, I run Kubernetes on it. So I have 4 of those boards running, so I have access to 8,000 MIPS at home, which is just, for me, that just blows my mind, just what I've seen in my lifetime of going from what I had in a computer now just being blown away by wall sockets and, you know, computers that are the size of a deck of cards. But this ran into a problem, right? We had young Aaron in 1981 running out of the power and processing and memory of his computer. So what did Aaron do? Aaron looked to use other people's computers, right? And so in the early 80s, I was a computer hacker, right? And did anything I could to access other people's computers. Now, the cool thing is, at that time, it wasn't about taking money. It wasn't about shutting people down. More than anything, it was a bunch of kids trying to learn stuff, right? We really just wanted access. You know, we were breaking into places so that we could read the manuals on the operating systems, right? It was things like that. We were just after knowledge. In fact, if you want to know how serious of a computer hacker I was, my 15th birthday, my super secret computer hacker name, Sir Brocculot, is on the giant cookie, right? So think of how lucky I am right now that the FBI didn't have access to the Great Cookie Company's database in North Park Mall, right? I'm incredibly lucky. Now we couldn't get away with this. It was the dark ages for computer hacking back there because we didn't do anything, right? We didn't have connectivity. We had to dial up. We didn't have the internet. We didn't have anything like that. All that has radically changed now, right? The problem is now we're no longer worrying about kids like Aaron that, you know, there were so few of us that even had access to computers back then that now we have people all over the world, right? All different backgrounds, some of them sponsored by governments, some of them looking for cash, some of them looking to lock up your data to hold it for ransom. We have people all over the place hitting and trying to get access to our data. And then We have incredible services out there to help them. Andrew, I don't know if you've seen this one or not. This is one I've been meaning to tell you about. Has anybody seen Shodan before? Yeah, it lets you go out and look for IoT devices, right? And find them and find what ports they've got open and all sorts of cool things you can do with them. Now, that's only one of them. There are a ton of these. Here's another one that I like called ZoomEye, which lets you search for things based on protocols, right? Or, oh, I skipped it. Sorry, let me jump back. Census lets you search based on IP address and ports and all sorts of amazing things. So now, for me, all the tough stuff we used to do is now bloody automated for the kids, right? So the problem is we have people able to find our open systems. So not only that, this is just like the 3 latest articles that I've read. Probably a lot of you guys have seen them. I don't know if you see, this was a great one that was just saying, look, your entire Kubernetes system and cluster is vulnerable if you have a single misconfigured YAML, right? If somebody can get access to it, they can take over your entire system. Here was another one that was just 3 days ago, and this is a new problem. Did you guys patch your clusters yet? A new thing with an ingress controller, where if you have an unpatched ingress controller, we can get access to etcd and your cluster, which we'll talk about what that means in just a second. And then here's one that just really makes me cry because I thought I was done with Windows, right? And one of the things that kills me is I've been doing Linux and Kubernetes, well, Linux for probably 20 years, Kubernetes from about when it started. And I've avoided Windows this entire time. Now, not only do I have to worry about Windows with Kubernetes, I'm back to worrying about Windows vulnerabilities. This talk was at KubeCon China last month. I was lucky enough to be there and got to met Louis. This was just posted to YouTube last week. They finally posted all the Chinese KubeCons last week. He is releasing a cool utility that if you have compromised Kubernetes, like we just talked about with that ingress, you can go in and modify the etcd database in some very cool ways. Now again, I'm going to show my age here, but does anybody remember something we used to do called Escape 255? Right? One of our favorite things to do is when we would compromise the system, you go create a new user, and for the username, you put in Escape 255. Anybody remember what that is? It's a space without a carriage return. Right? So what winds up is you get a username that's blank, that people don't even notice in the UI that there's a username there. What's funny is, like I said, that's something we were doing in the 80s all the time. You always do Escape 255. It was hilarious to see this talk because he's literally doing the exact same thing. He's giving you the ability to go into etcd and create a namespace with a space and a totally blank name so it doesn't appear, right? So now you can have hidden namespaces that people can't see. All sorts of cool stuff. Go look at his talk. It's, again, this is the problem. We took advantage of your system. We compromised it through a bad YAML or ingress or whatever. Now we can do nefarious things to it. Customers are worried about this, right? This is CNCF. This is 22, so just last year. 44% of people that want to roll out containers haven't rolled them out because of security, right? That's a huge concern. We need to stop this. 97% of customers that they surveyed said that Kubernetes security is hard, right? And I swear 3% did not thoroughly understand the question or they're being lied to by their staff, right? But I mean, that's the honest to God truth. It's, no, man, there's so many working parts. We really have to worry about security here. And of course, another thing, biggest concern is security policy. So what do? The answer, of course, is, what's the answer to everything in Kubernetes, right? It's as code. Right? Or it's not just Kubernetes, it's what we've learned in cloud native. It's as code is the way to go. And why do we want it as code? It's because as soon as we start to treat things as code, it's reproducible, right? We know that every time we run it, it's going to run the exact same way. It's testable, it's scalable, and it's auditable. And what do we mean by that? It's sitting in a Git repo, right? We can see all the changes that people are making. We can check out a copy. We can test against it. We can do everything, right? So now we need a policy platform. What do we need a policy platform to do? We need somewhere to write and store all those policies. We then need the system to be able to evaluate those policies and make those judgment calls. Should I allow this to happen? Should I not allow it to happen? Should I mutate this object before we spin it up or what have you? And then the other key thing to this whole thing is to constantly monitoring, right? You're monitoring not just to make sure that people are compliant with your policies, but what happens when something's not compliant with the policy and all of a sudden you get a whole bunch of alerts, right? You want to not just have your system board turned red, you want to be able to act on those alerts. Now, as soon as we start to talk about writing stuff, what do we get into? The argument that people have been having for 50 years now, what language am I going to code it in? Right? And that's really the problem. We want as many people working on security as possible because we have as many nefarious people as possible trying to get access to our system. So what we need to do is make security not only accessible so that anybody in our company or whatever can write security policies, but we also want it so that everybody can understand them and read them and they're logical and what have you. But we run into this thing, which is everybody likes a different programming language. And everybody has different comfort levels at a different programming language. So what we really want to do is we need the ability to adopt to however people are comfortable coding, right? I've got a person here that's in DevOps. Bob, he's familiar with Go and Rego. That's great. He's in DevOps, especially with Rego. That's going to help us with some of our policy stuff, right? But the problem is we also have Alice, who's one of our top developers. She doesn't do Rego. Rego's so specific to Kubernetes and policies. Why would she know that, right? She knows Go. She knows Rust, right? We've got the same thing with our DevSecOps person, codes in a couple different languages. What we want to be able to do is we need to get security knowledge from all of these people and be able to teach it to our policy system. And it's not only that about what language they're comfortable in coding in. Different languages are more efficient at doing different things. So here we've got a couple different tasks. You know, we might want to validate a service. We might want to, in fact, this is one of my favorite things, right? Create a policy to make sure that any container that's going to spin up is on a full signed image so we don't have, you know, code sliding in that we don't know about. You know, lock down the cluster so that it can only have signed containers. We get here to where we want to do some validation in labels. You could write that in Go, but you're going to have to throw some libraries in and stuff, and it's going to be a little bit of work to use labels where, in that case, it would probably be a lot more efficient to write it in Rego because you're going to be using native Kubernetes labels. Now, what about preventing SSH leaks? Oh my God, how many libraries are there for that, right? People have already done the work for that. So in that case, if I'm writing something there, I'm probably going to write it in Go or C# or something where I'm just going to be able to go steal somebody's library that already is going to check to see if there's SSH keys leaking or whatever. So that's the cool thing, is it's not just taking advantage of what people can develop in, but really picking the proper language based on what your task is. And that's really where KubeWarden comes in, right? KubeWarden's goal is to be a universal policy platform. How am I doing on time, by the way? Cool. When are we over? I should have asked this before, huh? 10 after. 10 after, cool, no problem at all. We're going to be great. Right, so what is KubeWarden? KubeWarden is an open source project that we created at Rancher, but now we have donated it to the CNCF, so it's a CNCF sandbox project. Yay! Cool. It's BYO programming skills, right? Whatever you're comfortable in right now. These are the 4 languages that we've got the SDK in that we're really promoting. But if you go to the KubeWarden site, we are just looking for people to say, hey, can you help do the SDK in this language, right? We're really looking for feedback from people. But right now, these have kind of been the 4 that people are jumping on. So if you code in this language, it's killer. You're going to be able to do stuff with KubeWarden. Or if you know some domain-specific programming. So right now, we totally support Rego, and of course, what's going on with OPA, and we'll talk about that in a minute. And we are working on the ability to do Kyverno and Google's Cell. So those are coming fairly soon. So the cool thing is, again, best tool for the job. You've already got a bunch of stuff written in Rego? Awesome. You've already got stuff and all that other stuff? It doesn't matter. We can go ahead and leverage it and take advantage of it. So how do we make all this work? That's why I was laughing. I just walked in and I saw a lot of you guys were here in the previous session. I walked in at the end of the last session. I was like, man, this is awesome. It's going to make my session a lot easier because he's talking about WebAssembly, right? How do we make this whole thing work that you get to code in whatever language you want? It's WebAssembly, right? So I get the ability to code in whatever language I want. We then build it, compile it using a WebAssembly compiler, and all of a sudden we can run on whatever we want. This is technology that came out in 2019, and it was really for browsers, right? In fact, what was cool is one of the first things that I saw, actually the first thing that I saw was Space Invaders, because somebody ported Space Invaders that you could plug into a browser as kind of a proof of concept, which was awesome. But then, I love this, they took the source code for AutoCAD, right? AutoCAD did this, no one nefarious, took the source code for AutoCAD, all they had to do was fire up their compiler and save it as WebAssembly. So now what happens? That's why all of a sudden, about 3 years ago, we were able to do AutoCAD in a browser now. And it's not that crappy stuff, it's like full-blown AutoCAD running in the browser. And that's really what's given us, it's given us this ability to do portable apps that truly are cross-platform and everything. So what did we do? We're using the exact same technology, but we're sliding Kubernetes in there, right? So we're taking advantage of WebAssembly. It gives us the ability to now write your policy in anything you want, right? Well, in these 4 languages, as long as that contains everything. Compile it, and then we can run it on your cluster. Doesn't matter what the platform is. Again, we get all that cross-platform stuff so that all of a sudden now that we're supporting ARM and we're supporting x86, now we're supporting Windows, right? That's the cool thing is all those policies can work on all the different platforms. And what is cool, as far as security goes, it's like a container running down on the machine, right? So we've got nice security. There are a couple things done specifically to make it secure. It is complete in a isolated runtime, right? So we've got it over there. It's running in a Linux container, and each one is in their own runtime. So we don't have to worry about security nearly as much. You can think of them each as tiny little VMs that are just doing a very specific task. And they're just containers. So what does that mean? We get to shove them in a registry, and we get to take advantage of all the normal stuff that we can do in registries with security, and can use that to move stuff around. And we also have the ability to go ahead and import from a variety of different systems, including taking native OPA policies that you may have already created, stuff from Gatekeeper, what have you. We can just go ahead and import those and run those as is. So how do policies work? So I've got a cluster here. I've got a couple different policies defined in KubeWarden. Now, what's going to happen is a policy is enforced when it's created, updated, or deleted, right? So it's only when a change happens that we're going to enforce a policy, and there's a reason for that we're going to talk about in a minute. So what's going to happen is I'm going to go try to do a task. It's going to check to see if it passes the policy. The policy is going to process it, and then there's a couple things that policy could do, right? It could accept, reject, or mutate. Now, what do we mean by mutate? Earlier, I talked about only wanting containers that are signed in my environment, right? This is a great example. I can search and see if you're using, some Python base image that I don't want you to use. I could swap that out and have you grab our BCI Python image that's solid, that's secure, that's locked down. You know what I mean? So you can do those live swap outs, live changes of whatever you want as you go. And we have 2 different modes, which is really cool. We have a monitor mode, in which case, when something is wrong and it doesn't meet the policy, it's going to notify you, but let it happen. And then we have a protect mode, which when you turn protect on, that's when it's going to actually do these accept, reject, or mutate. So you have control over that. Now, I said it only happens when it makes a change to Kubernetes. That's important, Because think about this for a minute. What we don't want to do is put something in place that says, okay, you can't run a container as root, right? Common thing that we're going to do. But the problem is Andrew back there 3 months ago released a container that was as root that's running a web server that we use internally, right? The problem is this stuff is only processed live as you go. So what is going to happen to his container when he reboots it? It's running fine. Everything's great. We put this in place 3 months ago. He reboots it. It's going to all of a sudden not be able to be recreated, right? Because the policy is going to be enforced. It's going to say, hey, this has root policy. I'm not going to let it run. So what we've done is we've just come out with a new capability. And what it allows you to do is not only run these at execution, but also go ahead and run them against existing containers just to get a list of the containers that are going to be hit by that policy and how they'd be affected. You're not actually going to apply them in place because you could have catastrophic things, but catastrophic? That's not even a word. Catastrophic, dude, it's late. You could have catastrophic things happen. So what's nice is we can produce a nice list of all the running containers, how they would be affected, and then you go make a choice as to what you want to do. Right? Do you want to fix them? Do you want to reset those containers or what have you? So lots of different options. Wow. An example, and this is the key. I'm not going to get into this. The key is, dude, that's just Go code. Anybody who writes Go sees that and can totally see what's going on. I got the exact same thing here with Rust code. There's nothing special. This is a mutate call, but it's very, very easy. Anyone who codes in these languages is going to have no problem doing it. We also have the ability to just directly go and compile your existing OPA and gatekeeper stuff directly into WASM policies. And then, of course, we have Kubernetes integration, right? This is our cluster administration policy. What's cool there is that allows you to set up policies that apply to the entire cluster and then namespaces under it. You also have the ability to create admission policies, which allows you to assign a user to do policies just to a specific namespace, right? So you can either assign stuff cluster-wide or to specific namespaces. And of course, we have integration with telemetry, right? So you can directly integrate with Grafana, with Prometheus, be notified when you're having problems, as well as integration into Jaeger. And we're going to finish in 2 minutes, no problem. As well as integration into Jaeger, right? And here's one of my favorite things. I'm not a developer. I don't code at all. I like to say I don't program in a lot of languages, which really means, like a lot of us, I can open up somebody else's code and tweak it a little bit, but I don't like coding directly from scratch. I like taking existing stuff. And that's one of the things that I absolutely love about KubeWarden is there are now over 35 policies sitting up on Artifactory that you can just go grab. And it's all the existing PSP stuff that was already in there. It's already stuff like what I was saying with the SIG verification on containers. There's 35 of them already pre-done and ready to go that you can just grab, tweak, and modify. Sweet. And because of time, I'm not going to go through the install. But the key is, if you're on Rancher, it's point-and-click install. It's just an extension for us. If you're not on Rancher, it's like 3 commands, right? You install cert manager and you do a Helm install, and you'll be able to play with it. We will, at the Rancher booth, we will have some people who can talk about KubeWarden if you have questions throughout the week. And I'm looking in the back of the room to find out if we have a CNCF KubeWarden booth here or not. Do you know? I'm looking at you, Robert. Okay, I thought someone from KubeWarden was actually going to be here, but cool. And I ended right on time, exactly on time. Any questions before I go drink beer?
I have one question.
Sure.
Okay, so now, does KubeWarden, if I have a dozen Kubernetes clusters in a company, like, you know, if I have multiple Kubernetes clusters in my company, like dev, pre-prod, prod, and geographically distributed production environments,
Yes, I did. I don't remember it off the top of my head, but I can get that later.
So there's a quick start charts, there's videos, there's all sorts of stuff to make it super easy to start to consume this stuff. Cool. Any other questions? If not, thanks. Beer, yes.